Hi, and thank you for taking this course. This will be quick, and I'd recommend just sticking around and just ignore the urge to skip ahead. This introduction is aimed to give you some pointers to more easily navigate the course and hopefully help you avoid issues. During the course, we'll be using different assets at various stages, and the asset folder is available here. Download and unzip this. Probably best, set up a project folder now and store all your files relating to the course inside, including this asset folder. I try cover a lot of content during my lectures and will be moving very quickly through the content. When recording, I try to clearly detail each step I take during the process. On the bottom right of the screen, the keys I press and the values I input will be displayed. These are there so if you do miss what I say, the keystrokes can help you replicate every action I take. You may have to pause and rewind often while following the course. There are some very useful controls on Udemy that can help make life a little bit easier. If we come to the gear icon and open the keyboard shortcuts, here we have a list of shortcuts. These can be used to quickly control the video playback as you watch the course. Play pause, for example, is spacebar. The next shortcut, Shift plus left arrow key, is to slow the video playback down, and Shift right arrow to speed it up. More importantly is to go back 5 seconds here, and that's just the left arrow key. There are other shortcuts you can familiarize yourself with here. Now, one thing to note is that if you are working in Blender and you want to rewind 5 seconds, for example, you need to make the video player active. In Windows, you can switch to another application with the shortcut Alt plus Tab. This will open a preview of the applications you have open, and then use the Tab key to toggle along the available ones. So if you only had Blender and Udemy open, you could quickly jump back and forth. In this case, I have OBS recording the screen, so I do have an extra app to toggle through. I can X this down. These can greatly improve your course experience on Udemy, and I do recommend spending some time to learn them. You can also adjust the video quality from the settings menu here. If you find the quality reducing, you can manually set it to the highest quality available. However, if your broadband speeds are low, the quality will reduce automatically. This can be frustrating, so just be aware that this is an issue. To manually adjust the playback speed, you can do that on the opposite side here. The default is 1 and 2 will increase the speed, where 0.5 will reduce the playback speed. If you come across any issues during the course or have any questions, please leave a question in the questions section and I'll do my best to respond quickly. Udemy have this great search function available here. Use keywords from your question to get the answer quickly. You will probably find the answer has previously been answered and you can continue through the course without further interruption. During the course, Udemy will ask you for a review, so if you have a sense of the course and have the time, please do provide one. You can always change it at any time. Your feedback and review are essential, and I appreciate all comments and reviews. That's it for the introduction, so jump into the first lecture, and I hope you will enjoy the course. In this video, we look at where you can get your copy of Blender and the installation process. Let's get started. To secure your copy of Blender, we can come to blender.org. From here, we can open the dedicated download page. Here, you will find the latest stable version of Blender, which is heavily utilized by production studios. This particular version enjoys long-term support and is systematically updated for 2 years. So whether you are a production studio or an individual embarking on an extended project, this version will continue to receive crucial updates, patches, and bug fixes aimed at maintaining hardware compatibility. If you require a different version, there is an alternative. Click on the drop-down menu to select the version that aligns with your needs. Blender accommodates a trio of operating systems: Windows, Mac, and Linux. Should you prefer managing your applications via other platforms like Steam, Snap, or the Microsoft Store, relevant links are made available on the same download page. To explore this, right-click on the given links and choose to open them in a new browser tab. Now open this newly spawned tab. If the Microsoft Store is your chosen platform, Blender can be effortlessly downloaded and managed from here. The same benefit applies if you are utilizing Steam or Snap, and these platforms facilitate the automation of updates for Blender. Let's come back to Blender.org's download page. An often overlooked feature of Blender's official website is its comprehensive archive of all previous software releases. If there was a previous feature that interested you or you find yourself feeling nostalgic, click to navigate to the section listing these releases. Here, every previous release of Blender is available to download. These archived versions contain all types, including zipped folders, that can be run directly from their extracted folder. Having explored this, navigate back to the download page. We are now ready to download and install the latest stable release of Blender. So let's click Download Blender. For the purposes of this demonstration, a Windows desktop is the platform of choice, although the installation process remains standardized across various operating systems. This could take a few moments, so I can speed this up. Once that completes, I can drag in a file browser with the location of the Blender download. This file serves as the installer, so we can initiate the installation process by double-clicking on it. This will guide us through the installation process, so I can click Next. Then we need to read the user agreement and accept. Now click Next. Here you can specify an installation location. However, the default typically suffices, so we can click Next. Now click Install and grant any necessary administrative approvals that may be prompted. The installation of Blender will commence, and I can speed this up. Once that completes, we can click Finish. Upon successful installation, a Blender application icon will be available on your desktop, so we can double click and launch Blender. This opens up into the splash screen. If this is your first time with Blender, the splash screen offers initial settings that can be later revised in user preferences. Here you can set the user interface language, opt for keyboard shortcuts from the previous Blender 2.7, or choose industry-compatible shortcuts akin to software like Maya or Max. For this tutorial, settings will be retained at their default Blender-specific configuration. Your selection preferences for your mouse, either left or right, can be set. It's worth noting that releases prior to Blender 2.6 defaulted to right select, but left select is generally the standard. The spacebar is mapped to play and pause functionality. The theme of the Blender interface can also be adjusted here. For instance, a preset like the Blender Dark theme is a viable choice. All these user settings can be modified at any time in user preferences, and we'll be looking at these in subsequent videos. We can click Next, which reveals the splash screen that greets users upon launching Blender. This interface allows you to select the file type you wish to work with. General will be employed in this instance and serves as the default setting. The splash screen also grants quick access to Blender's official manual, or if you want to support Blender's development, you can do that with the link provided. To immerse yourself into Blender's working environment, we can click into the scene. In this video, we look at changing interface settings in Blender. Let's get started. In our previous video, we saw how these initial settings such as left select, play pause, or the theme could be adjusted on setup of Blender. This was just an illustration of the numerous customizable features in Blender. Note that these options won't be available after the initial setup, but can be still accessed in user preferences. To begin, we can left click into the scene and close the splash screen. Incidentally, to open back up the splash screen, come up to the Blender logo and find that button here. To open preferences, come to the Edit menu and down to Preferences. We can begin up top in the Interface tab, specifically focusing on the resolution scale. By clicking and dragging in the resolution scale field, you'll notice the text on screen enlarging. This not only aids you in following the videos, but also helps me see what buttons I'm pushing. Adjust that if you feel it improves Blender's ease of use. If you do change a setting, but later decide it's not what you expected and need to change it back, don't panic. Simply hover the cursor over the field and press the backspace key to reset the value back to its default. In this case, a value of 1. For this resolution scale setting, I'm going to left click into the field and set this to 1.3. I find this amount increases the text sufficiently for me and should make it easier for you to follow along. Next are the tooltip settings below. In Blender, if you hover the cursor on a button or property, will prompt information to appear, providing a short description. Additionally, the Python tooltip shows the Python reference, useful for getting tips about buttons and properties. Further on down here we have translation. If English is not your first language, then below you can change that from the drop-down. Then have that effect tooltips interface and new data settings. The remaining default settings are fine here. Next, we can move on to the Themes tab. Up top, from the preset drop-down, choose a preset theme from the menu. This will change the entire interface color scheme. In addition to that, each interface item can have their color properties modified using the menus here, allowing you adjust the color of every aspect of the Blender interface. Let's move on to the Input tab. When working in Blender, a 3-button mouse is recommended, but a 2-button mouse can also work by enabling this option, Emulate 3-button mouse. This emulates the middle mouse button functionality using the Alt key and left mouse button. Enable this option only if you have a 2-button mouse. The middle mouse button is used to rotate and it can be difficult to work in Blender without that functionality. Next is the Navigation tab. The first setting we can enable is Orbit Around Selection. This makes your selected object the center point when orbiting in object mode or when in edit mode, whatever part of the mesh you have selected. Really important enhancement to navigation that allows you to get in close and work more accurately. The second option here is Auto Perspective. This one I usually disable. This setting automatically changes the view to perspective after you leave an orthographic view. I prefer to remain in an orthographic view and manually shift my perspective if needed. Feel free to leave it at default, it's just a setting I like to disable. The final setting in navigation is Zoom to Mouse Position. This sets the cursor as the target when zooming, another great enhancement for navigation. Next, we can open the Key Map tab. We previously looked at these on Initial Setup. Up top, you can choose a Blender key configuration or industry standard. If you have come from another 3D software, you might prefer to use that setup. Setups like Maya or Max. I'd recommend the Blender configuration as it's set up for convenience and speed, and also will make it easier to follow along with the course. Next, you can also specify left or right selection. For the spacebar action, choose between Play, Tools and Search. The default Play works well as it's industry standard. Shortcuts are a major productivity enhancer in Blender, and down below are all the key bindings listed. If we expand the 3D view and 3D view global, every shortcut is listed for the 3D view. The first binding here is to Set 3D Cursor. Here we can see when the right mouse button and the Shift key are pressed, this command executes. This is where you can discover the available shortcuts or change shortcuts. If we scroll down to the very bottom of this tab, here you can actually add and assign your own shortcuts for the different commands. As we are seeing from user preferences, Blender is very customizable. I usually leave these at default in the 3D view as the shortcuts work well. However, I do add additional shortcuts within the video editor to help speed up my workflow. Let's move on to the System tab. The first setting we can look at are the number of undo steps. As we all know, these are really important in any program. In Blender especially, you can use up your lives very quickly. Increasing these, however, will lead to higher memory usage. 256 is the max, this value can be increased, and I usually set this to 100. That number generally provides enough headway that you feel confident experimenting at times. Next, we can open the Save and Load tab. Here we can look at the recent file number. This is the number of recent files that get displayed in the file menu. I find 10 too few when trying to open recent files and usually increase this to the max 30. Finally, we have the file paths. This is where you set up the source folders for the different file types. These include fonts, textures, scripts, sounds, and output files. That way, Blender will open directly into these folders. In the render area, the images you render out can also have the default folder set up here. Blender does create a temp folder by default, but you can specify one here. Applications can also be linked. An image editor such as Photoshop or GIMP can be set up to open from Blender. Finally are the asset libraries. Here you can set up paths to external asset libraries. Essentially, these are blend files that store assets. These can be models, materials, brushes, lights, cameras. Multiple libraries can be added that allow assets be dragged and drop into the scene. There will be a video on using asset libraries later in the course. That's it for the settings. Blender will automatically save any changes you make in preferences in future. That is, once the Save Preferences checkbox is enabled in here. Now the next time you open Blender, these changes will have been saved. We can close Preferences by clicking the X. The final thing is to save the file. You hear this with all applications, but do make sure and save your file often. Also, save incrementally. Blender provides a useful feature for saving incrementally, so no excuses. It's also a really good habit to get into. We can first come to File and Save. This opens a file browser. Another useful habit is to set up a project folder for the course. That way you can save all files in the same location. So let's navigate to a location where you will store all files relating to the course. Here I've created a new project folder. Inside, for example, I have the asset folder from the course resources. Later, as the course progresses, more folders for the different file types can be added. These folders can be created when needed, but the important thing is to keep all project files together at the same permanent location. That way, files aren't deleted or moved independently and links don't get broken. So now is a good time to set up your project folder. Name the folder something you will recognize. Inside this project folder, we can create a new folder to store blend files. Rename this one Blend Files. Double click inside here. In the name field, choose something that makes sense, but make sure to add an underscore 001. Having the underscore 001 not only helps you recognize the most recent file, but also makes incrementing easier. Now click Save Blend File. Then, to use the great feature Blender has for incrementing files, come back up to File, and this time choose Save As. This opens back up the file browser. The name field is highlighted red to indicate this name is already used, and we'll save over this file unless the name is changed. At the back of the name field is a plus and minus. If we click the plus, the suffix underscore 001 increases to underscore 002. That way, as you follow the course, you can easily save incrementally. Really important. If for some reason your file becomes corrupt or you encounter another issue with the file, having saved incrementally and often will allow you to take a step back without losing hours of work. We can click Save As. Now you know how that works. The next time all you need to do is come to File and down here to Save Incrementally. Blender will increase that file number by 1 automatically. This video sets out to explain how to tackle the various challenges. Each challenge relates to something we covered in the previous lecture. Let's take this first challenge and look at how you can start solving it. The text lecture outlines the challenges within the blend file. So from the resource folder, download and open this file. This was created in Blender 4, so make sure that you are using a version of Blender 4 or above if taking the challenges, or you may encounter issues when opening the file. In the 3D view, we are in a top view to start with, and each challenge is listed. Each one also has a hint that might help. If you leave this view, use the gizmo to switch back and the text will be visible again. Below here in the text editor is the Python script that will create the buttons and check if you have solved each challenge. Make this a little larger. This is behind the curtain stuff and needs to remain unchanged, but we can take a look before running it. At the start, it's importing the BPY or Blender Python module and the sleep function. Next, some assignments for the challenge and solved messages. Next is a class that creates the panel that will get created on the sidebar. After that, the following code does the check when you press the buttons, and finally at the end, the sound function. Let's come back up to the top now. To start this off, we need to click the Run Script button here. Then on the sidebar, shortcut N, a new tab was created called Challenges. Here, 3 buttons were created for each of the challenges listed. So if we take the first, have a read and try find the solution. So if you figure it out and then click challenge 1, Once solved, the sound will play and the text will update to say you solved the challenge. Then you can move on to the next. Otherwise, the text will remain unchanged and you need to continue trying to solve the challenge. That's it for this introduction to the challenges. If you encounter issues or have any feedback for improvements, send a message or leave a question and I'll respond as soon as possible. In this video, we look at enabling add-ons in Blender. Let's get started. The next step in setting up Blender is to enable the add-ons we'll need for the course. In Blender, add-ons are Python scripts that add functionality, enabling a multitude of varied tasks. To begin enabling these add-ons, press F4 to open the File context menu. At the bottom, we'll find an option to open Preferences. Inside Preferences, let's navigate to the Add-ons tab, where every available add-on will be listed. If you need to understand more about individual add-ons, simply expand the corresponding tab. Each has a documentation link to give you thorough information. The first add-on we can enable is close to the bottom, so grab the slider on the right and drag down towards the bottom. Our target is the Loop Tools add-on, situated under the letter M for Mesh and labelled as Loop Tools. This add-on grants additional mesh editing functionality, which are vital when editing in edit mode for more efficient mesh object modification. To enable this specific add-on, place a checkmark in the box here. If you wish to disable it later, just remove that checkmark. Further information can be obtained by expanding it and reading the associated documentation link. In the location field below, you will find the location of the add-on. It is located in the Edit menu of the sidebar. Below in the tab category, the name field here is customizable. You can designate a custom tab by entering a name. So let's come to the sidebar. Click the button to broaden the sidebar or use the N key to toggle it open and closed. Notice that in object mode there is no edit menu, so you must be in edit mode. Therefore, select the cube or any mesh object and switch to edit mode from the mode menu up top here. Now the edit menu on the sidebar displays the Loop Tool add-on. Let's create a personal tab for this add-on in the sidebar and call it Loop Tools. Let's return to Preferences. In the name field, simply rename it Loop Tools. Instantly the tab name updates to Loop Tools. One more add-on we'll activate is called Node Wrangler. So let's come back to the add-ons tab. It's located a bit further on down, so scroll until you find Node Wrangler. Should you face any difficulty in locating any add-on, there is a search feature up top. Input Node Wrangler and it should appear listed. This particular add-on plays a crucial role when working with materials and configuring textures, as it simplifies the texture node setup. Take the time to read the documentation for more insight into this add-on. Below you'll also find a hotkey list, so be sure to try some out. That's it for enabling add-ons, but as we progress through the course, we can enable additional add-ons as they become necessary. Let's close Preferences. When many add-ons are enabled, the sidebar can get crowded out with tabs, and that's where the add-ons filter can help you manage the add-ons more effectively. Press Tab and switch back to object mode first. In the Tool tab, expand Workspace. Here we can enable Filter Add-ons. This will set all to disable, and then you can enable the ones you need in the current workspace or blend file. Just be careful, as when the filter menu is enabled and the add-ons are not checked on, they will not be available. In this video, we look at how to manage and recover files. Let's get started. We previously looked at saving your file, then saving incrementally. This can help avoid losing large amounts of work. That is, once you remember to save regularly. Sometimes crashes are inevitable, or even accidental closes without saving, especially after hours of work. These moments, the next two features can truly save your project. They stand out as valuable functionalities within Blender and are worth taking note. The first feature comes into play if you quit Blender inadvertently without saving. There is a way to recover the last closed file immediately. To do that, come to File and down here to Recover. Then use Recover Last Session. This action will promptly reopen the last quit blend file. This feature could very well be the difference between losing your hard work and recovering it intact. The second feature becomes relevant when Blender crashes or shuts down unexpectedly. In that case, you are relying on the autosave option. Autosaves are essentially blend files stored in a temporary folder on your system. Blender will create this temporary folder on its own unless you specify one in Preferences, a topic we covered earlier and will revisit shortly. The autosave feature is set to automatically preserve your blend file every 2 minutes by default. Moreover, you have control over this autosave duration from within Preferences. Let's explore this further by clicking Autosave. This opens into the temp folder and the previous autosaved blend files are listed. The file path is conveniently visible at the top. Also, the time and date stamps associated with each file serve as helpful reference when identifying the file you need. If you double click on any of these files, they will open up. We can cancel this and come back to Blender. Let's investigate where to adjust the autosave duration and where to define the temporary folder's location. Press F4 to open Preferences. We can open the Save and No tab. By default, the autosave feature is active. Blender will save the blend file based on the frequency value displayed, ranging from 1 to 60-minute intervals. With it set to 2, Blender will automatically save the file you're working on every 2 minutes. One caveat, however, is sculpt and edit mode data are not included in these saves. The recent file value we looked at in an earlier video and sets the number of recent files available to you from the file menu. This can be as high as 30, but for me, keeping it below 20 is always a challenge. Related to the first feature is where you accidentally close Blender. A save prompt will ask you for confirmation, a handy safety measure. Therefore, it's wise to keep this enabled. Additionally, you have the ability to save multiple backup copies of the blend file when performing manual saves. The default is 1, but sometimes more is better. Adjust the value below here to either increase or decrease that number. To designate the location of the temp folder, open the File Paths tab. You have the flexibility to set the location for the temp folder or simply adhere to the default location that Blender refers to. Typically, it's convenient to stick with the default, unless a specific location is needed. So the next time Blender closes unexpectedly, check the temp folder before you panic. Really great feature, particularly for those rare occasions when Blender crashes. At this point, we can close Preferences. In this video, we look at shortcut keys and where to find them. Let's get started. As we move through the course, you'll be introduced to the most commonly used tools and commands. You'll find all available tools and commands within the different menus. The Object menu, for example, has object-related commands. So to duplicate objects, we can click Duplicate Objects. This makes a copy of the cube and I can move this across and position. So every time you want to duplicate an object, you'd come to the Object menu and use this command. However, you may have noticed alongside this command, the shortcut key Shift+D is displayed. So rather than clicking Duplicate Objects from the menu, we can press Shift+D and duplicate this way. Using shortcuts is a much faster way of working in Blender and will become part of your workflow very quickly. This means, however, you will have to remember the key combinations. To make this a little easier, I have created a shortcut guide to help practice and memorize these key combinations. I try update this regularly and the guide can be found on the asset page of my website here, blenderzen.com. Come to the asset page. This is a PDF file and if you click, it opens onto a new page. This guide has shortcuts for both Mac and Windows. It begins with a brief introduction, then a list of the most common keyboard shortcuts for both operating systems. You can download this file from here and even print it off to have it close by. I'd recommend taking some time and working through each command to help familiarize yourself and get up to speed more quickly. In this video, we look at navigation in Blender. Let's get started. In Blender's 3D view, to rotate around, you simply press and hold the middle mouse button. As I rotate around here, because the cube is selected, I'm able to orbit around this selection. All thanks to a setting we enabled in an earlier video called Orbit Around Selection. If we select the camera and press the middle mouse button, we'll then orbit around the camera. Really useful setting, providing not only focus but also a smoother control over your viewport. Then we have zooming. By pressing and holding Control with the middle mouse button and pushing forward and back, you can achieve a very smooth zoom. You also have the option to roll the middle mouse button to zoom, although this method offers less control over speed and it's not continuous. To pan the view, you need to press and hold Shift along with the middle mouse button, and then move the cursor. The middle mouse button and Alt key can also be utilized to switch views. First, switch into a front view by clicking the green circle on the gizmo. If you prefer shortcuts, numpad 1 gets you into a front view, and numpad 5 switches to an orthographic view. Your current view type is displayed at the top left, and you can switch back and forth between perspective and orthographic views using this button here. Switching views using the middle mouse button and Alt key works in both perspectives, but it's easier to demonstrate from an orthographic view. For a right view, press and hold Alt, then press the middle mouse button and drag right to left. Feels like dragging the view around. For a top view, hold Alt, then the middle mouse button and drag from top to bottom. This technique might take some practice, but it's very effective once mastered. The view gizmo offers further control when switching views. If you hover the cursor on each axis end, the tooltip will display the view. Under the view gizmo, there are controls for zoom, pan and camera. The first button will smoothly zoom the view. The button beneath will pan the view. These gizmos can be switched off using this Show Gizmo button, and the navigation controls get disabled. This can help clear your viewport. When enabled, you can limit this to just the navigation gizmos by disabling navigation here. I like this View Navigation gizmo to get my bearings, so I always leave these switched on. Below, the Pan button switches you in and out of camera view. Once the camera is selected in the outliner, it's highlighted in the 3D view. You can press and hold Shift with the middle mouse button to pan around, with the camera view remaining fixed. If you try and rotate, you will leave the view. To control the camera further, press N to open the sidebar, and in the View tab, put a checkmark in Lock Camera to View. This allows you to zoom, rotate and pan from within the camera view, aiding you in capturing the perfect shot. With Orbit Around selection enabled and with the camera selected, the target object is the camera itself. If we select the cube, then rotate, we can orbit around the cube as it's now the selected object. This feature is particularly handy for focusing on and rotating around specific objects. Moreover, you can adjust the camera's focal length and depth of field. Simply right-click on the camera for the context menu and choose Adjust Focal Length. Pushing in or out will adjust it, and the value is displayed at the top left. Right-click again to exit. To exit camera view, we can click the camera icon. If you exit camera view and find yourself far away from the object you're working on, use numpad period to frame the selected object. To frame all objects in the scene, press the Home key. The navigation commands can be found in the View menu. In the Viewport menu, the different views and their shortcuts are listed. In addition to this View menu and the gizmos, there is a shortcut to open a View Pie menu. Pressing the apostrophe key will open this menu. Then click to select a view or press the corresponding number to switch into that view. If we press the apostrophe key again, you'll also find the zoom to the selected object from this menu. In this video, we look at the 3D View editor. Let's get started. The 3D view in Blender is the area highlighted here. It acts as both an editor and a space to interact with 3D objects. This is where you can display, modify, animate objects and perform various other tasks. On the left side of the 3D view is what's known as the tool shelf. To open it, simply use this arrow button and then you can click on the edge and drag it back to close it. You can also use the T key as a shortcut to open and close this area. Inside the tool shelf, you'll find various transformation and editing tools that are essential for shaping your 3D models. On the right side of the 3D view, you'll find the sidebar. This is where the properties related to the different objects reside. To open the sidebar, you click this arrow icon and then you can drag it back to close it. The shortcut key N is used to toggle it open and closed. Like all editors in Blender, the 3D view can be changed from the editor type dropdown, which lists the editor types available, each catering to different functions. For example, let's switch to an image editor. Notice how it instantly takes up the entire space, replacing the 3D view. Now we can go back up to the editor menu and switch it back to the 3D view. Blender is mode-based and different object types have specific modes available. If we select the cube, the modes for a mesh object become available, including Object, Edit, Sculpt, Vertex, Weight and Texture mode. Other objects, like the camera, will only have Object mode available. With it selected, we can see only Object mode from the drop-down, while armature objects can access Object, Edit and Pose mode. Using Ctrl+Tab, you can open a pie menu with the available modes for the selected object. Most often we'll be switching between Object and Edit mode, and you can do this quickly by pressing the Tab key. Your current mode will be displayed on the top left. The next menu along here is the View menu. Here, the tool and sidebar can be opened or closed. The shortcuts T and N are listed alongside. Below these, enable tool settings. This displays the available options for the current tool. So again, with the cube selected, press Tab and enter Edit mode. The tool settings relate to the currently selected tool from the tool shelf. Select different tools for those tool settings to become available on the menu here. From the View menu, if we disable this setting, those settings are hidden. We can tab back to Object mode. The asset shelf will make assets available within certain editors without needing to open the asset browser. Then adjust Last Operation. This will display the properties after an operation has been performed, if any are available, useful for adjusting the results. Below this is Frame Selected and Frame All. We saw a similar command for Frame Selected on the View menu with View Selected. Frame Selected can be useful if you find yourself lost in 3D space. Numpad 5 will switch between a perspective and orthographic view, and we saw this using the button in the viewport. Numpad / will bring you in and out of local view. Local view lets you isolate an object. This makes editing objects much easier. Multiple objects can enter local view together. When in local view, Alt plus Numpad / will remove any selected object from the local view. So for example, back in the scene we can press Shift and select the second cube. Now press the / key to isolate both objects. Your current view is displayed to show local here. If we want to remove this first cube from local view, select it, then press Alt plus Numpad / to remove it. The second cube remains in local view and you can continue working without the need to return to global view first. Pressing the / key again will return to global view. Coming back to the View menu, you can set the active camera. This will be the one that renders the view. Viewpoint has the different views. We saw this with the apostrophe key for the pie menu. Navigation has orbit, roll, pan and zoom controls. Also, the walk and fly commands from the navigation menu are available. Additional walk and fly settings can be found in the Navigation tab in Preferences. Align View lets you align your view to selected objects or center your view. View Region lets you select small portions of the view to render and can save time rendering complete shots. Play Animation is the spacebar and that button is below on the timeline here. This can be paused here also. Other useful options on the View menu are the ability to render an image from the viewport, render a quick play blast animation, or render the keyframes if any were available. In this video, we look at selection types and the Quick Favorites menu. Let's get started. To begin, let's come to File and start a new general blend file. We can move on to the Select menu. When working in Blender, selecting objects or part of objects is fundamental and a constant occurrence. We previously saw how you can select objects with the left mouse button, but there are many more ways, including the first selection type here, Select All. This will select all visible objects in the scene. The shortcut for this command is the A key. Double tapping A will deselect. However, a more common way to deselect is using Alt plus A. Next, we have Invert Selection. This will deselect your selection while selecting everything else. So for example, if we select the cube here, then press Ctrl plus I to invert the selection, all other objects are selected with the cube being deselected. This is especially useful in edit mode when selecting vertices, edges or faces. Next, we have Box Select and Lasso Select, and we'll be taking a closer look at these selection types in the next lecture, so we can hold off until then. Additionally, you can select objects by type, so you can select all visible mesh objects, curve, text, even empty objects using this command. Really useful if you need to apply a specific operation to all objects of a particular type. Select Active Camera, select the mirror of an object, or select Random. So if we wanted to vary the scale of trees in a forest, for example. Following this, we have Select More or Less. For this, you can use Ctrl plus Numpad plus to increase the selection, or Ctrl plus Numpad minus to decrease it. This command is beneficial in edit mode for selecting vertices, edges, or faces up to a designated edge. Then select Grouped, select Linked Objects, and select Pattern. We'll be using some of these commands during the course, so you'll get a practical usage at that stage. However, before we do move on, I want to highlight 3 additions to selecting. The first is adding to selections in edit mode. So select the cube and tab in here. When we say select a vertex, we left click to select it. Then if we want to add to this selection, we can press and hold the Shift key and select the second vertex. And that adds to the original selection, and the 2 vertices are selected. The second is selecting the shortest path between 2 vertices. So if we select this top vertex here, hold the Control key and select this bottom corner vertex, this selects the shortest distance between those 2 vertices. The final one is Alt Select. This will select an edge loop of vertices, edges or faces. So first I'm going to press Ctrl plus R to add an edge loop. Then just left click and right click to place it center. That just adds an edge loop center here. Press Alt plus A to deselect. If we wanted to select this entire edge, we can press and hold the Alt key and left click. That will select all the vertices right the way around here. Works for edges and faces also. Let's tab back now. We can move on to the Add menu now. As the name implies, this is where you'll find the various object types you can add to your scene. In the Mesh menu, you'll find a range of primitive mesh objects, basic geometric shapes that serve as an excellent foundation for modeling. Let's add a UV sphere into the scene, a form that is a useful starting point for various modeling and saves you from shaping it manually. A task that is doable but time consuming. There are also curve objects, surface NURB objects, metaballs, text, volumes, grease pencil, armature, lattice, and empties. You have the ability to add reference and background images, light objects, probes, cameras, speakers, force fields, and collection instances. Additionally, some of the add-ons you'll find in Preferences will expand this menu even further with unique objects. Let's move across to the Object menu. The Transform menu lists an object's transformation options. Remember the keys G for moving an object, R for rotating, and S for scaling. These are perhaps 3 most frequently used commands in Blender. Following this is the Set Origin menu, Mirror menu, Clear menu, and Apply Transforms menu, and the Snap menu, all of which contain commands we will use often as the course progresses. We previously saw Duplicate objects. Another is Duplicate linked objects. Then Join objects together. This command lets you join multiple objects into one. So if we duplicate this cube with Shift+D, these are two individual objects. However, if we Shift select both, notice how the last one selected is a lighter color, indicating this is the active object. This means the new object will inherit properties of the active object, such as its name, any modifiers, and location transform. So press Ctrl+J and join this into one. When setting up, we made sure tooltips were enabled, so if you ever find yourself stuck for a command, hovering on the name will display a description. Also, alongside most, the shortcut key will be listed. Moving on down, we have copy and paste. These are very useful for copying values between objects. Let's see an example. In the sidebar, we can open the Item tab. Here we have the transform for the selected object, in this case, the cube. If you hover on the scale field and press Ctrl+C, this will copy the value to the clipboard. Now hover on the X location field and press Ctrl+V to paste in that value. This will translate the cube to 1 along the X-axis. This copy and paste functionality extends to various elements in Blender, like copying and pasting color values, for example. Let's open back up the Object menu and continue. Next is the Asset menu, giving you the ability to mark an asset. We'll see an in-depth example of this in a later video. Then Collections menu and the commands associated with collections. An upcoming lecture will be dedicated to collections and we'll go into more detail at that stage. More commonly used tools are here in the Convert menu. This allows you to convert curve objects to mesh or mesh objects to curves. You can also convert text objects to mesh. Let's look at an example. So from the Add menu, we can come down and add text. And I'm just going to quickly rotate this on the X and Z axes so it's facing forward. Over in the Object Properties tab, in Geometry, I'm going to extrude this text a little bit so we have a little bit of thickness. If we tab into Edit mode, we'll see this is an editable line of text. You can press the backspace key to remove the text. I'll quickly type text again. If you press Ctrl+A, it will select it all and you can press Ctrl+V to paste in your own text. We can replace this with Example. Then tab back to Object mode. If we come to the Object menu and down to Convert, we can convert this to a mesh object. So now if we tab in here, we have a mesh object that can be modified further. Back in the Object menu, there are other commands we'll use throughout the course, but the last one I want to look at here is Quick Effect, and we can choose Quick Explode. So what that does is it adds a particle system and an explode modifier onto the selected object. In this case, the example object here. If we press the spacebar to play the animation, the text will explode. That's the Object menu. You can quickly access the most common Object menu items by right-clicking and opening the Object Context menu. This menu is mode specific, meaning only tools for the selected object that work in that mode are available. So if we tab into Edit mode and right-click, the Context menu displays a list of tools only available in Edit mode. We can tab back to Object mode. For those tools you frequently use but lack a shortcut, you can add them to the Quick Favorites menu. Press Q to open the Quick Favorites menu. Right now, the list is empty as we don't have any commands stored yet. Let's assign the Selection to Cursor command here. So from the Object menu, open the Snap menu. To add a command to the Quick Favorites menu, right-click and from here, click Add to Quick Favorites. Now in the scene, if we press Q for the Quick Favorites menu, the command Selection to Cursor is now available. With the sphere selected, press Q and choose Selection to Cursor. That will snap the cube to the position of the 3D cursor. Very useful for commands without a dedicated shortcut. Incidentally, the shortcut for the snap menu is Shift+S. Finally, we'll explore the orientation menu. Here you'll find options for global, local, normal, gimbal, view, cursor, parent, and even the ability to add a custom orientation from a selected object. Each has a specific purpose, but let's compare global and local so we get an idea. By switching on the Move tool on the tool shelf, you can use the red arrow to move the cube along the X-axis, moving it globally along the X. If you double tap R to rotate this cube randomly and left click, then move the cube along the x-axis again, it will continue to move along the global x regardless of the object's orientation. Now in the orientation menu, change the transform orientation to local, and the manipulation arrow will change to align with the object's own orientation. You can then move the cube based on its own local orientation. If you switch back to global again and press GX, it moves along the global x-axis. Press X again and it changes to the local axis. The current orientation is displayed on the top here. This is a really useful shortcut for switching between those two transform orientations. We'll be taking a closer look at these orientation settings later in the course. In this video, we look at proportional editing and the shading options in Blender. Let's get started. We can begin back at the pivot menu. The pivot settings are crucial when scaling or rotating objects, and these settings can vary slightly between object and edit modes. The default pivot setting is the medium point. In object mode, the origin of the object acts as the pivot, while in edit mode, the center of the selected geometry becomes the pivot, calculating its position based on the amount of geometry selected. The 3D cursor pivot scales and rotates from the position of the 3D cursor. This behavior remains consistent in both object and edit modes. Throughout the course, we'll be exploring each pivot-specific use case, providing a more nuanced understanding of these features. Next, we can move on to the snapping menu. By clicking the magnet icon, you can toggle snap on or off. With the cube selected, press G and notice how the cube snaps in increments as you move the cursor. You can cancel this movement by right-clicking. Now let's switch to a front view. Also, make sure you are in an orthographic view. One of the essential steps in manipulating objects is clearing out rotations. You can see the rotation value displayed in the Item tab. Inputting 0 in the X, Y, and Z fields clears these transformations. This command is also accessible through the shortcut Alt+R. Now I can demonstrate snapping. The way we snap the cube depends on the snap type selected. The default is increment, and the snap distance is determined by the zoom level, displayed at the top left of the screen. So at a zoom level of 1 meter, the cube will snap in increments of 1 meter. Zooming in or out changes that zoom level, so 10 centimeters into millimeters, or out to 100 meters in the default scene. The distance you can zoom out can be increased, but we can leave the defaults. So back at 1 meter, if we press GX and move the cursor across, the cube snaps 1 meter in distance each snap. To move the cube in increments of 10 centimeters, we can first zoom into that zoom level. 10 centimeters is now displayed here. Now press G and the cube snaps in increments of 10 centimeters. The other snap types you'll find include vertex, edge, face, volume, edge center, and edge perpendicular. Each has a specific use case, and we'll see examples of the most common during the course. Let's set the snap type to vertex. We can switch snapping off by clicking the magnet icon. When snapping is off, we can activate it manually by pressing and holding the Control key. So for example, if we press G to move the cube, we can activate snap by pressing and holding the Control key. If you hover the cursor close to the sphere, you'll notice an orange circle appear. This indicates the cube can be snapped to this vertex. We can left click to confirm the operation. I generally leave the snap setting off and activate it using the Control key, as I find this provides more control and better experience. We'll be using snapping quite regularly during the course, so you'll get more experience then. There is also a dedicated snapping lecture. Let's move on and click to enable proportional editing. The drop-down menu lists the fall-off types available for the tool. We can leave it at the default setting of smooth for this example. In the outliner, we can click the eye icon and hide the cube in the scene. Select this sphere and tab into edit mode. You'll notice how the settings from one mode don't carry to another, as here proportional editing is disabled. A key concept in Blender. Make sure vertex selection is enabled. Zoom in here and select the top vertex. Now press G, Z and move it up. Only the selected vertex moves while all other vertices remain in place, as you would expect. We can right click to cancel movement. We can press O and switch on proportional editing. If we press G now, you'll notice a circle appears on the screen. That represents the proportional editing area of influence. If we roll the mouse wheel forward, that influence decreases. If we roll the mouse wheel backwards, the influence increases. The more we increase the influence, the more the vertices around the selected vertex gets affected. This tool excels in sculpting organic shapes, offering the ability to quickly create complex forms with ease. We can right click to cancel movement. Also switch off proportional editing. Let's tab back to object mode. We also need to switch this off here. The next menu controls object type visibility and selection. These icons, such as the eye for hiding and arrow for making objects unselectable, provide quick access to streamline your workflow. Moving across, the next menu shows or disables the gizmos in the scene. Clears the screen of clutter if you don't use these tools. I find the rotation gizmo great for getting my bearings and axes directions. From the drop-down menu, you can enable or disable individual gizmos. The overlay menu offers control over scene visibility, including the grid, screen text, relationship lines, or the 3D cursor. This can be especially useful if you need to render a quick play blast, as it will hide everything in the rendered image. One more overlay menu that appears here is the Mesh Edit Mode overlay. But first, we need to tab into Edit Mode. This overlay menu offers additional mesh data information, like edge length or face normal direction. We can tab back to Object Mode. Next, we come to Shading Types, an integral part of 3D visualization. The first option is to show or unhide X-ray mode with the provided button. If I rotate around the object, you'll see this effect more clearly. The X-ray mode lets you see through objects, providing insight into the inner structure. Within the shading drop-down, you'll find a control for the X-ray alpha amount, allowing for precise adjustments to this view. Feel free to switch it off to return to the standard view. The next shading type is wireframe mode, drawing only a wire on the edge of faces. It offers a skeletal view of your object. Great for understanding the fundamental geometry. Following that, we have solid shading, the default shading type in Blender, providing a tangible feel to the objects. Look Dev is another option, giving a material preview in the viewport. It simulates how materials and lighting interact, offering a more realistic view of your scene. The final type is render mode, showing how the scene will look once rendered. It's like a preview of the final product. Accessing these shading types is made easier with a pie menu. Simply press Z to open it and then press the corresponding number or click the shading type you want. In the drop-down menu, you'll find additional viewport shading options. Clicking on a sphere allows you to choose from one of the Studio Light presets. You can check on the cavity option to highlight the edge of the mesh. This brings out the finer details on the surface of the object, like small scratches, bumps, or details in a sculpt. Or turn on shadows to help preview the shadows being cast. These different shading types can be useful depending on your Blender task at hand. Whether sculpting or modeling, these settings can significantly improve visual feedback and improve your workflow efficiency. That was a brief look at where you can find some of the more commonly used tools within the 3D view. In this video, we look at the tool shelf. Let's get started. From the View menu, we saw how to open and close the tool shelf. The shortcut is the T key. The tool shelf is essential as it hosts context-sensitive tools for transforming or editing objects. We'll first look at the tool shelf in object mode, then later in edit mode. The first tool is the Select tool. Press and hold the left mouse button and the list of selection types gets displayed. The default is Tweak. With this selection, simply click on an object to select it, then drag to reposition it. Now let's open this again and choose Select Box. With this selection method, a single click selects objects and a left click and drag will create a selection box, permitting you to choose multiple objects. Many find this highly convenient. It's the selection type I generally utilize. The next selection type is Circle Select. We'll demonstrate this, but first, make sure you have an object selected. Press Tab to enter Edit mode. One thing to note is that the selection tool stays consistent, remaining the previous one used in this mode, echoing what was mentioned earlier regarding tool states not transferring between modes. On the selection menu, switch to Circle Select. Then left-click to select faces, edges, or vertices, depending on the mesh selection type. Circle Select, although somewhat limited, I find operates best when triggered from another selection type. So for example, let's come back and set the selection type to Select Box. To activate Circle Select, press C. Left-click to select parts of the mesh. To deselect, press the middle mouse button. To exit Circle Select, right-click. Really useful selection method for certain situations and when activated from another selection type. Finally, we have the Lasso Select tool. With Lasso Select set as the tool, we can left-click and drag a lasso selection to select parts of or all of the mesh. Similar to Circle Select, Lasso Select works best when activated from another selection type. Let's switch the selection type back to Select Box. To activate Lasso Select, press and hold the Control key and press and hold the right mouse button. Then draw a lasso selection around the object. I generally leave the type set to Select Box and only call the other selection types when needed. You can toggle through the selection types by pressing W. The icon switches to each, so if you remember the icon, it helps to select the one you want. Pressing Shift plus Spacebar opens the toolbar menu, whether you're in Object or Edit mode. From here you can switch by clicking on the selection method and choosing the type from here. One important thing to note when selecting vertices, edges or faces when in solid shading, only the visible vertices get selected. So if we deselect first, switch to Select Box also, then if we drag these visible vertices here, rotate around and any vertices that weren't visible will not get selected. This is important to be aware of. In wireframe mode, however, all vertices under the selection get selected. Let's tab back to object mode. Set the selection tool to your new favorite. Next up is the 3D cursor tool. With this tool active, left click to position the 3D cursor within the scene. A shortcut also exists to place the 3D cursor. First, switch back to the Select tool. Press and hold Shift and right-click. Accurate placement can be achieved via the View tab's Location and Rotation fields. If we input 10 in the XYZ, the cursor will be placed at that location. We will be taking an in-depth look at the 3D cursor in a later lecture, and you'll be surprised how versatile it really is. Below, we find the Move tool. The Move manipulator lets you grab and move objects in the scene. Arrows correspond to the axes. Green for Y, red for X, blue for Z. Left-click the center circle to move an object without constraint. Next is the Rotation manipulator. Similar to the Move manipulator, the Rotation manipulator allows for rotation via grabbing any of the 3 circles. Left-click a circle to rotate around that axis, or click the center for free rotation. The Scale tool functions in a similar manner, allowing scaling along any of the axes or all simultaneously. The next option enables all 3 manipulators at once, though shortcuts like G for Move or for Rotate, S for Scale, and specifying an axis with X, Y or Z can be more convenient. For example, to move the sphere 1 meter along the X-axis, press G to move, X for the axes, 1 for distance, and Enter to confirm. While these tools prove valuable, especially for beginners, you may find yourself favoring shortcut keys as you become more familiar with Blender. In this video, we look at how to use the Annotate Measure and the Interactive Cube tool. Let's get started. We can move on to the Annotate tool. That gives you the ability to draw freely on the screen. By holding the left mouse button on the tool, you can switch between line, polygon, or an eraser tool. The related options for these tools appear at the top of the header in the 3D view. Click and draw somewhere on screen. This gets added as a layer, so from the drop-down, control the color, visibility, name, thickness, and opacity. Changing the color specifically applies to the current scribble you've made. You can find these properties also available in the View tab on the sidebar. If you expand the Annotation tab, these options will be revealed. Here you can double-click on the name Note and we can rename this scribble. There's a special option called onion skinning that helps you animate what you draw using the timeline. You can use the before and after settings from the drop-down to observe these changes. Right at the top you'll find the placement settings, which control the positioning of your annotation. By default, it's set to the 3D cursor, aligning your drawing with the plane of the 3D cursor. If you rotate your view, the alignment with the 3D cursor will become evident. Pressing Shift and right-clicking to reposition the cursor will allow you to draw another annotation aligned to the new cursor position. Other alignment options include View and Surface. While the View option aligns drawings to your current perspective, Surface enables you to draw directly on object surfaces. If you wish to remove an annotate layer, simply click the minus sign. Next in line is the Measure tool, a valuable asset for swiftly determining distances between 2 points or getting the angle. Let's get a closer look, so from the Add menu, let's add a new cube. By pressing Ctrl, you can activate Snap and highlight the corner vertex with a left click. Continue holding Ctrl and move the cursor across. You might notice this can also snap to the midpoint, but let's snap to the opposite vertex to display the distance, which in this case is 2 meters. You can repurpose this measurement by hovering over the endpoint until a particular icon emerges, select that point and snap it across the diagonal to record that distance. This tool also exhibits angles. Left select, hold the distance away from the edge, and a fresh point is made. Press Ctrl and snap to a corner or midpoint vertex, and the angle measurement will be displayed. If you wish to remove this angle, select the point, and an X will highlight. Pressing X deletes it, reverting to the original distance measurement. If you wish to remove the dimension altogether, press X again to delete. Lastly, we can explore the Interactive Creation tool, which allows you to draw shapes in the scene or on top of other objects. Left click and drag to shape the rectangle. Release and drag again to set the height. You can create these on another cube by pressing Ctrl to activate Snap and snapping to a vertex. If you want to draw a square, left click, drag and press Shift to maintain the aspect ratio. Pressing and releasing Shift once more forms a perfect cube. The Properties box then enables adjustments to size, location and rotation. If you left click and hold, other geometric primitives become accessible in the list. This tool is particularly useful for quickly blocking in objects of varying sizes, providing flexibility in your design process. In this video, we look at how to use the Extrude, Bevel and Edge Loop tool. Let's get started. Next, we can take a look at the tool shelf in edit mode. First, switch back to the Select Box tool. Ensure that a mesh object is selected, then press Tab and enter edit mode. Or alternatively, use the mode menu at the top of the screen to switch into edit mode from there. You can bypass all the tools we explored in object mode and come straight to the Extrude tool. Left clicking on this tool will unveil all the extrude tools available to you. With the tool set to extrude region, navigate to the top of the screen to change the selection method to face. Select the face on the cube now. The extrude manipulator allows you to grab the plus icon, drag it out and create a new section of mesh. Remember, the shortcut key for extrude is E. The other extrude options include extrude manifold, which creates manifold faces during extrusion, a brilliant addition as it adds geometry where needed to keep quads on the mesh. Other extrude tools are extrude along normals, extrude individual, and extrude to cursor. If we select Extrude to Cursor tool, you can click within the scene, creating an extrusion at the cursor's location. This command can be accessed quickly as a shortcut. We can first switch the tool back to Select. Now if we press Ctrl and right click, you achieve the same outcome without needing to activate the specific Extrude to Cursor tool. Next we have the Inset tool. First, let's tab back to Object Mode. Press A to select everything, then press X and delete all objects. To add another cube, press Shift+S and reset the cursor to World Origin, ensuring that the newly added cube is positioned at the world origin. Remember, objects added from the Add menu are placed at the 3D cursor's location. From the Add menu, we can add a cube. Now tab into Edit mode. Ensure the selection type is set to Face at the top. Select the face on the cube. Click the circle gizmo and drag towards the face to create an inset. Options for the inset then become available, allowing you to modify values and adjust the inset. The shortcut for this tool is the I key, and it's also found in the face menu here. Let's move on to the Bevel tool. Begin by selecting a face on the cube's side. Bevel all 4 edges by dragging them outward. If you switch to Edge Select, you can bevel individual edges. Switch to Vertex Select and choose a corner vertex. We need to change the effect type to vertices from the drop-down. Now click and drag to bevel the vertex. The shortcut is Ctrl+Shift+B. The command can be found in the Vertex menu here. The shortcut for beveling edges and faces is Ctrl+B. Now let's tab back to Object Mode. Press X and delete the cube. From the Add menu, add a second and we can tab back into Edit mode. Lastly, we'll explore the Loop Cut tool. This tool places an edge loop on the mesh. Hovering the mouse close to an edge gives a preview of its position. Left click and hold to edge slide and find a desired position, then release to confirm. You can also leave the edge loop exactly at the insertion point by simply left clicking and releasing. The second tool in this menu is the Offset Edge Loop Cut. With the last edge you added still selected, left click and drag to form 2 new edges on each side. The shortcut for the Loop Cut command is Ctrl+R. Left click to place the loop cut, drag to position it, and left click again to confirm. If you wish to leave a loop cut exactly where it's added, which is centrally between 2 edges, use Ctrl+R. Left click, then right click. This way no edge sliding occurs and you can ensure it's centered. The shortcut for the Offset Edge Loop Cut is Ctrl+Shift+R. Simply drag down and left click to confirm. In this video we look at the Knife and Polybuild tools. Let's get started. We can now move on to the Knife tool. This tool allows you to manually cut new edges into the mesh. First, tab back to Object Mode and press X to delete. Press Shift+S to open the Snap menu and ensure the cursor is back at the world origin. From the Add menu in the Mesh section, choose a cube. Tab back into Edit mode now. To initiate a cut, left click on an edge, which adds the first point of the cut. The edge that you are adding is now displayed, and on the bottom info bar, different options for the tool such as midpoint and angle become accessible. Hovering on the corner vertex or on an edge will cause the box to highlight, indicating where the next point will snap. Click on the edge, then hover on a corner vertex and click there. To complete the cut, press Enter. Note that this method doesn't cut all the way through the mesh. To achieve a complete cut through the mesh, the Cut Through command can be used. For this, align the cut to the view by coming into a top view. Click an edge here for the first point. Notice that on the info bar below, the Cut Through setting is currently off. Press C to toggle it on. To straighten the cut, press A for the angle constraint. With the edge now straight, click to add the second point. Press Enter to confirm. Rotating around the object, you'll notice the edge has been added all the way around the entire mesh. Clicking and holding on the Knife tool reveals a second tool called the Bisect tool. To demonstrate this, add a new cube by first tabbing back to Object Mode, press X to delete the current cube, and since the cursor is at the world origin, press Shift+A and from Mesh, add a new cube. Tab back into Edit mode. Press numpad 1 to return to a front orthographic view. This bisect tool has the power to cut right through an object, but you must have the object selected. Press A to select everything. To initiate the cut, click away from the selected object, drag down and left click. You can fine-tune the cut using the manipulator, and the options let you adjust both the position and shape of the cut. The clear inner and outer options give you control to remove one side of the cut. Clicking away on the screen finalizes the cut. Next, we can explore the polybuild tool, an invaluable asset for retopology, the process of creating a low poly version of your model. First, tab back to Object Mode and delete the cube. From the Add menu, select the plane this time. Press G, Z and drag it upwards. Tab back into Edit mode to use the polybuild tool. Hover on an edge to highlight it, then left click and drag to create a new edge. Pressing Ctrl will create a triangle from an edge. To delete a face, press and hold Shift. Hover to highlight the face in red, and then left click to remove that face. This tool is highly effective for retopology, often used in conjunction with a shrink wrap modifier and face snap enabled, greatly accelerating the process. In this video, we look at the spin tool. Let's get started. We can now explore the spin tool. First, tab back to Object Mode, then press X to delete. From the Add menu in Mesh, let's add a cylinder for this example. Now tab into Edit mode. The spin tool can be used to create a sweep, so activate it. By pressing and holding the Alt key, you can select this entire edge loop of vertices. To properly view this, switch into a front view, where the curve indicates the direction. So up top, select the Y-axis for the sweep. Notice that the handle centers on the 3D cursor and pivots from this position. Clicking here will cause the new vertices to overlap, but you can adjust the position of the center afterwards from the options box. Alternatively, you can press Ctrl+Z to undo those steps. You can use the 3D cursor location fields to position the cursor accurately. However, let's press Shift plus the right mouse button to place the cursor out here, optimizing the pivot for forming the curve. Click on the widget and rotate these vertices. In the angle field, input 90. The position can then be adjusted if necessary. Here's a second example using the tool to sweep a profile. Select everything by pressing A, then press M for the merge menu and choose at center. This merges all the selected vertices into one at their center. Press G and look closely to find the single vertex. Let's place this vertex at the center by pressing Shift+S and choosing Cursor to World Origin. Then press Shift+S and select Selection to Cursor to snap the vertex to the 3D cursor. Switch the tool back to the Select box. To start the extrusion, press E and X to create a base. Press Ctrl plus right click and begin forming a profile. Repeat the extrusion around this area. It doesn't need to be highly accurate, just ensure the profile stays to one side of the center line. I can quickly finish the profile here. Now press A to select it all. We can change back to the spin tool. Also, make sure the axis is set to Z up top. As we've seen, the spin tool uses the 3D cursor as the pivot, so ensure the cursor remains centered. Grab the manipulator and drag to create the sweep. The options allow you to increase the angle to 360 and finish the sweep. Make adjustments to the center X and increase or decrease the diameter. Similar to the profile you might create on a lathe, this tool could create some really nice shapes very quickly. Next, let's move on to the Smooth Vertices tool. This tool functions by averaging the angles of the selected vertices. Select everything with A, then click and drag the tool to smooth the shape. The properties then allow you modify those changes. Following that, we have the Edge Slide tool. Press and hold Alt to select an edge loop around the shape. We can then edge slide the selected edge to reposition. Double tapping G is the shortcut. Edge slide retains the original mesh shape, allowing it to slide along the surface. The shrink flatten tool is next, allowing you to increase or decrease the selected edge's size using the tip. Alt+S is the shortcut for this command. The next tool is shear. The shear tool lets you shear the selected vertices or face along a chosen axis by dragging. Lastly, the rip region tool. Click and drag the widget to rip the selected edge loop apart. The shortcut for this command is the V key. In this video, we look at workspaces. Let's get started. Begin by tabbing back so that we can delete this object. You'll notice the tabs running across the top of the viewport. These are custom workspace layouts. Each workspace is a thoughtful collection of editors set up specifically for common tasks such as modeling, shading, and scripting. If you recall, we previously explored these editor types from the menu. Each editor serves a specific purpose, but when arranged together, they provide the necessary tools for specialized tasks. This is the innovation that Workspaces brings, opening up a new way of working. Consider the UV editor, for example. It has the 3D view on the right side and the UV editor on the left. This workspace also includes the outline editor on the top right, with the properties editor beneath it. Though this is the default layout, customization is an option if needed. Now let's delve into creating and setting up our own workspace. Creating workspaces can be done in a couple of ways. First, click the New Tab button here, then choose the type. Generally, you can commence with one of the presets. An alternative way to create a workspace is to right-click an existing one and choose Duplicate. This creates a new workspace alongside the existing one. Double-click to rename it. For instance, My Workspace. This action duplicates the existing workspace exactly. Next, let's simplify this workspace to just one editor and then build it back up. Press T and N to close both shelves. If we come to the dividing line between the 3D view and the properties editor, we can right-click to get this menu. The first option is vertical split. This will add another editor. Drag the line to position and add one beside the existing. Right-clicking gives you the option to join these, with an arrow indicating which editor you wish to remove and return this to one. Right-click again, this time selecting horizontal. Then position the line and choose whether you want this added above or below. Then right-click to join these areas back. If you right-click on an edge again, the option Swap Areas reverses the order of the outline and properties editor. Right-click and join these editors. We can repeat the process for the timeline and 3D view and join these together also. Combine the 3D view and the properties editor into one. That leaves us with just the 3D view. To split this view, come to the upper corner on either side and a plus icon will appear. Left click and drag to the left to split this into two. To split the left side editor vertically, hover in the top corner and left click and drag down to split. You can join them using the same method. Hover to get the plus icon, then drag up or down quickly to choose the direction you want to join. If you start creating extra editors, right click to cancel. It might take some practice, but remember you can always right click and join from here. In the editor type drop-down, you can choose an editor type. Change the second editor also to demonstrate how effortlessly you can create workspaces in Blender. Additionally, you can modify and customize existing workspaces. Right-click for further options such as deleting the layout, reordering the workspaces to front or back. Also, you can remove the menus and provide more space for the workspace menu bar. Put a checkmark back in the box to show the menus again. Lastly, before we conclude, change the editor type back to 3D view. The functionality of having a double viewport provides an extremely valuable feature in Blender. In this video, we look at what collections are in Blender. Let's get started. Let's begin by coming back to the Layout tab and over to the Outliner. This is where you'll find Collections, a powerful tool in organizing the objects within your scene. Collections provide you control over visibility during render, enable you to light specific objects, and make appending from other scenes both quick and effortless. The scene collection acts as the parent collection, housing all others beneath it. The first collection, aptly named Collection, is listed here. Its checkbox ensures that everything inside is included in the view layer, or what's visible in the scene. The eye icon controls visibility, offering a convenient way to hide or unhide objects, while the camera icon governs whether objects are included or excluded from the render. There are additional settings in the filter menu. The next makes objects or collections selectable or unselectable in the viewport. The next option is Disable in Viewport, which turns off or disables the visibility of objects and collections in the viewport. The final two options can be ignored. The first is used for masking objects during render, and the second, Indirect Only, sets collections to contribute solely to indirect light. Close the filter menu and you'll see the icons we've enabled are now available. Double-click the collection and rename it Geo, short for Geometry. To create a new collection, right-click and select Create a New Collection. If the Geo collection was previously selected, the new collection will be added inside. Double-click this new collection and rename it Lights. If you want to add the new collection under the Scene collection, first select the parent Scene collection. Right-click and create another. This will appear under the Scene collection and you can double-click and rename it Cameras. Reordering collections is a breeze no matter where they're placed. Simply select the Lights collection and drag and drop it over the Scene collection to move it. When adding objects to the scene, depending on the selected collection, the object will get placed inside. Select the Geo collection. Then from the Add menu, add a cube. The Extrude from View Layer checkbox lets you control what will be rendered in the current view layer up top here. The next icon will control whether the cube can be selected or not. When off, the cube can't be selected. Really useful when you don't want to accidentally move objects. The eye icon hides objects. The shortcut for hiding is H, and for unhiding Alt+H. Another icon disables objects in the viewport. The camera icon will exclude the object in render. Let's come to the Add menu and from here add a camera. Press G and move this away from the cube. Let's come back to the Add menu and from the Light menu add a sun lamp to the scene. Drag this away from the cube also. To move the light into the Light collection, press M and choose the Light collection to place it inside. If we select the camera, in the outliner, click and drag to drop it into the camera collection. Collections can be closed or expanded using the numpad minus and plus keys. Repeatedly pressing numpad plus expands the hierarchy, while the numpad minus key closes it back one level at a time. The icons signify the objects inside collections. A triangle, for instance, denotes a mesh object, and the 2 indicates there are 2 mesh objects inside this collection. In this video, we look at the very versatile, essential, multi-purpose 3D cursor. Let's get started. To get started, press A to select everything in the scene, press X and delete. We previously looked at the 3D cursor tool on the tool shelf. When activated, you can click to position the 3D cursor within the 3D view or even on the face of objects. In the sidebar, in the View tab, the location transforms of the 3D cursor are displayed, providing the exact coordinates of the cursor as you move it. Next, we can look at accurately positioning the 3D cursor. Blender operates on the right-angled Cartesian system where the z-axis points upwards, the x-axis runs horizontally, and the y-axis extends from front to back. These 3 axes work in conjunction to describe every point in 3-dimensional space. The 3D cursor's location, along with the positions of every vertex, edge, and face, can be precisely calculated using these points. This information is visible in the View tab, allowing for accurate positioning of the 3D cursor. Visual aids include the red line representing the x-axis, the green line for the y-axis, and the blue line for the z-axis, which can be activated via the Overlays menu. The intersection of these lines at the world's center 0, 0, 0 represents the convergence of all axes. You can reset the 3D cursor to world origin by updating the location fields to 0, 0, 0. We can also align objects to the 3D cursor's rotation. The rotation field below controls the rotation of the 3D cursor. Here we can input a value of 45 in the X rotation field to rotate the cursor. Then input 0 for the Y and Z. This is useful when aligning objects. So from the Add menu, we can add another cube. In the Options box, change the Align setting to be 3D cursor. If you wanted this behavior as default, that setting is available in Preferences. So press F4 and open Preferences. In the Editing tab, this setting New Objects Align to. The default is World, but you can change this to 3D cursor and have objects align to the 3D cursor by default when added to the scene. However, since aligning objects to the 3D cursor is a rare task, it may be left as is. We can, however, use another command in the scene, so I can leave this at World and X down Preferences. If you wanted to align existing objects to the 3D cursor, come to the Object menu. In the Transform menu, come down and choose Align to Transform Orientation. Then from the Options box, you can change this to Cursor here and match the rotation of the 3D cursor this way. The 3D cursor also comes with a dedicated Snap menu. By right-clicking and selecting Snap, you have 6 options for cursor positioning. For instance, Cursor to World Origin resets the cursor and clears rotation values. You can also access this menu via the Object menu, or use Shift+S as a shortcut. Next, let's look at snapping individual vertices to the 3D cursor. Let's select a cube and from the Mode menu, enter Edit Mode. Switch to Vertex Selection. Position the 3D cursor somewhere in the scene. Now select the vertex on the cube, press Shift+S, and from here we can choose Selection to 3D Cursor. That will snap the selection to the 3D cursor. Press A and select it all. Press Shift+S again and this time choose Selection to Cursor Keep Offset. This will snap your selection to its position but maintain the vertices position relative to one another. You can also align objects to the location of the 3D cursor. First, we can switch back to Object Mode, position the cursor in the scene, then come to Object and Transform and down to Align Objects. In the options, set relative to the 3D cursor, then set the axes. All 3 can be activated using the Shift key. From Align Mode, change to one of these options. Next is snapping to the position of the 3D cursor. Press Shift+S and choose Cursor to World Origin. We can call up the same snap menu and we can choose Selection to Cursor. That snaps the origin of the cube to the 3D cursor. The yellow dot is the origin of the cube. It's possible to change that origin with the help of the 3D cursor. From the Mode menu, we can switch to Edit Mode. Currently, the origin is at World 0, and one thing to note, if we move all the mesh in Edit Mode, notice how the origin point remains in place. I can right-click to cancel move. That's one major difference when moving objects in Edit or Object Mode. In Object Mode, the origin moves along. We can set the origin at the base of the cube and it's usually where you will want it. Up top, change the mesh selection type to Face, then select the bottom face. Press Shift+S and put cursor to Selected. To set the origin, we need to switch back to Object Mode. Then from the Object menu in Set Origin, we can choose Origin to 3D Cursor. The dot or origin of the cube updates to that face. Another use is using the 3D cursor as a rotation point. The pivot point in Blender can be set to the 3D cursor, and this allows rotation around its position. In the location field, we can input 0 for the X, Y, and Z, and place the cursor back to 0. Let's use the gizmo here and come into a front view. If we press R and rotate the cube, it rotates around its own origin point. We can change that here in the pivot menu to the 3D cursor. Now back here, press R to rotate. This time it's rotating around the 3D cursor. We can right click to cancel rotation, then reposition the cursor. Now press R and rotate again. This can be a great way to rotate objects quickly. The final aspect of the 3D cursor is using it as an insertion point. Let's change the pivot point back to medium from the menu. If we come to the Add menu, in Mesh, add a sphere. Objects get added by default to the position of the 3D cursor. This works the same way in edit mode. The 3D cursor is a very versatile multi-purpose tool, essential when working in Blender. In this video, we look at snapping. Let's get started. To begin, we can press A and select everything. Press X and delete. Put the cursor back to world origin, so press Shift plus S and place that back here. In the outliner, select the Geo collection. Then back in the scene, press Shift plus A and from Mesh, add a cube. Now we can open the Scene tab. In here, expand the units area. By default, Blender's scene unit is metric with a unit value of 1. The length setting is meters and we can leave it this way for the following examples. Let's open the Item tab. Here, because the length setting is meters, the dimensions are displayed as such. These dimensions are equal to 2 meters along the X, Y and Z axes. In the scene, let's come into a front view and then an orthographic view. Snapping is a method to accurately position or align objects or parts of objects. The magnet icon you see will turn snapping on or off. For this example, we can switch it on. How we snap the cube is dictated by the snap type found in the list here. The default setting is increment. This increment snaps to the grid relative to the cube's position and the current zoom level. Additionally, there is an absolute setting that lets you snap the object's origin to the grid points relative to the world origin. When in an orthographic view, the snapping increment amount changes based on your zoom level. You can open the snap menu with Shift plus Control plus Tab, set the snap to increment, then zoom in or out and set the zoom level to meters. When the zoom level is at 1 meter, the cube will snap in increments of 1 meter. You can activate this by pressing G and then X, moving the cursor. Each increment the cube snaps to equals 1 meter, and you can see that distance displayed on the top left of the screen. Right-click to cancel move. If you wanted to snap in smaller increments, like 10 centimeters, zoom into a level of 10 centimeters. Then press G. The cube will now snap in increments of 10 centimeters. This same method applies to millimeters. Just zoom into a level of millimeters. Press G and the cube will snap in increments of 1 millimeter. Right-click to cancel the move. The same is true if you zoomed out to kilometers. Now let's compare relative and absolute snapping. Currently, when we snap the cube, it's snapping relative to its existing position. To see this more clearly, turn off snap with the shortcut Shift plus Tab. Press G and move the cube away from the world origin. You may want to press Z and switch to wireframe for a better view. If you zoom in, you'll notice the cube's origin isn't precisely on a grid point. Turning snap back on with Shift plus Tab, you'll see when you press G and move the cube, it moves relative to its position. Right-click to cancel the move. Absolute grid snap is a different method, snapping an object relative to grid points. Open the snap menu and switch on the absolute setting. Press G and the cube's origin will snap instantly to the nearest grid point. It will then snap relative to grid points as you continue to move it. Grid snapping can be a great way to achieve accuracy. Up top, switch off snap. Then in the snap menu, switch off absolute. Also, change the snap element setting to vertex. Back in the scene, let's zoom out here first. Duplicate the cube by pressing Shift plus D, then press X to move it along the X-axis and position it as required. Press Z to switch back to solid shading. To move the cube, press G. Then to activate snap, when off, press Control. This allows you control when snap is enabled and the way I like to use it. Hover on a corner vertex and an orange square will indicate the closest vertex the cube can snap onto. Then click to confirm. This is limited by the fact it must be the closest vertex. Let's open the snap menu briefly. Here you will see the default snap width setting is closest, which snaps the closest vertex of the cube to the target. So in this case, the corner vertex closest was snapped. You can expand snapping further by setting a base point. Similar to CAD programs, if we press G to move the cube, down below here you'll see a setting called Set Base Point, and that's the shortcut B. So if we press B, we next need to select the base point as the command is open. So if I, for example, pick this back corner, that's now the base point and snap is now active. So we just need to decide where we want to place the cube and click. So really precise way of snapping objects in Blender without needing to change any other settings. This also works with increment. So if we have increment set and we press G, then press B to choose a base point, then snap in the same way. However, it's also possible to navigate during transform. Press and hold the Alt key. This will allow you navigate while in snap mode. Also, when set to increment, press G, then B for a base point. You also get the option to pick a midpoint. So select this as the base point. Then again, when snapping, pick a midpoint. So that's a really big change in Blender and huge improvement to snapping. Let's open the snap menu and switch this back to vertex. The other snap width setting are the center or median. These are similar and will snap the center of the object to the vertex. So in this case, the origin of the cube as this is center. If the second object has a center edge, you could snap the cube to that vertex or edge. The last setting is active, and this will do the same thing as center in object mode and snap to the center of the cube. However, in edit mode, this works similar to setting a base point. But in this case, we set an active vertex where you can achieve precise snapping. For this, we can tab into edit mode, press A to select all the vertices, then deselect and reselect this corner vertex. This highlights white to indicate the last vertex selected and therefore the active object. The active object in Blender is a way to manage the order of objects, and we'll talk more about it during the course. So if we press G and press Ctrl to activate snap, we can snap the cube based on the active vertex. So now when I snap, the cube snaps based on the active vertex. A really great way to accurately snap in edit mode. Selecting the base point also works in edit mode, so you have good options for precise snapping in both modes. Let's open the snap menu again. The backface culling setting excludes backface geometry, and I never have a need to enable. Align rotation to target is useful, so let's enable this. Set the snap type to face and the snap width setting to closest. Back in the scene, select a corner vertex. Now press Ctrl plus Shift plus B for the bevel vertex command and bevel the vertex. Drag to increase its size and left click to confirm. Tab back to object mode now. If we select this cube, the align rotation to target will allow us align the cube to the beveled face. Press G, then get the cube into alignment, then left click and the cube gets aligned to the face of the bevel. We can come back to the snap menu and switch off align to rotation of target. We can also change the snap type back to vertex. In the Scene Properties tab, let's change the length setting to millimeter. Then make sure and save your file. In this video, we look at face normals. Let's get started. To begin, we can press A and select everything. Then press X to delete the selection. From the Add menu in Mesh, we can add a new cube. Then tab into Edit mode. In 3D applications, face direction is really important. In order to render objects and scenes, these programs consume considerable computational resources. By calculating the visible and front-facing faces of the cube here, They conserve resources by avoiding the rendering of back faces. Face normals are the means to determine the face orientation and direction. Front faces, in particular, influence the interaction with light and shadows and are what the camera sees. Although Blender can automatically ascertain the correct face direction, you may occasionally need to manually update it. Thankfully, Blender offers a couple of tools to assist with this task. The first of these tools can be found in the Overlays menu. Come down and enable Face Orientation. Right away, the faces of the cube turn blue. These blue faces indicate the mesh's front faces. Right-clicking here allows you to add this overlay to your Favorites menu, providing a crucial and frequently needed check. Every face on the cube has both a front and back face. The front faces are rendered and shown in blue. Let's switch to Face Select up top, then select the cube's top face. Press X and choose Faces. Now we can see the internal faces are red. These red faces denote the back faces of the mesh, which aligns with what is expected of internal faces. Suppose this cube were to represent an interior space, like a room. In that case, reversing these faces would be essential. Select an internal face and we can come to the Mesh menu and down here in Normals. Here you will find three options. The first manually flips the selected face or faces. The second option recalculates outside faces, reversing them if deemed outside faces. The third option recalculates inside, flipping them if identified as inside faces. Choose the first option to flip the face and change the face normal's direction. This will simply flip the direction of the face normals. Flipping faces will be a regular process because if you notice shading issues on your mesh, the first check should be the face orientation. The second should also be face orientation because you didn't check correctly the first time. The final check should also be face orientation. If textures look odd, check face orientation. And always, before you export your model, check face orientation. Blender provides a second tool to visually represent normal direction. This is located in the Mesh Edit tools here. This menu is available in Edit mode. At the bottom we have the Display Normals for vertices, edges and faces. We can check on Face to enable it. Increase the size it's displayed on screen by increasing this value here. The line symbolizes the face normal direction, pointing outwards on these faces, except the face we reversed. If we select another face, press Shift plus Control plus N for the Recalculate Inside shortcut. That determines that is an internal face and the face normals are now flipped. Let's come back to the Overlays menu and switch this off. Another feature to highlight is backface culling, found in the Shading Settings menu. Enabling this renders the back faces of the mesh invisible, allowing only the front faces to be seen. This reflects what will and won't render, assisting when modeling. Importing a mesh with reversed faces into a game engine or rendering it in Blender may result in invisibility or distorted textures. Therefore, understanding the tools to check face normals in Blender is vital. We can switch off backface culling. We can also press Q and switch off the face orientation overlay. One crucial point to consider is that the Quick Favorites menu stores different shortcuts for each mode. For example, the face orientation command won't be available in object mode after tabbing back. Press Q here. The face orientation command is not available. Each mode requires its addition to the Quick Favorites menu. We can come up to the Overlays menu and add this to the Quick Favorites menu for object mode, enabling activation or deactivation from either mode. Most commands you never use in more than one mode, but face orientation is one of the exceptions. In this video, we look at the coordinate system. Let's get started. Blender uses the right-angled Cartesian system, a geometrical framework used for describing the position of every point in three-dimensional space. This is where the z-axis is pointing upwards, defining the vertical orientation. The x-axis runs horizontally from left to right and the y-axis front to back, with each axis having both a positive and negative direction, enabling a complete spatial description. We mostly take it for granted, but at any time, the position of any vertex, edge, or face can be calculated using the coordinate system. Why is this important? The location for every vertex, edge, or face can be found, allowing for detailed 3D modeling. Lighting calculations use vector math like dot product and Lambert's law that rely on the Cartesian system to calculate accurate shadows, highlighting, and intensity. Object transformations are also simplified using this system. The list goes on. We saw previously the 3D cursor can also be accurately positioned within the coordinate system by using the XYZ location transform fields. We can press X and delete the cube. Press Shift+S and put the cursor to world origin. Then from the Add menu, in Mesh, add a cube. We can tab in here. In edit mode here, we can select the corner vertex of the mesh. If we come to the mesh menu and down to separate, here we can separate selection. Now tab back to object mode and select the vertex. It will be called cube.001 and you can make sure it's selected in the outliner. Click the eye icon and hide the first cube. This isolated vertex is the foundational element in computer graphics that defines the shape of a polygon mesh. Using this vertex, you can extrude and form the other two vital components, edges and faces. These three elements are the building blocks of all mesh objects. If you open the Item tab, you'll notice that it retains the cube's origin coordinates, 0, 0, 0 in the X, Y, Z axes. By going to the Object menu and setting the origin to geometry, with geometry referring to the single vertex and its 3D space position, you'll see updates to -1 in the X, -1 in the Y, and 1 in the Z. If we press numpad 1 and come into a front view, we can visually see the position along the negative x-axis is -1 and +1 in the z-axis. Let's tab into edit mode. Select the vertex, press E, X, input 2 and enter. Now we have created a second vertex connected by the second component, an edge. Switch to edge selection at the top and select the newly formed edge. Press E, Z, input -2 and enter. This action creates a second edge below, introducing the third component, a face. We can switch to face selection up top and select the new face. You'll notice the polygon has 4 vertices, 1 at each corner. If we switch to edge selection, you'll see how each edge connects the corner vertices, and in face selection, how all these combine to form a single face. Now press E, Y, input 2 and enter. This extrusion sequence transforms a single vertex into an edge and then a face, eventually creating a cube with 6 sides using the X, Y and Z axes within the coordinate system. Let's press Q and switch on the face orientation overlay. This is a common occurrence when extruding from edges or faces. Select it all and press Shift+N and recalculate outside. In this video, we set up an asset library and link it to our asset browser inside Blender. Let's get started. To begin, we can tab back to Object Mode. Press Q and switch off the Face Orientation overlay. Let's create a new workspace, specifically for the asset browser. Up top, right-click on the Layout tab and choose Duplicate. This creates a copy of our current workspace. Then double-click and rename this to Asset Browser for clarity. Now let's adjust our panels. Hover over the dividing line between the 3D view and the timeline editor until the cursor changes to a double arrow. Then drag up to expand the timeline editor, creating more room for our asset browser. Change the editor type by selecting the editor type drop-down, search for and select Asset Browser. The Asset Browser simplifies adding objects by linking or appending. Follow Preferences uses the settings defined in your Blender Preferences, where the default mode is Append Reuse Data. This mode ensures that any assets brought in from your linked asset libraries will share the same object data. In the drop-down, there are options like Current File, which refers to assets you've marked in the project you're currently working on. Remember, objects must be marked as assets to appear here. We've seen previously how to link external blend files as libraries via the File Paths tab in Preferences. Once linked, they're accessible from this dropdown. The Essentials category contains predefined assets like hair, which are included in the Blender version you've installed. You can right-click on any asset to view its blend file or check its location if needed. This is particularly useful when you need to see the contents of an asset blend file, like the one provided with Blender for hair models. We can close down this blend file and come back to Blender. Now let's mark a simple cube as an asset. You can do this through the Object menu by navigating to Asset and selecting Mark as Asset. Alternatively, in the outliner, right-click on the cube and choose Mark as Asset from the Context menu. The cube will then be available in the Asset browser when you switch to Current File. Blender automatically generates a thumbnail for it, but you can customize this. Select the cube, press N, and in the sidebar, that appears. You can add a custom thumbnail. Simply take a screenshot, save it, and then upload it here. This is also where you can add a name, description, and other metadata to your asset, ensuring everything is well organized and easily identifiable. To categorize our asset, click the plus sign next to Catalogs to create a new one. Double-click to rename it Mesh. Now, if you click back to Unassigned, you can drag and drop the cube into the Mesh catalog. This sorts it into the new category you've created, making it readily available for future projects. For our next step, I want to demonstrate using two blend files to set up an asset library. The first file is downloadable from my website. Open a web browser and navigate to blenderzen.com. On the asset page, scroll down and you will find the file available for download. Remember, this is a zipped file, so you need to save and then extract it before we can use it in Blender. Back in Blender, let's clear the current scene. Press A to select all objects, then X to delete them. Now let's bring in the assets we downloaded. Go to File, scroll down to Append, and navigate to the downloaded blend file. Double-click to open it and enter the Object folder to see all the available objects. To import them, select All by pressing A, and then Append to import them into our scene. We will be saving this file as an asset library, so first we can save this. So come to File and Save As. This first step is important as the file will be saved in a permanent location. This will be here in my main folder called My Asset Library. Here I can create a new folder. There will be one library folder where all blend files containing Arch assets such as this file will be stored. Rename this library _1. You can name this whatever makes sense for you, but this is just an example. These names can be changed later anyway. We can also create a second folder and rename this one library _2. Let's double click inside here, library _1. In the name field, this can be renamed Arch Assets. Now save as to save this library. Let's press Z and switch to Material Preview to check the materials on our newly appended objects. Let's start with the kettle and create an asset. In the outliner, press the period key to jump to the kettle if it's not visible. Right-click on this and from here mark as asset. Done. Down below, the kettle should be ready to boil and you can narrow the search by switching this to current file. This is now ready to be dragged and dropped into the scene. If we drag select the remaining objects, press Shift+R to repeat the last command, these will all be marked as assets. Right now, these assets are listed as unassigned, so click the plus here and create a new catalog. Rename this Chairs. If we select unassigned again, we can select this chair and drag and drop it over the Chairs catalog. That will place the chair inside. You can do the same for the remaining assets and add them to a catalog. But I'm just going to create one new catalog. Rename this Kitchen Assets. Then drag all these unassigned assets and drop them into my Kitchen Assets catalog. We are done creating the asset file now, so we can come to File and Save. Then we can come to File and New. Let's open a new blend file. The first thing we can do is press A to select everything, press X and delete. Let's come to Edit and open Preferences. Then we can open the File Paths tab. In the library asset area, we can link that asset file we just created. To add a path, we can click the plus. This will open up Blender's File Explorer window, so navigate to where you created the library folder. This will open the path to this library and make available any blend files inside. You can add more blend files to the library at any time. Now click Add Asset Library. In the name field, let's add arch_assets after library so we can tell the folder and the contents. Let's click the plus, and this time we can navigate back and select library_2. Now add this here. In the name field, we can add cube diorama. We'll get a blend file for this library shortly. We can close preferences. Let's drag up the timeline and make some space for the asset browser. Then from the editor type drop-down, let's switch this to an asset browser. We can change this from all to be the arc asset file now available here. Now all the models we marked as assets are available here in the asset browser, and each listed within their catalog. These can be simply dragged and dropped into the scene. There are 3 options when adding assets into the scene. Append reuse data is the default. This appends the asset from the library file, and any copy uses the same data. This means if I add 2 kettles into the scene and tab into edit 1, the other will also update as it's using the same object data. The append option will not link the object data, so adding another kettle and editing this will not affect any other instance of this object. The link option links directly from the original file. You can edit the original file and the changes will update on the current asset. Very useful in situations where multiple people are working on different assets for the one scene. Blender has an asset library file available, so let's look at adding this file to our ever-expanding library. I can drag in a web browser. Here at blender.org, we can click and open the download page. Here we can open the demo files page. Here the asset library demo scene is available. Let's download this cube diorama file and add this to our asset library. This should start automatically, but if it fails to start, download manually and select an alternative mirror. This is a zipped file, so it needs to be uncompressed first. I can open the download folder and unzip the file. This utility 7-zip works well on Windows. Next, this can be saved in our asset library _2. So I can drag over a second file explorer window and just use these to copy across. Open up the folder to the blend file first. Now drag this diorama blend file inside the library _2 folder. Also drag over the text file as this provides the asset information for your library. The asset library is now complete. With Blender's asset browser, the sky's the limit. Your design possibilities just became endless. We can open back up Blender. In the library dropdown, we can switch to the second library and the assets will be available here. Change this back to append reuse data. These assets can then be dragged and dropped into the scene. There are many other sources of assets available online where you can start creating materials, HDRI and asset model libraries. In this video, I want to highlight the most common issues students encounter using Blender and some solutions to help you deal with them successfully. If you want to follow along with this video, you'll find this file in the resource folder of the course. One pervasive issue when modeling in Blender is the presence of doubled up vertices. Such redundancies can cause a variety of problems, including shading, texturing, or rendering artifacts, and can also adversely affect vertex weight painting, among other things. Let's consider an example where you're trying to inset a face by initially choosing to extrude it. Press E for extrusion. If you change your mind and decide to use the inset tool instead, you might instinctively right-click to cancel. However, this action doesn't cancel the initial extrusion command. The extrusion has occurred, and to confirm, press G. You might find an additional face occupying the same space as your original selected face. One way to help ascertain the number of vertices you're working with, activate Statistics option in the Overlays menu. It will show you the count of vertices. If you select all, a standard cube, for instance, should display 8 vertices. Here, however, it shows 12, indicating the overlap. You won't always know the number of vertices, so it's always helpful to regularly press M and choose Merge by Distance. This action will remove vertices that occupy the same location, effectively eliminating any extra vertices. Yet another scenario where faces may overlap occurs when you attempt to divide a face in two. Switch to Vertex Selection and select two vertices. If you press F at this point thinking it will do the job, you're actually just creating an extra edge. To visually isolate this, select the adjacent face and press H to hide it. This reveals the extra edge. We can select the edge and press X to delete. To make the face visible again, press Alt plus H. To correctly split the face in two, switch to Vertex Selection mode. Select two vertices, and then press J to join. This will divide the face approximately without adding extra unwanted geometry. The next common problem that arises in Blender is with loop cuts not functioning as expected. Loop cuts are a valuable tool for adding extra edges to your mesh, serving to increase detail or maybe exert greater control over the subdivision surface modifier. You may encounter instances where pressing Ctrl+R to activate the loop cut tool does not yield the expected results. Specifically, you may find that only a single vertex appears as an option, which you can observe at the top of the edge. If I move my cursor down the mesh here, you'll see a preview of an edge, but the loop cut still won't fully connect from top to bottom, or wrap around the mesh as intended. The culprit behind this behavior is often an Ngon in your mesh. To clarify, if you right-click momentarily to cancel, you'll notice that all the lower faces where the edge preview appeared are four-sided polygons, or quads. However, the face at the top of the mesh here has more than four edges, making it an Ngon. Loop cuts are programmed to avoid Ngons. They simply don't know how to handle them, so they refuse to create a cut through these problematic polygons. This serves as yet another reason to steer clear of using Ngons in your mesh. If you find it absolutely necessary to create an edge loop through an area with an Ngon, you do have an alternative method. The knife tool. Activate the knife tool by pressing the K key, then select your starting point at the top of the mesh. Navigate to the bottom of your mesh and click and establish the second point for the cut. Confirm the action by pressing Enter. This way you can add an edge loop to a mesh containing an Ngon, just not through the regular loop cut command. Occasionally while modeling, you may experience the sudden disappearance of your work after pressing the 1 key. This can be particularly confusing if you're accustomed to using the keys 1, 2 and 3 for selecting vertices, edges and faces. However, it's crucial to remember that these numeric keys function differently depending on your current mode in Blender. In edit mode, pressing 1, 2 or 3 allows you to select vertices, edges or faces, as you're probably familiar with. However, when you're in object mode, these same keys actually serve to toggle different collections on and off. For example, if you press 4, all collections except for the fourth one will be hidden from view. Similarly, pressing 5 will hide all collections other than the fifth one. If you find yourself in a situation where multiple collections have been hidden and you want to make them all visible again, there's a straightforward solution. Simply press and hold the Control key while clicking on the eye icon in the outliner. This action will unhide all your collections, restoring visibility to your viewport. On occasion, you might find yourself pressing the M key and merging all vertices to the center, leaving you with a lone vertex. While this may seem straightforward, it presents some challenges in Blender's interface. For instance, if you switch to edge selection mode, this solitary vertex becomes invisible. The reason for this is simple. In edge mode, you need a pair of connected vertices to form a visible edge. Similarly, in face selection mode, you'll also notice that nothing is displayed because a face requires at least 3 connected vertices. Attempting to extrude this single vertex while in edge or face mode won't yield the result you're aiming for. It will merely move the existing vertex. To properly extrude, you'll need to switch back to vertex selection mode. Once there, pressing the E key will allow you to extrude the vertex, thereby forming an edge. However, be cautious. When you're in face selection mode and you try to extrude by pressing E, doing so won't create a new face. it will only move the edge you've formed. If your goal is to create a face, you must either be in vertex or edge selection mode. For instance, while in edge selection mode, pressing E will extrude the edge, creating a new face in the process. Now, when you switch to face selection mode, you'll find that the new face can indeed be selected and extruded. When working with multiple objects in a Blender scene, the need to zoom in closely for detailed work can arise. For instance, zooming into the first monkey head object may present no difficulties. Similarly, zooming into the second monkey head could also be straightforward. However, when you attempt to zoom into the last one here, you might notice that your zooming capabilities are suddenly more restricted. The reason for this limited zoom range can be attributed to the view mode you're currently in, typically user perspective. One way to circumvent this restriction is to switch your view mode to orthographic. Unlike the perspective mode, orthographic view removes the limitation on how closely you can zoom into an object. To switch to orthographic view, use the relevant controls in your Blender interface. Once you're in this mode, you'll find that you can zoom in extremely close to your object without any hindrance. Alternatively, if you prefer to work in user perspective mode but still want a workaround for the restricted zoom, you can engage the fly mode. To enter fly mode, press Shift along with the tilde key. In this mode, you can use the W, A, S and D keys to navigate around your scene freely. Once you're at a desirable viewpoint, simply left-click your mouse to exit fly mode and lock in that position. This provides another effective method for circumventing zoom limitations in Blender. When working on a Blender scene, you may inadvertently press the spacebar, causing unexpected movements or disappearances of objects within your scene. To understand why this is happening, let's consider an example. Say you select an object and move it to a new location, then advance the timeline to frame 100. Now move the object again. In each of these instances, Blender automatically adds keyframes that record the object's transformations, such as position changes. The root cause of this automated behavior is the auto keying feature, which is usually toggled on via this button. When enabled, this feature automatically adds keyframes to the timeline for any changes you make to an object's properties, like position, rotation, and scale. Essentially any attribute that can be keyframed. Although the auto keying feature is invaluable when animating, it can become an annoyance if it's turned on unintentionally, especially if you're not aware of its capabilities or forget it's activated. Therefore, if you notice objects moving or changing in unexplained ways, it would be prudent to check the status of the auto keying button to see if it's enabled and toggle it off if necessary. In this video, we look at object and edit mode and manipulating primitive meshes. Let's get started. In this introduction to Blender Basics, we look at the fundamentals including object manipulation, basic modeling, materials, lighting, rendering, camera usage, and animation. This short section is designed for absolute beginners to Blender to help them get a better grasp of the software. So if you know the fundamentals, feel free to skip ahead and continue with the next section. Let's begin by coming to File, New, and create a new general blend file. 3D modeling is the process of creating a three-dimensional representation of any surface or object by manipulating polygons, edges, and vertices in 3D space. This can be achieved through a variety of techniques like polygon modeling, digital sculpting, or primitive modeling. One fundamental concept within Blender is its system of modes. These modes govern what operations can be executed on an object and what can be selected in the 3D viewport's header. The modes available are dependent on the type of the active object. When you fire up Blender, the software opens in object mode by default. In object mode, you can interact with whole objects, which means you can select, move, rotate, and scale objects. Moreover, this mode allows you to add new objects to your scene or remove existing ones. Here you can establish properties that apply to the entire object, such as setting up materials, applying modifiers, or defining physics properties. Keep in mind that any transformations you apply in object mode are based on the object's origin point and they impact the whole object. On the other hand, edit mode is where you alter the structure of your object. We can transition into edit mode from the mode menu, or as we'll do throughout this course, by pressing the tab key. This action toggles between object and edit modes. In edit mode, you can manipulate the individual vertices, edges, and faces of an object. Here you can subdivide faces, extrude faces, bevel edges, merge vertices, and more. Essentially, edit mode is where the detailed shaping of the 3D object takes place. Importantly, even in edit mode, you're still working with the same object, but now you're altering its internal structure. To put it simply, object mode deals with the macroscopic view of where objects are in relation to one another, while edit mode enables you to fine-tune the details of each individual object. You'll often find yourself switching frequently between these two modes during a typical workflow in Blender. Let's press tab and switch back to object mode for now. Take a look at this cube. It's a type of primitive object, often used as a base for modeling. When you initiate a new project in Blender, a default cube is typically present right in the middle of your 3D workspace. As you can see, it's simply a geometric shape, a six-sided object that can serve as a good starting point for numerous modeling projects. Blender also provides other primitives such as spheres, cylinders, and cones. I can quickly add these into the scene. Let's move these primitives aside for a better view of each. These basic shapes are frequently used in a method called primitive modeling. In this approach, you start with these basic shapes and then modify and combine them to create more complex models. Depending on the shape of the object you intend to create, the sphere primitive might be an ideal choice. For instance, modeling a character's eyes or the base shape for head sculpting could begin with a sphere. Using these primitives as starting points can save considerable time as you develop your model. Alternatively, a cube can be resized in object mode to approximate the size of an object you want to model. For example, you could quickly create a rectangle top for a table. In the Y dimension field, let's input 3500 mm. Then tab into the Z dimension and input 100 mm. As you can see, you can rapidly transform the dimensions of a primitive cube into an object just by modifying its dimensions. In this video, we look at vertices, edges, and faces. Let's get started. A vertex is a fundamental unit in 3D modeling and computer graphics. In the simplest terms, a vertex is a point in 3D space that has coordinates. In Blender, you can switch between vertices, edges, and faces using the three buttons up top here. Alternatively, use the shortcuts 1, 2, and 3 to switch between each. In the sidebar, shortcut N. Here the coordinates of each vertex get displayed when selected. So if we select this top corner vertex, we can see that the coordinates are 1 in the X, -1 in the Y, and 1 in the Z. Now you may realize something as you look at these. 1 meter in the Z doesn't add up, nor does the Y coordinate. We changed the size of this table top to be 100 millimeters in the Z and 3500 in the Y. When you make changes to an object dimensions or scale in object mode, the scale needs to be applied before the mesh updates. It works from the old data until being applied. This is true for UVs, modifiers, and right across Blender. So if we press tab and come back here, we'll notice that the scale on the Y and Z are non-uniform and need to be applied. So let's press Ctrl+A and apply that scale. So now, if we tab back in here, we can see that the mesh data has updated to correctly represent the vertex positions. Vertices are used to define the shape of polygons in 3D modeling. They serve as the corners or endpoints where edges of a shape meet. You can move a vertex in any direction to change the form of the model. Use the move manipulator to drag and reposition. While you can accurately position the vertex using the fields, more often you'll use the move manipulator to position them. In addition to defining the shape of an object, vertices can also hold additional information that influences how the object is rendered. This can include data like color, texture coordinates, normals, which determines how light interacts with the surface, and weights for skeletal animation. So not only being a point in space, but in combination with other vertices, define the shape and surface of a 3D model. Next up is the edge. This is a straight line segment connecting two vertices. Together, edges define the structure and shape of the 3D object. Edges can be thought of as wires in a wireframe representation of the model. Edges play an important role in defining the topology or flow of a 3D model, especially in models that will be animated. Good edge flow can help to ensure that a model deforms correctly when it moves. Just like vertices, you can manipulate edges to modify your 3D model. You can select, move, scale, rotate, extrude, bevel, to name but a few. In addition to defining the model's shape, edges can also be used to control shading and appearance of the model. For example, sharp edges can be defined to create a creased or faceted look. There are a couple of ways to add vertices, edges, and faces. You can create an edge between two vertices using the New Edge Face command. That can be found here in the Vertex menu. Works on vertices, edges, and faces. So if we select this vertex, press Shift+D to duplicate, X to restrict it to the X-axis, and just drag this away. If we press and hold Shift and select the first vertex again, press F and this will create an edge. You can also select the vertex and press E to extrude a new edge and form it this way. You can create a vertex center of this edge if you have two vertices or an edge selected. Actually, if we switch to Edge Selection, then select this edge, right-click and subdivide. That splits the edge into two. So if we switch back to Vertex Selection, there is a vertex center. You can also select two vertices and right-click and subdivide to add one center. The options box lets you increase that number if necessary. Faces can also be subdivided, so switch to Face. Select the top face here. Right-click and choose Subdivide. This splits the top face into 4, 2 by 2, along the X and Y. You'll also notice it only subdivides the top face. Let's undo subdividing with Ctrl+Z. If you wanted an edge loop connected all the way around, you can use the Edge Loop tool. Press Ctrl+R to add an edge loop all around the mesh. Left-click and right-click to place center. You can remove a vertex by selecting it, pressing X and delete vertex. However, it also removes the edges connecting. Instead, we can press Ctrl+C and undo. If we press X and choose Dissolve Vertices, that maintains the edges but removes the vertex. You can also dissolve edges and faces without removing connected geometry. In this video, we look at adding edge loops and extruding faces. Let's get started. To begin, let's come to File, New, and start a new General Blend file. We'll be working with all three objects during this introduction: the cube object, the default camera, and the light object. But for now, we'll be focusing on the cube and creating some basic shapes. To get started, select the cube and press the Tab key to enter Edit Mode. In Edit Mode, you can scale the object without needing to apply transforms, since you're directly editing the mesh. First, let's scale up the cube along the Y-axis to double its length. There are a couple of ways we can do this. You can use the Scale tool by coming over to the Tool shelf, shortcut T. Select the Scale tool. Grab the manipulator along the Y-axis and drag it out. While it's selected, input 2 and press Enter to confirm the operation. You can verify the scale in the options box below here, where the Y scale field should show 2. Next, let's add an edge loop around the mesh along the X-axis. To do this, let's press Ctrl+R to add an edge loop. When hovering the cursor close to the mesh, you'll get a preview of where the edge loop will be added. Left-click once to control the edge loop, and then you can manually position it. If we just right-click to cancel movement, it will be placed exactly at the center of the face, which is what we want. The reason for adding edge loops is to split the mesh into two top faces. We want to extrude from the back face, so switch to Face Select mode and select the back face. On the tool shelf, choose the Extrude Region tool. Click and drag to start extruding, then input 2 and press Enter. You can verify in the options box that it was 2 we extruded. Tab back to Object Mode for a moment. In the sidebar, Under the Item tab, you can see the dimensions for the cube. It should now show 2 meters in the x-axis and 4 meters in the y and z. Remember that modifications made in edit mode will be reflected in object mode once you tab back. In this video, we look at the shading modes and selecting mesh elements. Let's get started. With the cube selected, let's tab into edit mode. If any vertices are selected, we can deselect them by pressing Alt plus A. Let's come up to the top right corner of the viewport here. This is where you'll find the different shading options: wireframe, solid shading, material preview, and rendered. Let's switch to wireframe shading for a clearer view of our cube structure. A quick tip, you can also access these shading options via a shortcut. Press Z to open the pie menu and select your preferred shading mode. Each mode has a number listed beside it for easy access. For example, pressing 6 will switch to solid shading. Repeating the Z key and pressing 4 switches to wireframe. This quick number selection can speed up your workflow if you are comfortable using the keyboard. Now let's switch our selection tool back to Select Box on the tool shelf here. Depending on what part of the mesh you want to work with, you can toggle between vertex, edge, and face selection modes. You can do this either from the menu at the top or by pressing the keys 1, 2, or 3 respectively. In vertex selection mode, you can easily select any vertex on the mesh, indicated by black highlights on the corners. Switching to edge selection mode, you can select any of the edges, also highlighted in black. Similarly, in face selection mode, you'll see a black dot that represents the center of each face, which you can select. Let's switch to edge selection mode and select the top edge on the cube. Our goal is to move this edge back by 1 meter. This can be achieved by pressing G for move, followed by Y to restrict the movement to the Y-axis. Input 1 and press enter to confirm the movement. If you wish to adjust the move properties after the transformation, you can do that in the properties box located at the bottom. Alternatively, you can also adjust the edge movement along the Y-axis in the Item tab at the top of the viewport. This flexibility allows for precise control and modification of your 3D models in Blender. In this video, we look at how to duplicate and mirror an object and correcting reversed normals. Let's get started. Let's continue from where we left off in the last video. In edit mode, our next step is to duplicate and mirror half of this model along the Y-axis to construct the back half. There are multiple ways to do this, but let's start with the mirror command. When you mirror an object in Blender, you mirror it around a pivot point. In our case, this pivot point will be the 3D cursor. So we first need to position the 3D cursor to serve as the pivot. Select this bottom edge here. Press Shift plus S to open the snap menu and then select Cursor to Selected. You can also find the snap menu at the top in the mesh menu, where you can also choose Cursor to Selected. To utilize the 3D cursor as the pivot, we need to switch the pivot point to the 3D cursor. You can do this from the pivot point menu. Now select all vertices by pressing A. We're going to duplicate these vertices, then mirror the duplicates. To duplicate, you can come to the mesh menu and select duplicate. The shortcut for this is Shift plus D. As soon as you duplicate, you gain control to position the vertices. But right-clicking will cancel any movement. To mirror the selected vertices, let's return to the mesh menu, and here you'll find the mirror command, interactive mirror. Let's select that. This command becomes open. As you can see at the bottom, you have a list of commands available. The first allows you to choose an axis, X, Y, or Z. We want to mirror along the Y-axis, so input Y and press enter to complete the command. There is one caveat when using the mirror command. If we switch to solid shading from the shading menu, then if we come to the overlays menu, we can activate face orientation. You'll notice that the faces are red, indicating reversed normals. To fix this, select everything by pressing A. Then press Shift plus N to recalculate the outside normals. This step isn't critical for these videos, but it's good practice to follow. Now let's turn off the face orientation overlay from the overlays menu. We can also switch back to wireframe shading. Lastly, we need to remove the internal faces connecting the front and back sections. Switch to face select mode. When we mirrored the model, we also included the end faces, which have now become internal faces. Let's select these faces. There should be 4 in total. Press X and we can delete faces. Ensure all 4 are deleted. The small black dot center can help identify faces. In this video, we look at how to merge vertices and how to use the snap command and its relationship with the zoom level in the 3D viewport. Let's get started. In the previous video, we duplicated and mirrored the vertices on one side of our model. However, while these duplicate vertices are positioned identically to the original, they are not connected. If you select one and press G, it separates from the center. You can cancel this action by right-clicking. This situation often occurs when you duplicate or snap vertices. The only time vertices are inherently connected is when you extrude them. To connect these separate vertices, we can use the merge command. But before we do that, let's turn on statistics in the overlays menu. This feature gives you a count of the objects, vertices, edges, and faces. Now select all vertices by pressing A. This now displays 32 vertices, and we know that 6 of these along the center need to be merged. In the Mesh menu, let's navigate to the Merge submenu, and in here we can select by distance. The information reading at the bottom indicates that 6 vertices were removed. The Merge command combines the vertices that are within a certain distance of each other, in this case 0.1 millimeters. The vertex count has now updated to reflect the new number. If you select one vertex in the center now and press G, you'll see that the duplicate vertices have been merged into one. It's crucial to regularly check for and remove overlapping or duplicate vertices, as these can lead to issues with shading, UV mapping, and more. Our next step is to form the wheel wells. Let's switch to edge selection mode, then press and hold Shift to select these 2 edges. Now let's move into a side view by clicking the View gizmo, and also switch to an orthographic projection for a full side-on view of the model. The default snap type in the Snap menu is Increment, which allows you to snap in set increments depending on your zoom level. For me, this level is displayed as 10 centimeters. However, note that you won't see your zoom level if you're in a perspective view, so you need to be in an orthographic view for this to be visible. Let's switch the pivot point back to medium point in the pivot menu and activate the move manipulator in the tool shelf. Instead of switching on snap, we can activate it using the control key. If you click and drag on the Z axis and press Ctrl for snap, you'll see that we're snapping in increments of 10 centimeters, as displayed at the top. Above this is the actual distance we're moving the vertices, which in this case is 1 meter. We can position these here. To illustrate how zoom level affects snap distance, if I zoom out to a level of meters, grab this arrow and press Ctrl to activate snap, you'll see it snapping in increments of 1 meter at a time. So remember, your zoom level significantly influences your snap distance. In this video, we look at insertion points for new objects and how to correctly apply rotation and scale transforms. Let's get started. The next step is to add the wheels, but first we need to set an insertion point for the cylinder object that will form the wheels. Switch to vertex selection and select the 2 bottom vertices on the wheel well. Press Shift+S to open the snap menu and select cursor to selected. Although we could add a cylinder in edit mode of the current object from the add menu, we want the wheels to be separate objects, so let's switch back to object mode first. From the add menu in Mesh, let's add a cylinder. To visualize this better, let's press Z and switch to solid shading. We'll need to rotate the cylinder, which we can do in the rotation transform field. In this case, we want to rotate the wheel around the Y-axis. The rotation gizmo can be useful for determining the correct axis. Click in the Y field and input 90 to orientate the wheel correctly. we also need to scale down the cylinder a bit. Let's click and drag in the XYZ fields in the Scale Transform section. This lets you input and update all 3 value fields simultaneously. Input 0.8 here to uniformly scale the cylinder down. Now we want to scale the cylinder along the x-axis to get the right width for the wheel. But when I try to scale on the x-axis, it also squashes the cylinder vertically. The reason for this is that the object has a non-uniform rotation transform. To correctly scale it on the x-axis, press Ctrl+A and apply the rotation. Now if we click and drag on the X field in the Scale Transform section, we can reduce the width of the cylinder. Press the Shift key for smaller increments and reduce this to 0.3. Then press Ctrl+A and apply the scale to solidify these changes. In this video, we look at how to refine and detail using tools such as Inset, Extrude, and the Subdivision Surface modifier. Let's get started. Next, let's focus on refining the shape of our wheel. We can start by isolating the wheel for closer inspection. Press the / key to enter local view, which is indicated in the top corner of the interface. This view is handy when you want to concentrate on just one object. Now press Tab to enter edit mode. Switch to Face Select, and we can select the outer face of the wheel. Let's rotate around, and holding Shift, we can select the inner face of the wheel as well. On the tool shelf, select the Inset tool. Left-click and drag inward to start insetting the faces. You can input a specific value, but for now let's simply release to finalize the inset. In the Inset properties, adjust the thickness value to 0.2. Next, press E to extrude, then right-click to cancel movement. Press S, then X and push inwards a little bit. In the Scale properties, round the X scale to 0.5. Again, use the Inset tool to create an inset on the outer face. Then in the thickness field, find a value that looks right. A value of 0.5 will work well here. Next, we can switch to the Extrude tool on the tool shelf. Select the outer face, then left-click to extrude outward. We can input a value of 0.1 and press Enter. Next, we can navigate to the Modifiers tab, and here we can add Modifier and add a Subdivision Surface modifier. Increase the levels on the modifier to 2. The Subdivision Surface modifier smooths and refines the appearance of a 3D model by subdividing its faces and edges, which is ideal for creating smooth shapes. To further control the smoothing effect, press Ctrl+R to add an edge loop. Hover over the area where you want to add the edge loop. Then use the mouse wheel to increase the number of edge loops to 2. Left-click to confirm. Then right-click to exit the tool. Press S, then X and drag outwards slightly to reduce the rounding of the corners. Press Ctrl+R again to add an edge loop within the wheel. Left-click and push inward. Then left-click again to confirm. Switch to Face Select and select the outer face. Switch back to the Insert tool and make a small inset. Inset once more. Then press M and select Merge at Center. This combines the vertices to one at center. Finally, add an edge loop inside the wheel by pressing Ctrl+R. Push this inward to add more shape to the wheel. In this video, we look at assigning different materials to specific parts of the 3D model and how to modify material properties such as base color and metallic values. Let's get started. Now let's add some materials to the different parts of the wheel. But first, the cap of the wheel needs a little edit to help define the transition from the hub. To help with that, in the Modifiers tab, on the Subdivision Surface modifier, enable this On-Cage setting. That way, we get a better preview of the effect of the modifier, without the overlay. Let's add an edge loop now. Press Ctrl+R and left-click. Then push in and add a little definition here. Head over to the Materials tab now. Start by clicking New to add a new material. Then in the name field, let's rename this tire. Press Enter to finalize. In the base color option, click the color swatch and darken it towards a black color. If you hover the cursor over the color field, we can press Ctrl+C to copy that value. This will be useful in a moment. We can preview the colors in the viewport, so let's scroll down towards the bottom of the Material tab. Look for the viewport display area. Click and drag it right to the top for easy access. Now expand it. Hover the cursor over the color field and press Ctrl+V to paste in the color value we just copied. This gives us a viewport representation of the color. Instead of having to switch to rendered or material preview, you can stay in solid shading and preview materials in the scene. Let's switch to face select mode. If we press and hold Alt, then left click, we can select these internal faces of the tire. Rotate the view to the opposite side. Press and hold Shift and Alt select the corresponding faces here. Then press Ctrl+Numpad+ to expand the selection by one face. Back on the Material tab, click the plus icon to add a second material slot for the rims. Click New to create a new material. Let's rename this to Rim. Adjust the base color. I'm just going to make this a lighter shade. Hover over the color field. Press Ctrl+C to copy that value. Then we can Ctrl+V to paste it into the viewport color field. You'll notice that the color hasn't changed yet. This is because we need to assign this new material to the selected faces. Click the Assign button and the material gets applied to the selected faces. Finally, we can add a material to the center cap on the wheel. Let's drag and select the front faces on the hub. Press Ctrl+Numpad+ twice to expand the selection. Over in the Material tab, add a new material slot. Then create a new material. Rename this to Cap. Adjust the base color to a dark shade. Then scroll down further and increase the metallic slider to 1, giving it a metallic material appearance. Hover over the base color field, press Ctrl+C to copy the color value. Then paste it into the viewport display color field using Ctrl+V. Finally, assign this material to the selected faces. We can return to object mode by pressing Tab. Then we can right-click and choose Shade Smooth to smooth out the faces and give the wheels a more realistic appearance. In this video, we look at how to set up environment lighting and how to use the Dynamic Sky add-on to create a procedurally generated sky environment. Let's get started. Let's begin by pressing the / key to return to Global View. Before we proceed to finalize the car's material, it's an opportune time to set up some environment lighting. This will allow us to preview the materials in a manner that closely resembles their appearance when rendered. Blender provides several lighting options for your scene, such as high dynamic range images, scene lights, and 2 other options that we can explore now. Firstly, let's head over to the Render Properties tab. For this demonstration, we'll switch the render engine to cycles, as the first option we're about to use is only supported in this mode. Next, switch to the World tab. In the Surface section, click on the small yellow dot next to Color. From the options that appear, select Sky Texture. For a better view of what we're doing, switch to the Shading workspace. This is a dedicated workspace for editing materials and lighting. Change the data type drop-down to World to display the nodes related to this lighting setup. In the 3D view, press Z and switch to Rendered mode. You can now see the rendered sky in the background. The Sky Texture node has several adjustable settings, such as sun size, intensity, and elevation. As you lower the elevation value, it changes the sun's position on the horizon, altering the color of the sky. Rotating the 3D view allows you to see these changes more clearly. Adjusting the rotation and elevation of the sun can create various effects suitable for different scenes. Now let's explore the second lighting option, which is an add-on. Head over to Edit and open Preferences. In the Add-ons section, search for Dynamic. Then enable the Dynamic Sky add-on. Additional information about the add-on can be found in the documentation link provided. We can close the Preferences window. Press N to open the sidebar. Then we can come to the Create tab where the Dynamic Sky add-on is available. Click on Create to generate a new dynamic sky. Then we can switch to the World tab. From the drop-down, we can change the environment texture to the dynamic sky we just created. This add-on gives you a different style of environment lighting. Rotating the view shows you a sky filled with clouds. You may need to reselect the dynamic sky from the menu if the settings fail to appear. Then the settings for this procedurally generated sky can be adjusted, but for now I'm going to stick with the default settings. In this video, we look at how to use the bevel modifier to soften the edges of the 3D model. Let's get started. Let's begin by returning to the Layout tab. We can click the camera button to switch to the camera view. From there, open the View tab and tick on the Lock Camera to Selected checkbox. This allows us to navigate within the camera view, so we can adjust our view of the car. Once you're happy with the framing, you can untick the checkbox to lock the camera in position. If you try to rotate the view now, you will simply exit the camera view. Click the camera button again to return to it. Now let's switch to the material preview to preview the material. Ensure that the car is selected and navigate to the Materials tab. If you don't already have a material on this car, then click New to create a new material. Let's rename this material to Car. Moving down to the base color, let's change it to a rich red color. We can also adjust more material settings to enhance its look. For instance, reduce the roughness value to 0.2 to increase the shininess of the material. After setting the base color, hover over it and press Ctrl+C to copy the color value. Scroll down to the Viewport Display section and press Ctrl+V to paste the copied color value. Next, we'll add a glass material to the car. To do this, switch to Edit mode. Hold Alt and select all the upper faces where the glass will be placed. Once you have selected all the appropriate faces, press I to create an inset. The initial inset is connected, but if you press I again, it will switch to individual faces. Set the inset to 0.2 and create a frame for the glass. With these faces still selected, head over to the Material tab. We can click the plus icon to add a second material slot. Click New to create a new material, and rename this material to Glass. Click the Assign button to apply this material to the selected faces. Next, click on the button next to the Surface field, and switch from the default BSDF shader to a dedicated glass shader. Change the color to an off black. Copy this color Ctrl+C and paste it Ctrl+V into the Viewport Display color field. Now switch back to Object mode. At this stage, the edges of the car may appear too sharp. To address this, let's come to the Modifiers tab and add a bevel modifier. Adjust the amount and maybe reduce it first. If we increase the segments to 6, it's then possible to give the edges a nice rounding, mitigating the sharpness. We can right-click on the car now and shade smooth. In this video, we look at how to set up and use drivers to create a relationship between different objects and properties, and how to use the mirror modifier to create identical copies of an object along an axis. Let's get started. We'll begin by setting up drivers that will make the wheels rotate as the car moves forward. Start by selecting the car and press F2 to rename it as car for easier identification. The updated name will also reflect in the outliner. Next, select the wheels. Then open the Item tab. In the X rotation field, we can right-click and choose Add Driver. This will open the driver properties. If you happen to move the cursor away, the window will disappear. Simply right-click again and choose Edit Driver. In the Expression field, we can remove back to VAR, then add multiplied by -1. For the object, we can click in here and find and select car. For the type, we can choose the Y location. Now when the car moves forward, the wheels will rotate accordingly. However, it might be hard to see if the wheels are rotating. To make it more obvious, we'll add details to the wheels. Select the wheels and switch into Edit mode. Hold Alt and select the rim of the wheels. Then from the Select menu, we can use Checker Deselect to deselect every other face. Press E to extrude these faces out slightly. We can tab back to Object mode. Now when we select and press G to move the car, it's easier to see the wheel rotating. Next, we want the wheel to actually move along with the car. The easiest way to do this is by parenting both objects to an empty. Select the car and switch to Edit mode. Switch to Edge Selection mode. Select the bottom center edge of the car. Then press Shift+S and choose Cursor to Selected. Then switch back to Object mode. From the Add menu, we can come down and from Empty, add an empty plane axis. An empty is a point in space which can control the transforms of other objects. To parent the car and wheels to the empty, first select the wheel. Then press and hold Shift and select the car. And finally the empty. The order of selection matters here, so make sure the empty is selected last. Press Ctrl+P and choose Object Keep Transform from the parent menu. Now if you select the empty and move it, both objects will move together. To duplicate these wheels, one of the easiest ways is to use a mirror modifier. Move to the Modifiers tab and add a mirror modifier. Move it to the top of the stack as we want to apply it soon and modifiers need to be applied in order, top down. Right now it's not doing anything because the origin of the wheel needs to be set at the center of the car. Luckily the 3D cursor is at the center. So with the cursor at this point, right click and choose Origin to 3D Cursor from the Set Origin menu. As you do this, the wheel will update on the other side along the X-axis. Also enable the Y-axis to mirror the wheels to the back of the car. Now select the empty. Press G, Y and the wheels will rotate from their origin point. We need to separate these wheels into individual objects and set their locations back to their centers. We can start by applying the mirror modifier. So over here from the drop down, apply the modifier and make the geometry permanent. Then switch to Edit mode. Press A to select all, then press P to separate by loose parts. This separates each wheel into an individual object. Let's tab back to Object mode. Next, set the origin of each wheel back to its center. Right click and choose Origin to Geometry. This will place the origin at the center of the geometry. Now we can use the shortcut Shift+R to repeat the last operation for the remaining wheels. Finally, if you select the empty and move it along the Y-axis, all wheels will follow and rotate correctly. In this video, we look at how to use the array modifier to create multiple instances of a mesh along a specified axis. Let's get started. Next, we can create the roadway. Let's use the view manipulator to come into a side view. Zoom in to a level of 10 centimeters. That way we can press G, Z, press and hold Ctrl and snap up along until the wheels are sitting on the green line here. Let's put the cursor back to World Origin. To do this, press Shift+S and choose Cursor to World Origin. Then from the Add menu in Mesh, let's add a plane. Let's scale it up. So press S, input 10 and enter. Before we edit this, let's apply that scale. So press Ctrl+A and apply scale. Now let's tab into edit mode. We can press Ctrl+R to add an edge loop. We want this running along the Y-axis. Use the mouse wheel to increase the number to 2. Then we can left click and right click to center it. Then press S, X and we can scale these out on the sides. These are going to help form grass verges. Let's add another 2 edge loops. So press Ctrl+R, roll the mouse wheel, left click and right click. Then we can scale this in to be the center line on the road. So now let's switch to Face Select and select the 2 outside faces. In the Material tab, let's click New to create a new material. This one will be the roadway, so let's rename this to Road. Then we can add a second material slot, create a new material. Let's rename this to grass. Then let's add a third material slot. Create a new material. Let's rename this line marking. If we select the grass, we can give this a dark green color. Use Ctrl+C to copy that color. Down below, paste it into the viewport display. We can also do the same for the road. Let's darken this. Press Ctrl+C to copy. Down below, press Ctrl+V to paste. With these two faces still selected, let's select the grass material slot and hit Assign. Select the center face on the road, then select the line material, and we can assign that here. Let's tab back to Object Mode. If we come to the Modifiers tab, in here we can add an array modifier. The array modifier creates an array of the selected objects, in this case our roadway. Now currently it's arraying this object along the x-axis, and that relates to the factor x value of 1 here. Instead, let's input 0. In the factor y, we can input -1 because we want this to array along the negative y direction. So when we do that, we can then increase the number. So let's just drag this up to maybe 15 and increase our roadway in length. Let's take a look at what we have so far. We can press Z and switch to rendered preview. That's beginning to look pretty good. Now one thing you'll notice is this lamp is causing a reflection on the plane. In the light properties, let's switch this to be a sun lamp. We can reduce the value to 1 to reduce the intensity. Then in the scene, let's press G, Z and drag it up out of the way. In this video, we look at setting keyframes that store the location and rotation data for animation and how to create and manage multiple cameras using markers and a track 2 constraint. Let's get started. Our next task is to animate the car moving along the road, which will be captured by the scene camera, as well as an additional camera that we'll set up shortly. Let's commence by adjusting our first camera to capture the car as it starts to move. For this, we'll have the camera rotate around, keeping the car in frame. Let's switch into the camera view. We can move to the view menu and check on Lock Camera to View. This will allow us to adjust the camera and frame up the car for the desired starting position. Once framed, we can deselect Lock Camera to View. Now, with the camera selected, we can add a keyframe to store its current location and rotation data by pressing I and choosing Location and Rotation. A small yellow dot on the timeline signifies that this keyframe has been added to frame 1. Drag this up to make a little bit more space. The empty object controlling the car also needs a keyframe added at the beginning and end. Select the empty. Press I and add a location rotation keyframe. Then let's move the scrubber to the end of the timeline, frame 250. This animation can be any length, but let's work with 250 for the moment. Next, let's exit camera view. Press G, Y and drag the car to the end of the road. Press I again to store these transform values. Now, when you press the spacebar, the car moves from the start to the end of the road. Return the scrubber back to the beginning. Let's actually come up to the Layout tab and we can right-click and duplicate layout. We can double-click and rename this Double. This way we have one viewport in camera view and the other to manipulate the objects in the scene. So let's come up and hover the cursor on the top right here. Left-click and drag to create a second viewport. We can jump into camera view in the left side viewport. Let's make some space and close the tool and sidebars with the shortcuts T and N. Let's come into a top view in the right side 3D view. In the timeline, let's drag the scrubber along to frame 50. We can hover the cursor in the viewport, then press R to rotate the camera around to frame up the car at this location. Then press I to insert a location rotation keyframe. So now if we grab the scrubber and drag back, we're capturing the car as it moves off the line. Next, bring the scrubber back to about frame 30 and where the car isn't fully framed. In the scene, let's rotate the camera around until the car is fully framed. We can press I and capture the location rotation values for this new position. That's a little improvement on the shot. Next, let's add a second camera to the scene. Place the 3D cursor at world origin, so press Shift+S and choose cursor to world origin. We can add the new camera, so press Shift+A and from the add menu, add a camera. We can move the camera about 2/3 down the roadway. So press G, Y and drag this down here. We can also press G, X and drag it off the road. We'll use a track to constraint and make this camera look at and track the position of the car. In the Object Constraints tab, let's add a track to constraint. We can select the car as the target object. In the timeline, let's drag the scrubber along to frame 51. Now we need a way to switch between the cameras and we can use a marker for that. So with the camera selected and the cursor in the timeline, press M to create a marker. Now we need to bind this. So from the marker menu, we can bind cameras to marker. So now when the scrubber hits frame 51, the scene switches to this camera. We also need to add a marker for the first camera. Select the second camera. So let's bring the scrubber back to frame 1. In the timeline, press M to add a marker. Then from the marker menu, we can bind camera to marker. This switches us back to the first camera. Now let's play the animation. We begin in the first camera, and when we get to frame 51, the marker switches us into the second camera, tracking the car as it passes by. In the next video, we'll continue with rendering this animation. In this video, we look at the process of rendering an animation in Blender and how to use Blender's video editing workspace to compile rendered images into a video file. Let's get started. Once you're happy with how your animation looks, we can give this a preview. So let's press Z and switch to rendered preview. If you come over to the Render Properties tab, you can now decide whether you want to render with Blender's real-time rendering engine Eevee or with the physically based render engine Cycles. I'm going to render with Eevee just because it will be faster. There are a couple of settings we can switch on to enhance the render. The first is ambient occlusion. Ambient occlusion creates soft shadows that give a greater sense of depth and weight to the objects. This can help make your renders look more real. Also, enable screen space reflections. This is a technique used in real-time rendering engines to simulate reflections in real time. If we come down to color management, and in the look, you can set it to something like medium contrast to enhance the colors a little bit more. Let's come to the Output Properties tab. This is where we set up the output file format and folder. This will be rendered out as a sequence of PNG images. Then we'll bring those into Blender's video sequence editor and render a movie file. So make sure the format is PNG. Next, we need an output folder for the 250 images. Click the folder icon and find a folder to save the files. I can put these in my project folder. We'll need these shortly, so remember where to save them. We can accept this. Now to render the images, let's come up to the render menu and render animation. That will work through and render all the images, and I can speed this up. Once that completes, let's close the image editor. I'm going to press Ctrl+S and save this file. That way we can come up to File, New, and start a new video editing file. This opens up into Blender's video editing workspace. It has a video sequence previewer editor up top here and the sequencer down here where we can add the image strips. It also has a properties editor. Let's add in the images we rendered out. So let's come to the Add menu and we can come down and choose Image Sequence. Navigate to where you saved those images. We can press A to select them all, then add Image Strip. So now, if we press the spacebar, we can preview this playing back in the video sequence previewer up here. When you play that through the first time, it caches to memory, so it will play back at the full 24 frames the next time around. The next thing to do now is render this out as a video file. So let's come up to the top right here and to the Output Properties tab. We can come down and by default it's set to FFmpeg and that's going to be fine. We can expand encoding. Here we can use an MP4 container. with the video codec of H.264. If you want to add sound effects, you can come down to Audio, and from Audio codec, choose one from here. AAC or MP3 work well. If you are adding sound files, you can come to the Add menu and just add in your sound files from here, then arrange them to suit the video. We're just going to render this out as a video without sound. So with everything set up, we need to pick an output folder. So let's just select the folder icon, navigate to where you're going to save this video file out. Again, in my project folder, I can create a new folder, rename this output video. Then double click inside. Now accept this. Then to render the animation, let's come down to the render menu and render animation. That will run through and render out a video file, and I can speed this up. When that completes, I'm going to double click my video off screen. This starts playing in VLC, which is a free open source media player available to download for free. Hopefully that was a helpful introduction series to Blender editing and some of the other tools you'll find within the application. In this video, we look at what is unit scale in Blender and how to work using metric or imperial. Let's get started. To begin, we can come to File, New, and open a new general blend file. Let's open the Scene Properties tab and expand the units area. By default, Blender has the unit system set to metric. There are three options: metric, imperial, or none. Metric and imperial we're all aware of. None are an arbitrary type. We will be leaving the unit scale at 1 as we will be working exclusively in Blender for this course. The unit scale represents the scale factor being applied and how they are displayed. There are instances where you might change the scale. For example, if you are exporting your model to a game engine such as Unreal Engine, Unity, or Godot. For Unreal Engine, this scale could be reduced to 0.01 to match centimeters used by the engine. Another example is when we are importing the DXF file. We could reduce this scale to 0.001 and match FreeCAD millimeters. However, we will leave this at 1 and scale down the imported DXF file instead. Changing the unit scale has a knock-on effect to other areas, such as camera clipping, and it's not necessary to change it as we are only working in Blender. If you were working back and forth between two applications, it could be useful. For students who prefer to work in imperial, you can easily do that in Blender. From the Unit System dropdown, change the unit system to imperial. The units can then be changed to input and display to whatever you choose in the length here. That can be miles, feet, inches, or tows. For this course, I will be using metric. However, you can use imperial and enter the metric values I use by specifying mm for millimeter, or cm for centimeter, and m for meters. So as an example, with the cube selected, in the item tab in the dimension of the cube, these are getting displayed as imperial measurements. They are also set to inches, and that's controlled by the length setting. Change this to feet to have the dimensions displayed as feet. So if we wanted this cube to be 4000 millimeters in the X, Y, and Z, in the X dimension, we can input 4000 and add mm to specify millimeter. Then tab into the Y and input 4000 mm, then tab into the Z and input 4000 mm. As I input metric values and specify the unit of length as mm, these are getting converted and displayed in feet. For this course, we'll be setting the unit system to metric, and we'll have the length set to input and display as millimeter. But feel free to work however you like. Blender allows you work however you need. In this video, we look at importing the DXF file, scaling to the correct dimensions, and converting to mesh objects. Let's get started. If you want to learn to draft this house design in CAD, you'll find that in section 7 and the very end of the course. Then you can come back here and continue. Or if you don't want to complete the CAD section, then continue with the course as normal. We'll be importing a DXF file now, and you'll find that in the resource folder of the course. I can open FreeCAD for a moment. In the CAD section, we previously exported our house plan in DXF format. Now we can take a look at importing a DXF file into Blender. So I can minimize FreeCAD. Back in Blender, let's press A to select everything. Press X and delete the cube, camera and light object. That way we can just focus on the imported DXF file. There is an add-on in Blender for handling DXF import, so let's come to Edit and open Preferences. Open the Add-ons tab and in Search type DXF. There are two, one for import and one for export. We want the second one without the caution sign. Put a check mark here to enable the add-on. Now we can close Preferences. Once enabled, we can come to File and down to Import, and this will be last on the list as it was just enabled. Navigate to where you downloaded and saved the DXF file from the resource folder. The file called Plans here. Select it and now import DXF. These have come in very large as each millimeter is now equal to 1 meter in Blender. In the outliner we can see a list of curve objects we just imported. The first thing we can do is scale these down to the correct size in Blender. So press A and select everything in the scene. Press S, input 0.001 and enter. This has scaled them down, but we first need to check whether they are in fact the correct scale. Then we need to check this section is 10 meters wide. So open the item tab and check the dimensions. That looks good. Select it all again. Let's press Ctrl+A and apply the scale. From the object menu, we can convert this from curve objects to mesh objects. We can also add this to a new collection. So press M and create a new collection. Rename this house plans and press enter and add these in here. In this video we look at rotating using the 3D cursor, rotating using the origin point and rotating in edit mode. Let's get started. To begin, we can start combining and naming the plans. This will make managing the sections easier as we progress through the course. Let's first come into a top view, also an orthographic view. Drag select all the objects that make up the ground floor plan. Then make one active. Press Ctrl+J and join these into one. We can tab into edit mode now. We want to separate these into multiple parts, including the furniture objects, external walls, windows, doors, and internal walls. Let's start with the furniture objects. Press Z and switch to wireframe shading so all the vertices are selected. Now start drag selecting these. Press and hold the Shift key and add to the selection. I'm including the text also. If you are selecting a section that shares a corner vertex with the wall, let's take the toilet as an example. Drag select all the vertices you can except the one sharing the same space on the wall. Then press Ctrl+L and select linked. That way only the toilet vertex is selected and not the wall. I can quickly work around and select the remaining objects. Finally, we can drag select the stairs. When you have all these selected, we can press P and separate the selection into another object. Let's tab back and select this object. Press H and hide it. Let's select this now and tab back in here. Next up, we can separate the doors. So let's quickly work around and drag select all the door outlines. We don't need to include the garage door in this selection. Let's come to the Object Data tab. In here we can create a new vertex group. Vertex groups let you save selections of vertices. Click Assign to assign the selected vertices to this group. Press Shift+D and right click. Press P and choose Separate Selection. We can tab back and select this. Press H and hide this also. Let's select the object again and tab back in here. We can then click Select to reselect the original vertices. Press C for Circle Select and use the middle mouse button to deselect the rectangles of the doorways. Careful not to deselect any arcs. Press X and delete vertices. Then click Select again. This time we can click Remove and remove this selection from the vertex group. Next, we can drag select all the window objects. Quickly add these to the selection. Leave the end window. Press Shift+D and make a duplicate and right-click. Press P and separate selection. Tab back and select it, and press H to hide. Select this again and tab back in here. Switch to Edge Selection, then drag select across the windows. Press X and delete edges. The final part of the puzzle are the internal walls. Drag select all of these. Once these have been selected, click Assign and add this to the vertex group. Press Shift+D and right-click. Press P and separate selection. Tab back and hide this also. Now select the external walls and tab back in here. In the vertex group, click Select and re-highlight all the vertices. Press X and delete edges. Drag select any loose vertices and delete these. Select it all, press M and merge by distance. That will remove any overlapping vertices. Now drag select anywhere there are two vertices along the wall. Press X and delete these. Finally, anywhere you've deleted vertices, select the two vertices and press F to create an edge. I can quickly finish these off around here. We can tab back now. Press Alt+H and unhide all the objects. It will be a good idea to start naming each object now. So the external wall section, for example, we can press F2 and rename this. Prefix this with GF for ground floor, then external wall. Next are the furniture objects. Press F2 and rename this GF furniture. For the windows, these can be renamed GF windows. The internal walls can be renamed GF internal walls. Next are the elevations. These will be used as reference and snapping positions, so these can be combined into one. Drag select all the parts that make this up. Make sure one part is active. Press Ctrl+J and join these together. The same for the end views. Make sure these are one object. Then rename each of them so they are easily recognizable. We can prefix these with an ELV for elevation. The first floor will also need to be separated in the same way as the ground floor. Try get that done before the next video as we don't need it right now. We can move on and start rotating and positioning these elevations so that we can accurately snap onto them. We can use the 3D cursor position to rotate the front elevation upright. Select the elevation and tab into edit mode. Make sure vertex selection is enabled. Zoom into each end on the base of the object and Shift select the two end vertices. We can then press Shift+S for the cursor snap menu and choose Cursor to Selected. That will place the cursor center of the selection, and at the point we can rotate upright. Let's tab back to object mode now. From the pivot menu, we can set the pivot point for rotation to be at the 3D cursor. We can rotate around to see the next operation a little bit better. Press RX, input 90 and enter. That's all we need to do with this elevation, as it's already aligned on the x-axis. So we can move on to the right side elevation. For this example, we can place the origin of this object center along the bottom edge. That way we are not reliant on the position of the 3D cursor for rotation. Right now the origin of this object is at the center of the grid, as represented by the small yellow dot. Let's tab into edit mode. Select the two end vertices on this object. Press Shift+S and put the cursor to selected. Now tab back to object mode. This time we can right click, and from set origin, we can set the origin to 3D cursor. We can see the origin has moved from world 0 to the position of the 3D cursor. We don't need the pivot set to 3D cursor, so from the menu, let's switch this back to medium point. You can also press Shift and right click to move the cursor away, just to see it's rotating around its origin. We can press RX, input 90 and enter. Also RZ, input 90 and enter. Now we can snap over to align with the edge of the ground floor plan. In the snap menu, make sure vertex snapping is enabled. Then press GY. Press and hold Ctrl and snap this over and align with the ground floor plan. For the left side, let's tab into edit mode. This time we can move this from within edit mode. Select it all, press RX, input 90 and enter. Then RZ, input 90 and enter. Then we can press G, press and hold Ctrl and snap over to the right side and align with this. Then move away, so press GX and drag this to the opposite side and left click. Now to position all the first floor layout. We can move the right elevation away first and just make some room. Drag select all these objects. Make sure one is active. That way we can tab into edit mode. Select it all. Press GX and snap down to align with the ground view. This can then be positioned up along the Z axis, so press GZ, input 2700 and enter. Finally, we can add these to their own collection. So tab back first. Press M and we can create a new collection. Rename this ELV first and press enter. Select the right side elevation. Press M and create a new collection. Rename this ELV right and add this in here. Create a second for the left side and call this ELV left. Then add this in here. Select the front and press M. Rename this ELV front and add this in here. For all this ground floor plan, drag select it all. Press M and create a new collection called GF plan. In the outliner, press the period key and close down the collections. We can double click on the empty collection and rename this plans. Then select these 5 collections and drag and drop these into the plans collection. That will just help manage the collections and keep the outliner tidy. In this video, we look at the Archimesh add-on and how the Archimesh door object is constructed. Let's get started. To begin this, we can come to the outliner and switch off all the collections except the ground floor plan. We will start with this and start modeling the building. We'll be starting with an add-on called Archimesh. Archimesh is an architectural design tool add-on for Blender that generates an array of architectural objects. Press F4 and open Preferences. In the Add-ons tab, we can search Archimesh. This add-on will appear listed here. put a check mark in the box and enable the add-on. Expand the add-on to find its location. Here we can see it's in the 3D view from the Add menu or on the sidebar in the Create tab. Use the documentation link for further information. We can close Preferences. To view the add-on, press N and open the sidebar. Archimesh is here in the Create tab. Expand it to view the available parametric objects. Let's look at the door and see how this is constructed. Press Shift and the right mouse button to place the 3D cursor into empty space. Archimesh objects get added at the position of the 3D cursor. Click Door and add one into the scene. The door unit is made up of 7 separate objects. The door consists of the frame, the door panel, then 2 handles on the inside and outside. The door panel is constrained on all axes except the Z rotation, and you can see that here in the Item tab in the Transform panel. The padlock icon indicates what axes are locked. That way, when you press R, the door will open and close as it's rotating on the Z axis. Clicking the padlock will unlock or lock that axis. The lock is to protect against accidental movement or rotation and misalignment from the door. It's also useful only needing to press R and open the door. The next piece of the door is the control hole object. This is the first cube-shaped object displayed as bounds. This is used to subtract the cube shape from whatever the door gets inserted into. This results in an opening being created, and we'll see this later. This is just a cube with its viewport display type set to bounds. That setting is controlled here in the Object Properties tab. In Viewport Display, it's displaying as bounds. Set as the default solid, and it's very hard to see what is happening, so bounds works best. The name or the selected object is visible on the top left here. In the outliner, if we press the period key, that will bring that into view. Here we can see the visibility in render is disabled. That way it won't appear in the render. Notice how this object is part of the door group. This empty object here is the parent object. All the door objects are children. Press G with the empty selected and the door unit will follow along. This makes the unit easy to manage by having just one object to move or rotate. We can see these relationships in the Object Properties tab here and in the Relations tab. If you select the door frame, in the parent field, the door group is listed. If you select the door panel, the door frame is listed as the parent. The handles are parented to the door panel. This second cube shape on the base that is displayed as bounds is used to subtract the baseboard if the wall has one enabled. Select the door frame. This will make the parametric parameters available in the Create tab. The object name will be labeled. Here you can adjust the width, frame height, frame thickness and size, what direction the door will open. There are many different model types to choose from, also handle types. It will also create a cycles material. That's the Archimesh door object. In the outliner, select the door group. Right-click and we can select hierarchy. Press X and delete these objects. That ensures all connected objects are deleted from the scene. In this video, we look at how to add walls from the Archimesh add-on. Let's get started. We first need an insertion point for the walls. Let's select the plan and tab into Edit mode. Select this inside corner vertex here. Press Shift+S and put the cursor to select it. We can tab back now. From the add-on, we can then click and add a room element. The room element begins as a single wall but can be modified to be a complete room. This creates a second tab called Room above here and where you'll find the properties relating to this object. This has a baseboard, so let's uncheck that from the add-on as it's not needed. In the thickness field, we can input 0.3 and match the 300mm thick wall from the drawing. We also know the length of the wall will be 16. However, we need to subtract the thickness of the walls. So input 15.4 in the length field. Let's increase the number of walls to 2. In the second wall length, we can input 9.4. Then increase the wall number to 3. This starts in the opposite direction, so we need to input minus 15.4 for the third wall length. We can either increase the wall number to 4 or click close here to finish the wall. In the height field, input 2.7. There is a floor option here, but this creates a single plane for the entire building. We will want individual floors for each of the rooms. That's the external walls complete. In this video, we look at how to add doorways from Archimesh and how to create a door duplicate. Let's get started. We first need an insertion point for the front door. So let's press numpad 7 for a top view. We can press Z and switch to wireframe shading. We can select the door outlines and tab into edit mode. Zoom into the front door. We can shift select the 4 corner vertices. Press Shift plus S and put the cursor to selected. This will be the insertion point of the door. So let's first tab back to object mode. Over on the Archimesh add-on, we can click door. That adds the door and we can update the door properties now. You can click and drag in the frame width and start to match the plan. Or input 1.2 here as this is the width. In the frame thickness, this can be increased to a size that looks right on the wall. For now, we can input 0.15 and adjust it later if necessary. Let's press numpad 1 for a front view. In the frame height field, increase this to match the drawing. 2.28 is the value here. Let's rotate back around here and take a look. Also, press Z and switch to solid shading. Right now the door is inside the wall and not very functional. We need to subtract the door from the wall, and the add-on has the functionality to do just that. So first, select the wall. Then on the Archimesh tab, we can use the Auto Holes button. This will use the control hole wire object we previously saw and subtract that shape from the wall. What it's essentially doing is adding a Boolean modifier to the wall and using the difference setting to subtract that object. The first modifier here is the solidify modifier, adding the wall thickness. Minimize this. Below then is the Boolean modifier. Switch this on to make the subtraction visible. Let's press H and hide the wall for a moment. We can continue and finish the door, so select the door frame. In the model drop-down, choose one from here. I can choose model 5 and add glass to the panel. You can also change the handle type from the drop-down, but handle 1 is the one I'll use. Let's select the door panel. Make sure the plan is visible. Press R to open the door and check if it opens according to the plan. That's matching the plan and opening in the correct direction. Left click and leave this open. To close the door, press Alt plus R to clear rotation. That's the front door complete. We can make a duplicate and add that as the back door. First, we need the insertion point. So select the door outline and tab into edit mode. Zoom into the back door area. We can shift select the 4 corner vertices. Press Shift plus S and put the cursor to selected. Now tab back. In the outliner, we can right-click on the door group and select hierarchy. Press Shift plus D and right-click. Select the empty. Press Shift plus S and choose selection to cursor. Press RZ, input 180 and enter. The final external door we can add is the garage door. Select the door outlines again and we can tab into edit mode. Select 4 vertices on the garage door opening. Press Shift plus S and put the cursor to selected. We can tab back to object mode. From the add-on, let's click and add a door. For the model type, this can be model 03. This is a panel effect. For the handle, we can choose none. For the frame width, we can input 3 here. Let's press numpad 1 for front view. We can reduce the height to 2.28 and match the elevation height. They are the doorways. We can press Alt+H and unhide the wall. Selected, then update the auto holes and subtract both hole objects. Select any Boolean objects and drag forward if the wall is not overlapping. In the outliner, press numpad- and minimize the collections. Open up the plans collections. We can hide these collections for a moment. Drag select the Archimesh objects in the scene. Press M and we can add a new collection. Rename this Archimesh. In this video, we look at how to add walls using Archimesh. Let's get started. The first thing we'll need when adding the wall is an insertion point. Let's select the wall outline and tab into edit mode. The wall extrudes along the positive axis, so we can select this front corner vertex here. Press Shift+S and put the cursor to selected. We can tab back now and from the Create tab add a room element. This wall will be straight across to the opening here. Right now it's rotated, so press RZ, input -90 and enter. In the thickness field, we can input 0.15. Let's also uncheck baseboard. In the height field, we can input 2.5 and leave room for the ceilings. In the wall length, click and drag to increase. The length will be 3.45. There are 3 more walls at the same orientation, so press Shift+D, Y, press and hold Ctrl and snap across to the endpoint. Then G, Y and snap back to the endpoint. That way, when we increase the length field, it scales from the origin point. 4.95 works here. Then Shift select the 2 walls and press Shift+D, X and snap up above here. Now we need 2 walls in between. Select one of these. Press Shift+D to duplicate or Z, input 90 and enter. Then press G and snap up to the endpoint here. In the length field, increase this to fit between the walls. 4.75 works here. Then press Shift+D, Y and snap this across to the far side. Next, there is the wall, the full width of the building. Select this wall here. Press Shift+D, X and snap up along here. Then increase the length to fit across. This will be 9.4 in length. The final wall is into the garage here. Select one of the walls running the same direction. Press Shift+D, X and drag down past. Then G and snap to the endpoint. That way we can increase this in length and fit across the room. 3.45 works here. In this video, we look at duplicating the internal doors. Let's get started. To begin, let's select one of the short walls here. Press H and hide this for a moment. Let's select the door outline and tab into edit mode. Select the 4 outside vertices of this door outline here. Press Shift+S and put the cursor to selected. Let's come into a top view so we can see this a little bit easier. Tab back first. Press Z and switch to wireframe shading. Now on the Create tab, we can add a new door. This door is the correct width. However, we can increase the depth so the frame extends beyond the wall. So in the frame width field, we can input 0.19. Press Z and switch back to solid shading. One thing we notice on this door is the fact it's slightly off center. That's because the empty is not center of the base. Now we could reposition and make the parent relationship again. However, if you make any modifications to the door properties, it will revert to its original settings, undoing those changes. Instead, we can just move it up slightly. Select the empty. Press G, Y, input -30 and enter. -30 is the distance each door can be moved to center the frame. Press Alt+H and unhide the wall. Select the wall and make the subtraction with the Auto Holes button. Select the door panel. Press R and check the direction. This is the correct direction, so we can right-click. We can duplicate this internal door and position at the remaining openings. So first, select the outline. Press the / key to isolate this. Then tab into Edit mode. We can select 4 vertices around this door on the bottom of the same room. Press Shift+S and put the cursor to selected. Now tab back and also return to Global View. Select the empty. In the outliner, press the period key if the door is not visible. Select the door group. Right-click and from here choose Hierarchy. Now press Shift+D and right-click. Select one of the empties. Press Shift+S and choose Selection to Cursor. Select the door frame to make the properties available. Here we can input 90 and rotate the door to align with the wall. Select the empty. Press G, X, input 30 and center this up on the wall. Select the wall and update the subtraction. That way we can see what direction the door is opening. Select the door frame. Now change the direction to open left. We need to update the subtraction again. That will be the process for the remaining doors. Make duplicates and position at the 4 remaining doors on the ground floor. The garage door is slightly wider, so that will need to be increased in width. I can do that between videos, so try get that done before the next video. In this video, we look at how to add windows from Archimesh and how to display statistics on screen. Let's get started. Hopefully you've gotten the remaining doors added to the scene. We can move on, and the first thing is to use the 3D cursor and get an insertion point for the first window. Wireframe shading will be best, so press Z and switch to that first. We can select the window outline here. Then tab into Edit mode. We can press A to select everything. Press M and merge by distance. That will remove overlapping vertices. Then drag select these vertices here. Now sometimes if you import a file like this, or even model yourself, there could be doubled up vertices in one area. This can cause the 3D cursor to be placed off center. I can show an example. If I drag select these 3, press Shift+D and just right click. Now there are 6 vertices this side and 3 vertices this side. If I drag select these now, press Shift+S and put the cursor to selected. The cursor is skewed towards the greater number as it's calculating the median point of the selection. Very noticeable here, but sometimes not so much. One overlay that can be helpful in this case is the statistics setting here. Check this on and the number of vertices selected will be displayed. Here we can see 9 vertices are selected when you might expect just 6. You could merge them, so press M and merge by distance. Then increase the distance to 1 and make sure that removes the 3. Just be aware how doubled up vertices will change the position of the 3D cursor and the issues it may cause. We can press Shift+S again and put the cursor to selected. Now tab back to Object mode. On the Create tab, let's click and add a panel window. We can use the elevation to position the window. Press numpad 1 for a front view. Select the window outline and tab into Edit mode. Select the bottom 2 vertices here. Press Shift+S and put the cursor to selected. In the View tab, we can click into the Z location. Press Ctrl+C and copy this value. We can tab back now. Select the empty. In the Item tab, paste in that value into the Z location and move this up to the correct height. Select the window and open back up the Create tab. Down below are the window properties. Reduce the horizontal count to 1. Then for the width and height, adjust the values below. 290 by 166 work for this window here. Zoom in and make sure these values are exact. Zoom back out now. We can press Z and switch to solid shading. Let's select the wall and create the subtraction. Let's select the window again. We can adjust the sill properties. So in the tree fields, input 20. Then 1 for the last remaining. You can adjust these further, but I'd be happy with the sizes here. When you're done with the sill, select the wall and update the Boolean subtraction. On the opposite side of the house, there will be exactly the same window, so try get that added before the next video. Just make sure and rotate it after you get that added. There are 3 smaller windows to be added, 2 on the end and 1 on the back. Let's add one of the end windows and you can finish off the remaining 2 before the next video. We can press numpad 7 for top view. Switch to wireframe shading. We can select the window outline and tab into edit mode. Drag select the end vertices here. Make sure there are only 6 selected from the display here. Press Shift plus S and put the cursor to selected. We can tab back. Let's select one part of the window. In the outliner, press the period key. Right-click on the window group and select hierarchy. Press Shift plus D, then right-click. Select one of the empties. Press Shift plus S and choose Selection to Cursor. Then we can select the window frame. You'll know it's selected when the properties become available. Then in the rotation field, input 90. In the width field, we can reduce this to fit the window. 190 works here. Then in the item tab, we can paste in the height value into the Z location. We can zoom out and rotate back around. Press Z and switch back to solid. Select the wall now and we can update the subtraction. There are 3 more windows marked on the outline left to add, 2 small and 1 large. Try get that done before the next video. In this video, we look at how to add windows from Archimesh. Let's get started. Hopefully you've gotten the remaining windows added into the wall and have it subtracted. Let's move to the opposite end and add in the large group of windows. We can switch to wireframe shading first and select the window outline. Now tab into edit mode. Select the end vertex here. Press Shift plus D X and snap out to the full length of the window. Now shift select the vertice on the far end. Press Shift plus S and put the cursor to selected. Now tab back and come over to the Create tab. We can start with the panel window. Below here in the window type drop down, we can choose the door 80 by 230. We can then reduce the vertical count to 1. Then the horizontal count to 3. Down below, uncheck the extra frame on the 2 outside panels. We can press numpad 1 and come into a front view. We can use the front elevation to resize the window. Click and drag and increase the height value. 218 works here. The width of each panel is controlled in the 3 fields here. We can input 117, 116, 117. These work to fill the opening. Let's add the large 5-part window to the end. Select the plan and tab into edit mode. Switch to edge select and select the center edge. Press Shift plus S and put the cursor to selected. We can tab back now. Then from the add-on, add a panel window. Now update the type to be a door 80 by 230. Increase the horizontal count to 5. Reduce the vertical count to 1. We can rotate this 90. Check on the last frame setting. That way 3 have the extra and 2 do not. I can drag out the panel here just to reveal the widths. Here we can input 187. And this value works for the width of the building. In the height, we can input 218 and match the height of the front window. We can make a copy of the front window and move to the opposite side. Select one of the components. In the outliner, press the period key. Right-click on the group and select Hierarchy. Press Shift+D and right-click. Then select one of the empties. We know the width of the building is 10,000 and the windows are sitting in 150 from the edge. So press GY, input 9,700 and enter. Then RZ, input 180 and enter. Let's press Z and switch back to solid shading. Select the wall and we can create the subtraction. This large window is slightly in past the ends, so select the empty. Press GX and drag out and align with the end windows. Zoom right in and move that into position. That looks very good. In this video, we look at how to extrude walls from the imported drawing. Let's get started. In the outliner, let's tidy up the objects from Archimesh. In the scene, press numpad 3 for a side view. Drag select all the objects and try not to select any of the drawing objects. Press M and we can move these into the Archimesh collection. In future, I can try select the Archimesh collection before adding objects from the add-on. We can switch off the Archimesh collection now. We can switch on the first floor plan and I've named this collection incorrectly. I can rename this FF Top. We can then switch off any other collection in here. I wanted to show some parametric modeling with Archimesh first so you can see the comparison with DXF file extrusion. It is a different workflow when you have a complete set of plans. I do find myself using a combination of manually extruding and parametric objects when I do use plans. There are many ways to form the walls and we can look at this example. Let's make a duplicate of these plans before extruding the walls as we'll use them later in the course. Select the scene collection so the new collection gets added here. Drag select all these objects. Press Shift+D and right click. Then press M and create a new collection. Rename this FF Walls and add these inside. We can then switch off the FF Top collection. The next step is to select the edges we'll be extruding. We will want to extrude a wall under each window. That way when we extrude it forms a wall for the window to sit. Select the door objects first. Press X and delete these. Now select the external wall object. Shift select the window object and internal walls. Press Ctrl+J and join these into one. Let's press Z and switch to wireframe. Now tab into edit mode. We can press numpad 7 for a top view. Select it all. Press M and merge by distance first. Increase the value to 1 mm and make sure all are merged. That will remove any overlapping vertices. Switch to Edge Select and select the center edges on the windows. Press X and delete edges. We can repeat that for the edges across the door. Select all these edges. Press X and delete edges. That leaves some missing edges. Select the vertices and press F and create an edge again. Next we can create faces to extrude up and form walls. We can start with the external walls. Let's drag select the 4 side vertices here. Press F and create a face. Select the front 2. Then press F again and continue to fill forward back to the start. You may have to manually select and fill in if fill forward fails. Usually overlapping vertices are the culprit. Hover on the external walls now and press L to select linked. Press H to hide. Next are the internal walls. Here we have extra edges, so select these. Press X and delete. Next, we want to create these internal walls similar to the ground floor. That means first selecting these short edges here. Press X and delete edges. Leaving these here would cause overlapping vertices. Next, select the corner vertex. Press V and rip this apart. Press Ctrl and snap up. That way, this will be a full rectangle shape. Repeat that on the other 3 corners and form the full rectangle. Rip, then snap into position. Press A again. Press M and merge by distance. Now we can start selecting 4 vertices. Keep an eye on the number of vertices if drag selecting, as there may be extra unconnected vertices that get selected. Delete them if you come across any. Press F and create a face. I can quickly work around. No need to fill across the doors. We can fill in across the top when extruding. I can quickly work around and fill these in. With that complete, switch to Face Select and make sure you see a face in each. Press Alt+H and unhide the external walls. The face has a dot center to indicate what the face is filling. Now we are ready to extrude the walls. Let's come into a front view so we can see the heights from the elevation. Switch on the elevation in the outliner. Press A and select it all. Press E and snap this first extrusion to the bottom of the window here. Now we need a door height, so let's add a door in. First, we can select the 4 bottom vertices of this door opening here. Press Shift+S and put the cursor to selected. We can tab back. Let's press C and switch to solid so we can see this a little bit better. Then from the Create tab, we can add a door. This door is the correct width and height, so we don't need to make any modifications. Let's select the wall again and tab in here. The top faces are deselected, so let's select just one. Then from the Select menu, we can come to Select Similar and choose Normal. Zoom out to take a look. If you have an issue, it probably means some normals are reversed. Press Q and switch on the Face Orientation overlay. Select it all. Press Shift+N and recalculate. Select the face again and now we can select Similar and Normals. Press E and snap up to the top of the door. Press numpad 1. This time extrude to underneath the roof. Finally, we need to fill in above the doors. So select the faces each side. Then right-click and from the Loop Tools menu we can choose the Bridge command. I can quickly work around and create a face over the remaining doors. Use Shift+R to repeat the last operation. We can press Q and switch off face orientation. That is one way of using the drawing file to form walls in Blender. In this video, we look at how to rebuild walls with faces. Let's get started. To begin, we can press Ctrl+R and add an edge loop to the front wall here. Left click and right click to leave it here. Press S, X, input 0 to straighten. Then G, X and snap to the front wall. We can repeat that on the back wall and add an edge loop. Align on the axis and snap into position. Next, we can press numpad 1 and come into a front view. Press Z and switch to wireframe, and also vertex selection. That way we can drag select the top corner vertices. Press X and delete vertices. That removes all the faces back to the level we need. Switch back to solid and take a look at what we need to fill. Press Alt+A to deselect. Press L and select the internal walls, both sides. Press H and hide these so we don't select the wrong vertices. We can start with the top here, so select the 4 vertices. Press F and create a face. Select the front 2 vertices and press F and fill forward around to the far side. That's the balcony area created, so press Alt+H and unhide the walls. Now let's tab back. We can press F2 and rename this FF Walls. In this video, we look at adding doors to the first floor. Let's get started. To begin, we can come to the outliner and switch back on the visibility of the Archimesh collection. Select the collection, and that way when we add Archimesh objects, they will get added into this collection. This will be exactly the same process as adding the ground floor doors. So you can work away and add these in yourself. I can quickly cover 2 and complete the remaining before the next video. Let's start with the external balcony door, so tab into edit mode. Select the bottom 4 vertices on the wall here. Now put the cursor to selected. We can tab back. We have previously modified the default door for the ground floor, so select one of the components. In the outliner, press the period key to highlight this. Right-click and select Hierarchy. Press Shift+D and drag across. Select the empty now. Press Shift+S and put selection to cursor. Select the door frame. In the rotation field, input 270 here. That way, the door opening direction will match the plan. This needs to be reduced in width and height. In the height field, we can input 2.1. Then in the width field, input 1. This temporary door we added, select the empty. Press Shift+S and put the cursor to selected. Then press the period key to highlight this in the outliner. Right-click on its parent and delete hierarchy. From the ground floor, we can select a door empty. Now select hierarchy. Press Shift+D and drag away. Select the empty. Press Shift+S and put selection to cursor. Try work around and add in the remaining doors for the first floor. I will also get these added between videos. In this video, we look at adding windows to the first floor. Let's get started. Hopefully you have the remaining doors added and they open in the correct direction. I added an extra opening here that's not on the plan, so I need to fill this in. Tab into edit mode. Select the faces up along here each side. Then from the Loop Tools tab, use the Bridge command. Select it all now. Press M and we can merge by distance and remove any extra vertices. We can move on to the windows next. There are a couple of ways to remove the faces for the windows, then fill around. We saw that with the balcony when we filled back in around the wall. We need to add 4 edge loops first. These will be the window boundaries. Press Ctrl+R and add an edge loop here. Press SX, input 0 and enter. Now snap this along the X and to this internal wall here. Add a second this side and snap to the other side. We then need another edge loop this side. Snap this down here. Finally, one up the far side up here. This one needs to be scaled on the X to 0. Then snap this into position. This time, let's select the faces that will be the window openings. The front windows include the top two faces. The back, we just need to select the lower two. Press E and snap across to the width. Now press X and delete these. We also need to select the opposite side faces. These include the top two on the front. Press X and delete these. Then the top faces here can be deleted. Extruding those across have filled in between, but we do have overlapping vertices, and we'll remove those in a moment. We can do the same with the end openings. Select these two faces. Press E and snap across. Press X and delete these. Select the opposite ones and delete these also. Now we can deal with the overlapping vertices, so select it all. Press M for the merge menu and we can merge by distance. The windows can be added in the same way as the ground floor. I can demonstrate the large front window and then we can complete the remaining before the next video. First we need an insertion point, so select the bottom face on this opening. Press Shift plus S and put the cursor to selected. Let's tab back. Select the empty below here. In the outliner we can right click and select hierarchy. Press Shift plus D and drag away. We can select the empty. Press Shift plus S and snap this to the cursor. Press G, Z, input 20 and enter. That will move the window up and make sure there is no Z fighting. Select the frame next and fit the window to the opening. In the height field we can input 178 here and increase this to fit. In the width dimension we can click and increase this, but it will only increase to 300 in this version and that's not enough. We will have to manually increase this width in edit mode. This means no other modifications can be made to the window in the properties here or it will revert back. So let's tab into edit mode. Press 1 and switch to vertex selection. Press Z and switch to wireframe shading. Drag select one side of vertices. Press G, X and snap out to the end of the wall. Now drag select the second side. Press G, X and snap these out. We can press Z and switch back to solid shading. We only need to manually adjust the front two windows. Just be careful not to modify either once completed. The remaining windows will fit to our opening. They are slightly shorter in height. Try work around and complete the remaining windows. In this video we look at adding a stairs to the building. Let's get started. To begin, we can come to the outliner and press the numpad minus key and close up the collections. Expand the plans collection and switch back on the ground floor plan so the stairs outline will be visible. Let's zoom into the start of the stairs. Select it and tab into edit mode. Select the two end vertices. Press Shift plus S and put the cursor to selected. We can tab back to object mode. From the Create tab, we can add a stairs. We can press numpad 7 for top view. The width of the stairs is 1000 on the plan, and 1 here represents 1000. In the number of steps field, we can input 13 and match the plan. In the step height field, we can input 0.1777. In the depth field, we can input 0.351. This is a very straightforward stairs, but saves a great deal of time. In this video, we look at adding a ceiling and subtracting the stairs opening. Let's get started. In the outliner, we can press the numpad minus key and close down the collections. We can disable the plans and the first floor walls collection for the moment. We can create a ceiling for the ground floor walls. This will be from the top of the wall here to 20 mm below the first floor floors. The floors will be separate objects, so each will have a different material. So having the ceiling 20 mm from the floors will ensure no Z fighting. That's where the faces of 2 or more objects are in the same location. This ceiling can be one plane, so first we can get an insertion point. Select the external wall and tab into Edit mode. Select the corner vertex here. Press Shift+S and put the cursor to selected. Let's tab back now. From the Add menu in Mesh, we can add a plane. Let's tab into Edit mode. Press M and merge at center. That collapses all the vertices to one at the origin. Make sure vertex selection is active, otherwise you can't extrude. Press E and snap across to the far side. I can zoom out here. Press A and select it all. Press EX and snap down to the far side. Let's select it all. Press G, Z and snap to the top of the wall. Then E, Z and snap up. We can then move this down 20 mm to allow room for the floors. Press G, Z, input -20 and enter. Ceilings are usually one color material, so this is a very fast way of adding a generic ceiling. We do need to cut a hole in the ceiling for the stairs. We can tab back to object mode. Let's switch back on the first floor walls collection to help visualize what we need here. The opening will go from the front of the stairs to this wall here, and from the side of the stairs to this wall here. So let's select the stairs and tab into Edit mode. Let's select this top inside corner vertex on the step. Press Shift+S and put the cursor to selected. Now tab back, and from the Add menu in Mesh we can add a plane. Let's tab in here. Select it all. Press M and merge at center. Press E, Y and snap down to the bottom wall here. Press A and select the 2 vertices. Press E, X and snap across to the stairs. Now we have the plane the size of the opening we require. Select it all. Press G, Z and drag this up slightly. The distance is not important, just make sure it is above the ceiling. Now press E, input 1200 and enter. This needs to have extruded further than the ceiling thickness of 200. Let's tab back and select the ceiling object. In the modifiers tab we can add a boolean modifier. We can use this picker tool here and select the plane cutting the ceiling. Now because we extruded down, let's press Q and switch on face orientation. There is always a chance the faces are reversed. If yours are, select the plane and tab into Edit mode. Select it all and press Shift+N and recalculate outside. We can tab back and switch off this overlay. We can see the result if we select the plane and open the Object Properties tab. In Viewport Display, we can change this from textured to wire. Now the stairs should be visible. We will leave the boolean modifier on the ceiling as there shouldn't be a need to apply it until it's necessary. That way, if we need to make changes, we can very easily. Select the ceiling now. Press F2 and rename this GF ceiling. In this video, we look at adding a floor to the building. Let's get started. When we add these floors, we need them to sit flush on the ceiling and be 20 mm in height. Let's select the first floor wall and tab into Edit mode. Select an inside bottom vertex in this back room here. Press Shift+S and put the cursor to selected. This will then need to be lowered 20 mm, so open the View tab. In the Z field, we can click and remove the MM. Then add in a -20 at the back of this value and subtract that distance. Back in the room, we can shift select the 4 corner vertices. Press Shift+D and right click. Press F and create a face. Press P and we can separate selection. We can tab back and select the floor. In the modifiers tab, we can add a solidify modifier and give this floor thickness. Increase the thickness to 20 mm. Make sure it's adding the thickness downwards. That will be the process when adding the floors for the remaining rooms, first and ground floors. We'll look at adding texture maps when creating the floor material. Try get the remaining floors completed before the next video. Next, we can create the hallway and subtract the stairs. Select the interior wall and tab into Edit mode. We can press the / key and isolate this object. Select all the corner vertices around the hallway. Press Shift+D and right-click. Press P and separate this object. We can tab back to Object mode and select the wall again. Then press Alt+Numpad / to remove it. We can then select our new object and tab into Edit mode. Let's select two vertices and press F and fill with an edge. Repeat that and join this all around. We need an extra vertex here, so select these two vertices. Right-click and subdivide. Select it and press G, Y and snap to a line here. Repeat that for this edge and subdivide. Then snap to a line. That will allow us form quads. Now select 4 vertices and create a face. Work around and create the 3 faces here. Press Q and switch on face orientation. If the faces are reversed, select it all and press Shift+N. Switch off the overlays now. We can tab back to Object mode and return to Global View. Let's Shift select this first floor. Press Ctrl+L and link the modifier. That will add the solidify modifier that has a thickness of 20 mm. Minimize this modifier. Add a boolean to this. Then use the picker and subtract the cutter object we set up earlier. This does leave a 20 mm gap around the stairs here that you can kind of make out. So let's correct that. Select the wall and tab into Edit mode. Switch to wireframe so we can select the bottom face of the end wall surrounding the stairs. Press E, input 20 and enter. We can tab back and switch back to solid. That fills in the gap and that looks good. Before the next video, try add in floors for the remaining rooms top and bottom. The balcony area will also need a floor, so try get that done before the next video. In this video we look at organizing the collections, adding the ground floor hallway and floor slab. Let's get started. Hopefully you have added the remaining floors to the first and ground floor levels. It's just a matter of duplicating the floor we created the last time and fit that inside each room. The ground floor hallway does involve a little more extrusion, but we can complete that shortly. Let's organize the collections so we can quickly switch on and off the visibility of groups of objects. We can press Alt+H and bring back any hidden objects. Let's start with the ground floor wall. Press M and we can create a new collection. Rename this GF wall and add this in here. Let's select all the first floor floors. Press M and rename this FF floors and add these in here. Then disable these in the viewport also. Select the ceiling next. Press M and create a new collection. Rename this GF ceiling and add this in here. This collection can also be switched off in the outliner. Switch off the first floor wall collection also. Next, we can select all the ground floor internal walls. Then press M and add these into the GF wall collection. Switch off this collection also. Next, we can select all the ground floor floors. Press M and we can create a new collection. Rename this GF floors and add these in here. We can disable this collection also. Next we have the windows. The best thing is to first come into a front view. Press Z and switch to wireframe shading. We can drag select all the first floor windows. Be careful to only select the windows and no doors. Rotate around and make sure just the windows are selected. Press M and create a new collection. Rename this FF Windows. and add these inside. Switch this collection off. Next, we can drag select all the first floor doors. Make sure to include the handles. Also, drag select the small empties at the bottom. Press M and create a new collection. Rename this FF Doors. This collection can also be switched off in the outliner. We can continue and select the ground floor windows first, so press numpad 7 for top view. Drag select all the windows. Make sure they are all selected. Press M and create another collection. Rename this GF Windows and add these inside. Disable this collection also. That leaves us with just doors and also these cutter objects, but we'll deal with these in a moment. Drag select what is left. We can shift select and deselect the stairs and the stairs cutter. Press M and create a new collection. Rename this GF Doors and add these inside. We can disable this collection now. We can select the stairs and add this inside the Archimesh collection. Now let's finish off the ground floor hallway. Let's switch back on the ground floor wall collection and the first floor floors collection. We can select the first floor hallway. Press Shift+D and snap this down to the ground. In the Modifiers tab, we can remove the Boolean modifier as it's not needed. Press M and move this into the GF Floors collection. Switch that collection back on in the outliner. Switch off the first floor floors collection. We can tab into edit mode now. Let's isolate this floor for a moment. Drag select the two end vertices across the hall here. Now return to global. Press E, Y and snap these out to the inside point of the wall and fill the hallway. Let's tab back. The final step is to add the base, so select the wall and tab into edit mode. Select the four corner vertices underneath. Press Shift+D and right click. Press F to create a face. Press P and separate selection. Let's tab back and select this. In the Modifiers tab, we can remove all the Boolean modifiers, but make sure to leave the Solidify modifier as that's adding the thickness. We do need to change the thickness to 200 mm. In the Item tab, we can increase this base to 16,000 in the X and 10,000 in the Y. Then, in the scene, if we rotate around, we need to press G and drag away. Press G again and snap to the bottom corner of the building. In this video, we look at adding a roof. Let's get started. Let's come to the outliner and switch on all the collections. Select the base slab. Press Shift+D, Z and drag this up. Now G, Z and snap down. We can press numpad 1 for a front view. On the left side, we need to extend this slab. So let's tab into edit mode. Press Z and switch to wireframe shading. Drag select the end vertices here. Press GX and snap out to align with the drawing. We can select this corner vertex here. Press Shift+S and put the cursor to selected. We can tab back and also press Z and switch back to solid shading. Let's open the View tab. We need to move the 3D cursor up the thickness of the slab. So at the back of the Z location value, we can add +215. That will update that value. In the Create tab, we can come and find the roof. These are only initial properties and will disappear if you use another command. If you click away, you can press F9 to bring them back. For the model number, I can choose 4. In the number of tiles for the x-axis, we can input 76, tab into the y and input 27. That's the basic roof in for the building. In this video, we add railings to the balcony area. Let's get started. Let's select the top wall section and tab into Edit mode. Press the / key to isolate. We need to form the pillars on each corner here before extruding. Press Ctrl+R and add an edge loop. Left click and right click. In the options box, check on even and straighten the cut. Then press GX and snap this down. Add a second on the width. And snap this down. We can repeat that for the far side and add an edge loop here to form the corners. Select it all now. Press M and we can merge by distance. Select the top two faces. Press F and create one face. Repeat that on the far side. Also underneath and match the tops. We can return to Global. Now we are ready to extrude. Switch to Face Select and we can select the two corner faces each side of the balcony here. These can be extruded up to form the pillars. So press numpad 1 for front view. Press E and snap these up to beneath the roof. Let's rotate back around and select the two vertices at the base of the pillar. Press Shift+S and put the cursor to selected. This will be the insertion point for the railing. Let's tab back. On the Create tab, we can use the column generator. The model can be changed to rectangular. For the X size, input 0.120 or a size you like. Match this in the Y also. In the count X, we can input 11. In the distance X, input 0.43 or a value that looks correct. That's it for the properties, but we'll be making some modifications. In the Modifiers tab, let's press Ctrl+A and apply the Array modifier on the columns. Select the top cap and remove the Array modifier here. Repeat that for the bottom cap and remove this array. Let's Shift select the three objects. Make sure and select the bottom cap last as we want the new object to inherit its origin point. Press Ctrl+J and join these into one. Let's tab into Edit mode. Drag select the top and bottom vertices on this. Press GX and snap to the far wall. Then drag select the far side through the pillar. Press GX and snap back. We can tab back now. Let's get the snap point for the opposite side. Tab in here and select the two vertices. Press Shift+S and put the cursor to selected. We can tab back now. Press Shift+D and right click. Press Shift+S and put selection to cursor. For the remaining railings, try get that done before the next video. Use the column generator and use the same process. 22 columns work across this opening. In this video, we look at 3D modeling the front step. We use the align command to center the new step up on the doorway. Let's get started. Hopefully you've created the final balcony railing and we can move on to the front step. Let's switch off the plans collection first. For the step, we can start with a cube. Press Shift and right click to place the 3D cursor out front. Then from the Add menu in Mesh, add a cube. We can update the dimensions to the sizes for this step. The X dimension is fine, so input 1000 in the Y axis. Tab into the Z and input 200. In the Z location, we can input 0 first. Then in the scene, press G, Z and snap down to align the bottom face with the base of the house. We need to center this step up on the door and we can use the align command to complete this. Shift select the door frame. This has its origin center. From the object menu in transform, we can choose align objects. Then in the properties box, check on the X axis. This is using the object centers and the active object as the target. Select just the step again. Then we can press G, Y and snap this back to the face of the base. Next, we need to form the top part of this step. Let's tab into Edit Mode. Select the top face. Press GZ, input -30 and enter. Press P and separate selection. Tab back and select this. In the X dimension, we can input 2060. Tab into the Y and input 1030. In the Modifiers tab, we can add a Solidify modifier and give this thickness. Increase that thickness value to 30. That doesn't look like 30, and the reason is we have a non-uniform transform in the Scale field here. Press Ctrl+A and apply the Scale transform. We need to move this up and forward. Press GZ and snap up. Press GZ, input -15 and enter. Press Ctrl+A to apply this modifier. Then Shift select the bottom, press Ctrl+J to make these one object again. Because we selected the bottom step last, the new object has taken on its transforms, including a non-uniform scale. Press Ctrl+A and apply that scale. The step can be moved into the GF Floors collection. In this video, we continue work on the external environment and extrude the external walls. Let's get started. We can begin and press Shift+S and put the cursor back to World Origin. Then in the View tab, in the Z location, we can input -200 and move this down in line with the base. Then from the Add menu in Mesh, we can start with a plane. Open the Item tab so we can update the dimensions. This plane will represent the overall external yard or environment. So in the X, input 26800. Tab into the Y and input 23800. Let's rotate around here. Press G and snap this to the back corner. Then we can move it away a certain distance. So press GX, input 2000 and enter. Then press GY, input 2000 and enter. Let's tab into Edit Mode now. We can press Ctrl+R and add an edge loop, then snap this to the edge of the step. This short edge out front won't have a wall extruded, so we can select all the edges except that one all the way around. Press P and separate selection. Tab back and select this. Press Ctrl+A and apply the scale value as we will be adding a Solidify modifier. Now tab in to extrude the wall. Select it all. Press EZ, input 1000 and enter. In the Modifiers tab, we can add the Solidify modifier. In the Thickness field, increase this to 400. For the next extrusion, we need to be able to select only part of the wall, so the modifier needs to be enabled. So let's tab back to apply this. Press Ctrl+A to apply the modifier. Now tab into Edit Mode again. This back left corner has an angled section and we need quads here. Press Ctrl+R and snap this edge to the first vertex. Press S, input 0 to straighten. Now snap back. Repeat that along the Y-axis and snap here. Press S, Y, input 0 to straighten. Now snap back. Now select the two top triangles. Press F to form one face. Repeat this underneath and select these two faces. Press F and form a face. Next, we can select the faces we need to extrude. So the back and right side wall, including the two small squares we formed. Press E, input 2000 and enter. In this video, we continue work and finish modeling the external environment. Let's get started. We can tab back and select the bottom plane, and then tab into Edit Mode. We can add more edge loops and mark out the grass, paving and border areas. So let's press Ctrl+R and add an edge loop on the opposite side of the step and snap this in here. We then want another edge 400mm offset from these. So first, add a second edge loop and snap this in. Press G, X, input 400 and enter to move this away. Repeat that on the opposite side and add an edge loop. Now move this away -400 along the X. We also need a 400mm strip offset from the high walls. So add an edge loop here and snap to the right side. Press G, X, input -400 and enter. We can rotate around to the back. Add an edge loop here and snap to the back wall. Press G, Y, input -400 and enter. The final border is around the base of the house, so we can add 4 edge loops and snap these into the house, then move them away 400. I can quickly work around and add this border in around the house. Finally, I can add the last one here. Then move this 400mm away. These will all make more sense when we add material and the particle systems. In this video, we look at 2 methods to light the scene. The first is to create a procedural sky and lighting setup, and the second is to add a HDRI environment texture to the scene. Let's get started. The first lighting method is a built-in add-on called Dynamic Sky. This generates a procedural sky and lighting setup. We can press F4 and open Preferences. In the Add-ons tab, search Dynamic. Here we can enable the add-on. Let's expand it and open the documentation. If I drag in a web browser, we can take a look. Here you'll find information about the add-on, including instructions. Check out the author's site for further information and instructions for the add-on. We can close the web page and move back into Blender. Once enabled, the add-on can be found in the Create tab once you are in object mode. You just need to click Create to generate a new procedural sky. By default, Blender has its own environment lighting here in the World tab. From the drop-down, you can switch back and forth between the default lighting and the dynamic sky lighting. If we open the Render Properties tab, you can set the render engine to either Cycles or Eevee, as Dynamic Sky works for both. We can change this to Eevee as you'll see the changes faster. Then from the top here, change this to Rendered. One thing to notice when you're in an orthographic view that the sky isn't visible, and that's true with the default lighting also. Press numpad 5 or this button here to switch back and forth. Now the sky is visible. Your current view is listed here. On the Dynamic Sky add-on, the settings are now available. Here you can adjust the brightness of the environment, the color of shadows with the saturation value, change the sky color, horizon color. The cloud settings are next. Adjust the cloud's opacity or the density of the clouds in the sky. Then the sun control. Here you can change the color, adjust the opacity value, make hard or soft shadows, and finally change the sun direction. The second method we can look at to light the scene is using HDRIs. These are high dynamic range images that provide a greater range of luminosity to light scenes. We can open a web browser first. In search, type HDRI or Polyhaven. This site have a great range of textures, models, and what we want now, HDRIs. I'm looking for outdoor images as this will be visible in the background, and I'd like there to be a few buildings. Choose one from here. From this page, you can choose the resolution. I usually start with 4K images and increase that if necessary. The format we want is HDR. Now download. This can be saved in my project folder, so save the file. We can open back up Blender. Then we can come back to the Scene tab. From the drop-down, we can switch this back to World. To add in the HDRI, we can click this yellow button on Color here. Then choose an environment texture. That changes the color of the screen, and this is a warning of a missing texture, even though we haven't added a texture yet. Anytime you see this color in Blender, it indicates a missing texture file. This is one reason why keeping your textures and related files together is really important. We just need to add a texture here, so click Open. Navigate to where you saved the HDRI. Select it, and we can open Image and add this into the scene. Once you are in a perspective view and rendered is the shading type, the image should be visible. You have the strength value and more properties for the HDRI here. It's also possible to control the HDRI's position and rotation, so let's switch into the Shading tab up top. We can switch to Rendered in here also. In the Shading Type drop-down, we can switch this to World. That makes available the nodes for the HDRI. Here, you can adjust the strength and other properties. Earlier in the course, we enabled the Node Wrangler add-on, so make sure that is enabled. That way, if we select this texture node and press Ctrl+T, a mapping and texture coordinate node are added. Then we can click into the Z rotation and rotate the HDRI for its best position. Let's switch the shader type back to Object. Then we can switch back to the Layout tab. In this video, we look at two sites where you can get texture maps. Let's get started. In the next series of videos, we will be UV mapping and texturing the models and preparing them for the animation. With most of the materials, we'll be using texture maps. It would be useful if you started thinking about what materials you'd like on your models. There are plenty of great resources available to get good quality textures. We previously saw this website, Polyhaven, when we downloaded the HDRI. This site also has high quality textures available. Take a look through here and find the textures you'd like to see on your model. When you find one, first select the resolution. Always best start with the lower resolution textures and only upres if you're going to use the textures in final render. 1K textures will give a good preview. Then choose the format. Then download. This will be downloaded in a zipped folder, so you need to uncompress the folder before adding them into Blender. Best look through and download what you might need. Another website that was formerly CCO Textures is now called Ambient Textures. Here you'll find a huge library of texture maps. When you select one, you can choose the resolution and download the files. These will also be zipped folders. Try find some textures now and download them. For the floor material, I'll be using a wood texture. In here, I'm going to choose a floorboard style. This one here looks good. I'm going to use the 1K JPG. JPG files are smaller than PNGs, and we can see this here. This can be saved in my project folder. I'm going to continue and search from these two sites for more texture maps before the next video. Try do the same and choose some textures and get them downloaded. Make sure to unzip them and be ready to import into Blender in the upcoming videos. We'll be starting with the first floor hallway and I'll be adding the wood texture I downloaded. In this video, we look at how to UV unwrap the floor and how to add the texture maps to the floor material. Let's get started. To begin, in the outliner, select the Empty House Plans collection and press Delete. To begin, let's select the roof and the railing objects. Press M and we can move these into the Archimesh collection. When using texture maps in materials, the objects need to be UV unwrapped. UV mapping is the process of laying out the 3D objects UVs in 2D space so that 2D textures can be applied to the surface. We can work through the first floor hallway as an example and UV map then create a material. If we press M for a moment, we can count what number the first floors are listed. These are 5. So escape from this menu and press 5 on the keyboard, not the numpad. That will isolate collection 5. Let's select the hallway, and you want to make sure the scale is 1 in the X, Y, and Z. That's fine, so no need to apply. This floor has 2 modifiers, a solidify modifier giving this thickness and also a Boolean modifier. Both will need to be applied, so we can press Ctrl+A and apply both in order. Let's switch into the UV editing tab next. Press the / key to isolate the floor. When you use a Boolean modifier, it can leave the mesh needing some cleanup. So press Ctrl plus spacebar to maximize this screen. This short edge here is not connected, so select the vertices top and bottom. Press J and connect them. Then select the top 2 vertices. Press J and connect these across. Repeat that underneath and connect this across. That way all faces are now quads. This is now ready to unwrap. We next need to add some seams. Seams cut the object's UVs and allow them unfold flat on the UV grid. This object will only be seen on the top and the side face here down by the stairs. Let's press and hold Alt and select all the top edges around the top. Press Ctrl+E and mark a seam. Press numpad 7 for a top view. Select the top faces. Press U and we can choose Project from View. Let's click back to Previous to see the unwrap. Press S and scale this up to maximize its space on the UV grid. In the UV editor, we can switch on this setting, UV Sync Selection. This will show the UVs whether they are selected or not. It also lets you select and manipulate UV faces. Select the top faces again. Press Ctrl+I and invert the selection. Press U and we can do a smart UV unwrap for the remaining UVs. Let's press G and drag this off grid. Most of these faces won't be seen, so we only want the 2 side faces here, so select them. In the UV editor, press G and drag over to the edge and leave them beside these faces. For the remaining, we can drag select these. Press S and scale right down. None will be seen. Position on the grid, making sure not to overlap any other UVs. That will do for this unwrap. Let's come back to the Layout tab and add a material to the object. Let's switch into the Shading tab. Click New and create a new material. Rename this Floor Wood. Select the Principal node. We can use this Node Wrangler shortcut, Shift plus Ctrl+T, and open the wood textures. Navigate to where you have unzipped the folder. We can select Roughness, Normal GL, the Metalness, Color, and the Ambient Occlusion and Displacement maps. That adds in all the selected maps. In the node editor, we can press Ctrl+Space to make this full screen. You can press that shortcut again or use the Back to Previous button here. Press Shift+A and from the Color category, add a Mix RGB node. Drag this on the line here and connect it up. Then connect the AO map to the color input. Switch this from Mix to Multiply. The factor then can be adjusted to change the amount of AO. That's it for the material, so let's press Ctrl plus spacebar and return. We can isolate the floor here. Now zoom in to take a look. This looks to be just one board, so we can adjust the scale on the mapping node. Here we can input 7 in the X, Y and Z and scale the texture down. That looks good now. In the Z rotation field we can input 90 and rotate the texture. Let's come back to the Layout tab. That will be the process for adding materials to the floor. The remaining floors are very straightforward and only require a smart UV unwrap. Create materials for each and check the scale and rotation are correct. I can get that done before the next video. In this video, we look at applying the wall modifiers and creating wall material. Let's get started. Sometimes you will open Blender and this bright color has replaced where material once was. This can happen if the location of the texture files has changed and Blender no longer knows where to find them. Luckily, in the external data menu, there is a Find Missing Textures option. Navigate to the folder where you have them stored, then click Find Missing Files. Blender will search this folder and subfolders and restore the link to the missing textures. Really helpful feature. I'm going to use the same material for all the floors, so I can link this here. To begin, we can come to the outliner and press Alt+H and unhide all the objects. Drag select these environment objects here. Also, select the base slab. Press M and create a new collection. Rename this environment and add these inside. Switch this collection off also. We have two very different wall objects as to the way they were created and how they will be unwrapped. Let's start with the more difficult, and that's the bottom one. We'll be using texture maps to create materials for the walls, so this will need to be unwrapped. This also means it's time to apply the modifiers and tidy up the mesh. We can press Ctrl+H and choose the GF wall collection. That will hide all other collections in the scene. In the modifiers tab, we can start with the solidify modifier. Make sure it's active. You need to apply modifiers in order, as not doing so will have unusual results. The order is how they are currently being calculated. Press Ctrl+A and apply all these modifiers. That makes the openings permanent. Let's press the / key and isolate this and tab into edit mode. When you apply Boolean modifiers, they can leave artifacts. These can be extra vertices connected or not. These may cause issues when we are animating, so best address them now. If we move over underneath the left side here, there are extra edges and vertices. This results in Ngons, and you can convert these to quads or 4-sided polygons. What we can do here is select the vertices and snap to the corner. That way we can merge together once we are done. Let's repeat that on the far side here. Snap these to the closest corner. There are other issues here also. Here where you see a lone vertex unconnected, we need to connect. So select the two vertices. Press J and join across. This also needs to be connected up around. For that, we can use the knife tool. Snap to the first point, then continue around to the far side and connect around here. Press Enter to finish. That will need to be repeated all around the mesh, over and around the windows. Let's look at another example. Here, where the edge is at an angle, press K, and we can connect down and around. Now connect up the far side. Repeat that on the side and connect around here. That leaves tries or three-sided faces. Select the two faces. Press F and form one face. Repeat that on the far side and form one face here. That's going to be the process all around this section. When you select the face, it needs to have 4 edges, not an Ngon like this face here. I'm going to quickly work around and finish this off. I'll speed up this part of the video. With that complete, let's press A and select it all. Press M and we can merge by distance. Increase the value to 1 and make sure to remove doubled up vertices. With this complete, let's return to Global View and tab back to Object Mode. Next, we can select each of the internal walls. In the Modifiers tab, apply the modifiers in order. Apply both the Solidify and the Boolean modifiers. Isolate the wall and tab into Edit Mode. Now use the knife tool and connect up to form quads. This can be repeated for all the walls. I can quickly work around and complete this process. I'll also speed up this part of the video. With that complete, we can select all the walls, including the external wall. Press Ctrl+J and join them into one object. Let's switch into the UV Editing tab up top and we can isolate the walls in the viewport. Select it all. First press M and merge by distance and check if there are any overlapping vertices. Press U and from this menu we can choose the Smart UV Unwrap. We can give the island margin a value of 0.02 and make a little space between the UV islands. The margins help to reduce the risk of texture bleed. Now we can click OK. That looks okay, but there is a lot of space being taken up with this section. That looks to be the top of the wall and won't be seen. You have a couple of options here. Select the unwanted faces in the scene and delete them, or select them in the UV editor and reduce their size so they take up little to no space. It all depends on what you are working on. In this case, we can scale them on the UV grid so they take up very little space. Let's press Z and switch to wireframe. Press numpad 1 for front view. Make sure you are in an orthographic view. We can drag select the bottom faces. Press Shift and drag select the top. Rotate around and make sure just the top and bottom are selected. In the UV editor, we can open the UV menu and choose Pack Islands. That just arranges these for us. Now press S and scale these right down. Then move them away off the grid. Next, press Ctrl+I to invert the selection. We can then come to the UV menu and pack these also. Drag select the UVs and move and position somewhere on the grid, making sure they are not overlapping. UVs should never be overlapping. That would cause materials to have artifacts. Let's come back to the Layout tab. Open the Material tab and take a look. When the Archimesh objects are created, this material is also created. We can remove this and create our own. So click the minus to remove it. Add a new material. Rename this External Wall Material. We can click the plus and add a second material slot. Add a new material. Rename this one Internal Walls. Next, we need to assign each slot to the appropriate faces. At the moment, all faces have the first material, so let's tab into Edit Mode. Press Alt+A and deselect everything. Hover on the internal walls and press L to select all of these. Now select the internal wall slot, then click Assign. We can tab back now. Switch into the Shading tab. Select the external wall material, then select the principled shader and press Shift plus Ctrl plus T. I have downloaded the Plaster 1 material from Ambient Textures, so I can add these in here. These may need the scale reduced as I'd like this very fine plaster. Here I can input 5 in the X, Y and Z. That looks better. In this video, we look at UV unwrapping the first floor walls. Let's get started. To begin, we can select the internal walls material slot. This can be modified further, but I'm just going to darken the color slightly. Because we did UV map these walls, you could add texture maps to modify the material. Let's switch into the UV editing tab. We can tab back to object mode. Return to global if the view is local. Press Ctrl plus H and we can isolate the first floor walls. Let's select this and tab into edit mode. Select it all. Press U and we can use the Smart UV Unwrap. Increase the island margin to 0.02. Now click OK. Let's press numpad 1 for a front view, then 5 for orthographic. Drag select all the faces on the top and bottom, as before. This time we can press X and delete faces. Now we can drag select the UVs again. We can pack these UV islands. Let's open the Material tab. From the drop-down, we can add the external wall material. Click and add a second material slot. From the drop-down, add the internal wall material. Let's press numpad 7 for a top view. Drag select all the internal walls from inside corner to inside corner. Then we can assign these faces. Let's switch into the Shading tab up top and take a look at the material. In the outliner, we can press the minus key to close the collections. Now switch back on the ground floor wall collection and make sure the materials look similar for both. That looks very similar and I'm happy with those results. In this video, we look at adding a concrete material to the sill. Let's get started. Let's hide these two wall collections and switch on both the window collections. Let's select one of these windows first. I've gotten a concrete set of texture maps I'm going to use on the window sill. I was looking for a rough granite but couldn't find one, so settled on the concrete 6 from Ambient Textures. In the Materials tab, we can come and select the window marble material slot. I'd like to swap this out for a concrete material. We can drag select these 3 nodes here. Press X and delete them. Then connect the principal shader node. I can speed up adding in the texture maps as we have seen this before. The important thing to note is that to use these maps, we need to add a UV map. These objects don't have a UV map when created, and we can see that in the Object Data tab in the UV Maps tab. Let's click the plus and add one. Then we can switch into the UV Editing tab up top here. Select it all, press U and we can do a Smart UV project. Increase the island margin to 0.02. Then click OK. Now we can switch back to the Shading tab. That has updated the material. Let's also switch back to the Materials tab. Select the PVC material. We can drag select these 3 nodes. Press X and delete them. Then connect up the principled node. Click into the color swatch and darken the windows a little. Also reduce the roughness value to 0.3 and give this a PVC look. The plastic and glass material will be fine, no need to modify these. One thing that will help the window sills is to add a bevel to the edges. Select the sill and open the Modifiers tab. Here we can add a bevel modifier. Now reduce the value to 2 mm. Then if we shift select all the windows close to the same size as the one we've modified, Finally, select this one, so it's the active object. Press Ctrl+L and make links and copy the UV map. Then again for the modifiers and bevel all these windows. If you're lazy, you can repeat that for the large windows, however the scaling will differ slightly, so you could UV unwrap them individually. In this video we look at adding a door material and linking UV maps. Let's get started. In the outliner, let's switch off the window collections. Then switch on the door collections. Now we're going to add a wood texture set when creating the material. I downloaded this from AmbientCG and it's called Wood 029. But first, let's select one of these handles. The color indicates a missing node. Open the Materials tab and select the handle. Here, there is a principled and glossy node, but no output node. There was obviously an issue with the creation of this material. Let's select the glossy and delete this. From the Add menu in Output, we can choose a material output. This node should always be included and be the last as it outputs the result of the node system. Connect the principled node to the output and create the material. We can increase the metallic slider to 1. Then reduce the roughness to 0.3 and have a metal material. Zoom in and take a look. That looks good. Make further modifications if necessary, but that's fine for now. All handles will update as they all use the same material. Next up is the front door. We can add in texture maps and that way we can preview the material as we unwrap and find the correct scale. In the Materials tab, select the door material. We can drag select all these 3 nodes. Press X and delete them. Now connect up the principled shader. We can add in the texture maps now, and I can speed up that process. You will have noticed the material isn't visible because the door has no UV map. We can increase the scale to 3 in the X, Y and Z here. Now we can switch into the UV Editing tab. Press Z and switch to Material Preview. Let's make this object local and focus in on it. For the wood material, I'd like the grain running top to bottom on each length. That will involve making sure the UVs are rotated correctly to match the orientation of the door frame. Let's select it all. Press U and we can first give this a UV map, so use the Smart UV Unwrap. Set the island margin to 0.02. Now click OK. As we can see, the UVs are not orientated correctly, so we'll have to manually rotate them. Select the glass panels front and back. Press S and scale these down and leave at one corner. Procedural materials don't require UV maps, so these can take up little to no space. Let's also press H and hide these. Come into a front view first. Press Z and switch to wireframe shading. Drag select the faces left and right. In the UV editor, press R, input 90 and enter. Press G and drag off the grid for a moment. We can start manually packing these now so they can all fit without overlapping. I can quickly rearrange the UVs. I'll make this full screen so you can see this. These can be packed in the one corner first so they can be scaled up once packed. Select them all. Change the pivot to 3D cursor. That way, if we press S, the UVs will scale from the position of the 3D cursor. Scale these right up. We can return to double view. Press Alt plus H and unhide the glass UVs, making sure they're not overlapping. Press Z and switch to Material Preview. Now the grain is running along the length and the material looks correct. Let's return to Global View. Select the door frame now and isolate this object. tab into Edit mode. Select it all and press U, and we can use the Smart UV unwrap again. Make sure it has an island margin and click OK. Select any faces where the grain is flowing the correct direction. These few here. Press Ctrl+I and invert the selection. On the UV grid, press R, input 90 and enter. Now quickly pack these onto the grid. Have them arranged so we can scale up in a moment. Now select them all, press S and scale to fit. We can return to Global and tab back to Object mode. Let's use the Make Links command and transfer the UV data onto the other door frames. So we can Shift select all the door frames. Then finally, the door frame we just modified. This is now the active object. Press Ctrl+L and we can copy the UV maps. The same can be repeated for the internal door panels on the back door. So Shift select this object. Press Ctrl+L and copy these UV maps. I'm going to work around and UV unwrap the large garage door and the internal doors on the ground and first floors. Try get that done between videos, as it will be the exact same process we just covered. Make sure and use the Make Links command to save yourself lots of time. Also, feel free to use a different texture set on the doors. In this video, we UV mapped the external walls and used the Seams from Islands command to help speed up the process. Let's get started. Hopefully you got the doors unwrapped and we can move on to the environment. Let's switch back to the Layout tab. In the outliner, we can switch back on the environment collection. In the scene, press Ctrl+H and isolate this environment collection. Let's select the wall and we can create a new material. Rename this wall. Select the ground plane and create a new material from this also. Rename this environment. The ground plane will be split into separate objects to make management of the elements easier. For now, let's focus on the wall. So select it and we can first add the texture maps to help UV map this. I've gotten the brick 066 from Ambient CG for this material. So I can quickly add these in here. Let's tab into Edit mode. Select it all. Press U and choose Smart UV Project to start this off. The scaling looks a little off, so increase this to 7 and take a look. Let's switch into the UV Editing tab. We can first remove the bottom faces on this, so press numpad 1 and switch to wireframe shading. Drag select the bottom vertices. Press X and delete faces. Now we can select it all. Press M and we can merge by distance and check for overlapping vertices. Press U and choose the Smart UV project. Increase the island margin. Now click OK. Press Z and switch back to Material Preview to take a look. That looks like it could be improved. Let's come to the UV menu and choose Seams from Islands. This will mark in the seams created by the automatic unwrap Smart UV project. If we look at the corners, it's clear these are still partially connected. So let's press numpad 7 for a top view. Switch to Edge Selection also. Press Z and switch to Wireframe. Now drag select the corners. Hold the Shift key and add these to the selection. Press Ctrl+E and mark seam. Select it all again. Press U and this time we want to add to the UV unwrap, so choose the first unwrap option. That tidies that up much better. Let's press Z and switch to Material Preview and take a look at these orientations. There are a few walls that need their UVs rotated. In the scene we can shift select these walls. In the UV editor, I can select the remaining small faces. Press Ctrl+I and invert the selection. Press R, input 90 and enter. Drag select these remaining UVs. Then we can remove these away off the grid. Now drag select all of these and position back on the grid. Now drag select these small ones and pack them back in here. In the scene, what we can do is select any face on the corner that is not aligned. In the UV editor, if we press G and move along the Y-axis, move them up until they align in the scene. I can quickly repeat that for the remaining faces here that need to be corrected. That looks good. We can improve the wall, so in the modifiers tab, add a bevel modifier. Reduce the amount to 5 mm. If this isn't being applied to the wall, expand the geometry tab. In here, uncheck clamp override. In this video, we start separating the ground plane into the grass, paving and stone sections. Let's get started. Let's move on to the ground plane now. This has a non-uniform scale, so press Ctrl+A and apply all transforms. That way, the location is also zeroed out. In the outliner, we can press the minus key a couple of times and close down the collections. Then switch on the GF wall collection so we can see where to add edge loops. Also, switch on the GF floors to display the front step. Let's tab into edit mode. Switch to solid shading as it's easier to see the edge loops. Press Ctrl+R and add an edge loop along the Y-axis. Now snap to the outside wall. We can repeat this for the opposite side and add an edge loop. Then snap this out to the edge. We can also add one to the front and snap this in here. Then add an edge loop to the back and snap this in here. Let's open the Material tab. We'll be using particle systems to create grass and stones, so we need to separate this plane first. Let's select the faces that will have grass applied first. We can start selecting all the faces around the front and side. Then select the center faces around the house. All these faces will be the grass area. Press P and separate selection. Next, we can select the faces at the front here. These will be paving. Press P and we can separate this selection. The remaining faces will be the stones, so let's update the material name. Rename this stones. We can drag select the faces directly underneath the building. Press X and delete these. Select it all now and press U and we can use unwrap. This will do for the unwrap, so let's tab back and select the grass area. Now tab in here. Select it all and we can unwrap this also. Finally, we can tab back and in the Material tab click and remove the stones material. Click New and create a new material and rename this grass. Select the paving and tab in here. We can unwrap this also. Planes don't need seams, so the basic unwrap always does the trick. Let's tab back. Remove the material here also. Click and add a new material. Rename this paving and press enter. You can work ahead and find some texture maps for this paving material. Then add those to update the material. You can also add grass textures to the grass material and stone or gravel textures to the stone material. These will be the base material for the grass and stones, and we'll be adding a particle system over those too. I can also add in the texture maps between videos. In this video, we start creating a stone particle system. Let's get started. Hopefully you have added in texture maps for the grass and stones. These will act as the base and aren't really important, just have some material applied. The tiles also need a material, and this one will be to the fore and seen by the camera. Let's move back to the Layout tab as we'll have more room to work here. In the outliner we can hide the ground floor walls and the floors collection. I have also named the 4 objects in the environment collection so they can be easier identified. They are the grass, paving, stones and the wall objects. We can switch to material preview for this. Let's move over to the right side and start creating the rock objects that will be used by the particle system. The particle system in Blender is used to emit a large number of objects from a mesh. You can then control the object scale, rotation, and material along with many other properties. Let's press Shift and right-click over in space to place the 3D cursor. From the Add menu in Mesh, we can add an icosphere. Let's tab into Edit mode. Select it all and scale to 0.2. We want to form this into a stone shape. We can use the proportional editing tool here. The shortcut is O. Switch to vertex selection and select the vertex. Proportional editing allows you move one vertex while influencing nearby vertices, depending on the area of influence. Really great tool for working with organic shapes. Roll the mouse wheel in or out to decrease or increase that influence. The white circle indicates the radius of influence and it is also displayed up top here. We can use this to form this sphere into a rock shape. These can be adjusted later if you want to modify the shapes. We can also place the origin of this stone to the base. So select the bottom vertex. Press Shift+S and put the cursor to selected. Tab back and we can right click and set the origin to 3D cursor. Now tab back in here. We can select it all. Press Shift+D, X and drag this across and left click. Then press Shift+R and repeat the last command. Repeat that 3 more times until we have 5 copies. Then quickly work along and shape these into unique stone shapes. I can speed up this process. Once this is complete, let's select them all. We want these separate objects, so press P, and this time we can choose by loose parts. Let's select what's left. Press U and we can unwrap with the Smart UV project. Click OK. We can tab back now. With them all selected, press Ctrl+L and make links and copy UVs. We can also come to the Material tab and from the drop-down search Stones. Press Ctrl+L and make links to the material. Next, we can press M and create a new collection for these stones. Name this Stones and add these in here. Then we can drag and drop the Stones collection into the Environment collection. To create the particle system, we can first come back and select the stone object over here. Then come to the Particle Properties tab. Now click the plus to create the particle system. Then press F2 and rename this particle system Stones. The emitter type can be changed to Hair. This creates extrusions from the mesh. We can control what is extruded, so let's come to the Render tab. From the Render As drop-down, change this to Collection. Then we can pick the stone collection from the Instant Collection field. We can zoom into the mesh here and take a look at how these are emitting. They look a good size, but we do need some more, so let's come back to the particle properties. Check on Advanced here. This will enable more options. Let's check on rotation and expand the properties. I find the normal orientation axis works well here. That way we can use the randomize slider and randomize the rotation. Because these are about the same size in the render area, we can use the scale random to randomize the scale between the different stones. We also need to omit more stones as it looks quite sparse. Up top, we can input 20,000 in the number field and increase the amount greatly. In this video, we start creating grass material and modeling a blade of grass. Let's get started. We first need to model a blade of grass. We can come into a front view and zoom in here. Press Shift and right click and add the 3D cursor here. I can drag in a web browser. We're going to need a grass texture and you can find one here on Ambient CG. I'll be using this one here, so download this or similar. Let's open back up Blender. Press Shift+A and from Image, we can add a background image. Navigate to where you saved those textures. We can use the foliage preview. So select it and load background image. That's very large, so open the Image Properties tab. Here we can reduce the size of the image. We can use this as reference modeling the blade of grass. Let's press Shift+A and from Mesh we can add a plane. Let's tab into Edit mode. We can switch off proportional editing for a moment. Press R, X, input 90 and enter. Let's also switch to wireframe shading so we can see through this plane. Let's press S and scale this plane down to the width of the blade. This one here, so move this over to the base. Scale again and fit the image. We can drag select the top two vertices. Press E and extrude. Start extruding and scaling up along this and forming the shape. I can quickly work up along and create this shape. Let's come into a side view. Switch back on proportional editing. Select the vertex and press G and drag this back and form a curve or how a grass blade might look. Reduce the area of influence and start shaping this to look more like a grass blade. Next, we can add a material. So switch to the Shading tab. Click New here and create a new material. Rename this Grass. Select the Principled node. Press Shift plus Ctrl plus T. Here we can select the usual nodes, and this time include the opacity map. Now add these in here. In the Materials property, we can scroll down and change the blend mode to Alpha Blend. Let's switch into the UV Editing tab to finish this material. Press the / key to isolate the blade. Press Z and switch to Material Preview. In the image drop-down, let's search for one of the grass images to use as reference. Select them all now. Press U and we can unwrap this. Now drag this over to match the one we used as reference and match the image until it fits correctly. We can tab back to take a look. Next, we need to make a clump of grass, so tab back in here. Drag select the bottom vertices. Press Shift+S and put the cursor to selected. From the pivot menu, let's switch this to 3D cursor. Let's come into a top view so we can rotate the copies more easily. Select it all. Press Shift+D and rotate around a little. Then left click. Press Shift+R and repeat that a few more times. We can create a second clump to help add variation to the grass. Select it all. Press Shift+DX and drag this away. Press P and separate selection. Select it all again. This time we can press S and scale this down a little. We can tab back and right click and set the origin to 3D cursor. Let's also press F2 and rename this grass blade. Select the larger clump and tab in here. You can vary the shape on this. Try make the shape a little different than the first. Now drag select the bottom vertices. Press Shift+S and put the cursor to selected. Now tab back and right click, then set the origin to 3D cursor. We are finished with the background image now, so select this, press X and delete. In this video we look at distributing grass using geometry nodes. Let's get started. To begin, let's move back over and select the grass plane. Let's switch into the Geometry Nodes tab up top here. You may need to roll the mouse wheel to bring that into view. This workspace has a spreadsheet editor and Geometry Nodes editor below here. The rest we're familiar with. In the Modifiers tab, we can add a Geometry Nodes modifier from here, or we can click this New button and add one. Let's rename this GN Grass. I usually use a suffix to help identify objects. It's especially useful when you have many similar objects in the scene. This has created two nodes, a group input and group output. In between is where we'll instance the grass objects using the points distribution node. Geometry nodes are similar to the particles we use to create the stones. In the spreadsheet, the object's vertices are listed with each one's X, Y and Z coordinates in 3D space. Let's press Shift+A and from points we can use a distribute points on faces node. Drop that over the line and connect it up. Straight away that scatters small points around our plane. What we can do is replace these points with the grass clumps by instancing in place of the point positions. You may also have noticed the plane has been replaced by this distribution of points. There is a join node that we can combine objects. So press Shift+A and from Geometry we can select the Join Geometry node. Drop that on the line to connect. Then take the original geometry and connect this up to the Join Geometry node. I can tidy these nodes up so you can see where each line is coming and going from. Next, we can replace these points by instancing the grass clumps in their place. So press Shift+A and from Instance, we can choose Instance on Points. Place this in the graph. Then we can divert the distribution on faces node into the points input. Connect this from the Join Geometry node also.
We can then break the link from the points on faces. Not this, connect this back up.
First, in the scene, let's come over to our grass clumps. Drag select these two objects. Press M and in the environment collection, we can create a new collection. Rename this grass. That way, we can call the objects inside this collection.
So let's come back over to the grass plane and select it so the nodes are available. In the node editor, we can press Shift+A, and from the add menu in input, we can find and add a collection info node.
We can check on both separate children and reset children so the grass gets displayed.
Then connect the instance output to the instance input.
From the collection dropdown, search for the grass collection and add this in here. This grass can be scaled down using the scale properties. I can set this to 0.4 and see how that looks. Use the density slider to increase the amount of grass getting instanced. Increasing the density slider too much may impact performance. Also, use the seed property to randomly vary how the grass is instanced. Use the Disable in Viewport button when the grass is not needed to free up the scene. You can modify the grass blades and clumps to improve the look of your grass at any time. Also, adding more clumps and varying the design will help greatly. In this video, we look at creating a tree with the sapling add-on. Let's get started. The first thing we can do is press F4 and down here open Preferences. Open the Add-ons tab and in the search box type sapling. This is in the Add Curve category, Sapling Tree Gen. Enable this and we can close Preferences. Let's come back to the Layout tab first where we have more screen space. These objects get created at world origin, so in the outliner, let's right-click beside the scene collection up top. Here we can create a new collection. This should be created below here. Double-click and rename this tree. Once it's selected, anything we add will get added inside. Press Ctrl+H and choose the tree collection. Then from the Add menu in Curve, we can choose the Sapling Tree Gen. That generates a base tree in the scene with a properties box. This properties box is temporary and remains while you modify the tree. Using another command will close the properties for good. However, if you only accidentally click away, you can get these back by pressing F9. We can start up top with the Settings tab. Here, the tree creation process is listed in the order you might work through creating the tree. We can start with geometry. We can also load a preset from the menu below here. For this, I can choose a Douglas fir. That makes this very large, so in the scale field, let's input 1 and reduce this in size. You can also make adjustments to these settings, but let's move on to the Leaves tab next. Here we can check on Show Leaves. This can help greatly when designing a tree. Change the leaf shape to rectangle. That will make UV mapping easier. Now we can move on to the Branch Splitting tab. The first setting here is Levels. This will increase the number of secondary branches. We can increase this to 4. This will greatly increase the number of branches and leaves on the tree. Feel free to experiment with the tree style and settings, but I'm happy with this tree now. In this video, we look at creating the bark and leaf material. Let's get started. When creating material for this tree, we'll need to get some textures. On ambient textures, there are both leaf and bark textures available. These textures are available from other sites also. Try get both texture sets downloaded and we can set up the material on our tree. We can open back up Blender. This gets created in 2 pieces. There are the leaves and the tree trunk. We can move these independently. I can right click. You're better off not moving the leaves as they are specific to the trunk. If we select the tree trunk and move this, the leaves are parented and will move along. This is how you want to move the tree. When duplicating, make sure both objects are selected. Let's start with the tree trunk. We can switch into the UV Editing tab. This object is a curve, so we'll need to convert it to a mesh before UV mapping. So tab back to object mode first. Then from the object menu, we can come down to convert and choose mesh. Now we can tab back into edit mode. The tree is made up of separate objects and makes it easy to unwrap. The trunk is one object and the branches are a collection of separate objects. We can focus on the trunk and leave the branches. They are on the grid here and there is no need to update those UVs. They would take up too much space and would not be seen up close. So we can first add some seams to the trunk. So we can Alt select an edge loop about 1/4 the way up the tree. Hold Shift and select another edge loop about halfway. Then finally Alt select an edge up 3/3 of the way up. Press Ctrl+E and we can mark a seam across these edges. Then if we rotate around to the back of the tree, we can Alt select an edge running top to bottom. Then we can mark a seam here also. Then press Ctrl+L to select Connected. We can press U and unwrap. We can then press Ctrl+I to invert the selection. And in the UV editor, press S and scale down the branches so they take up less space. Let's add in the texture maps and create the material. So let's switch into the shading tab. In here, click New. Rename this Tree Trunk. I can speed up adding in the texture maps. Let's press the / key to isolate this. The scale needs adjusting, so I can input 5 in the X, Y and Z. That looks better. Let's return to Global View and select the leaves. We can click and add a new material. Rename this Leaf. Then if we select the node here, I can speed this up and add in these textures. Then in the Material tab, come down to the bottom, update the Material Blend mode to be Alpha Blend, and that way it uses the opacity channel. We need to adjust the UVs, so let's switch into the UV Editing tab. In the Image Settings, we can X off whatever is here. Then in the drop-down, find the leaf texture from the material. This one here. I can drag the UVs away for a moment so you can see the texture. We need to place all the UVs over one of the images here. You could use the other two textures by selecting certain faces and placing them over the image, but I think this will be fine.
In this video, we start applying modifiers and start combining objects. We also test Boolean subtraction. Let's get started. This is the animation we're aiming to achieve in this section of the course. The plan will roll open and the house will begin to reveal itself. You can make a storyboard to help with the timing and sequence, or just use this reference video. You'll find it in the resource folder. Also here, I've created a list of each object with a description of the property we keyframe, with the frame number and second included. These start as placeholder values and changed as I worked through the animation, adjusting the timings. The list should help you understand what steps to take to complete the animation. Feel free to adjust the sequence and flow. So now is a good time to save a copy of your work. Use Save As, and that way if you need to start over at any point, that file will still be available. We'll be using Boolean modifiers to subtract from objects, making them appear and disappear. In order to have this work correctly, there are a number of steps required. These include applying modifiers, removing parent-child relationships, and finally combining objects together. Also, we need to make sure there are no extra vertices, edges, or faces within the objects, as this can lead to the Boolean failing or getting glitchy results. Let's start by coming back to the Layout tab, where we have more viewport real estate. Drag select the trees. Press M and add this into the tree collection. In the outliner, we can switch off the tree collection for the moment. Then let's switch on the ground floor wall, the first floor wall, and the ceiling collections. The first object we can select is the ceiling object. In the modifiers tab, we can see this has a Boolean modifier that's subtracting the hole for the stairs. We need to make that hole permanent. So press Ctrl+A and apply the modifier. The wall objects don't have any modifiers, but select them and make sure. So select everything. Press Ctrl+J and join these into one object. Press F2 and rename this new object Walls. That makes 2 empty collections in the outliner, so select and delete these. We can rename the remaining collections Animation. Now we can test the Boolean object on this wall and make sure there are no issues before moving on. So press Shift+S and put the cursor to World Origin. Press Shift+A and from Mesh add a cube. Let's come into a front view. We can move the cube up to sit on the grid floor, so press GZ, input 1000 and enter. In the Object Properties tab, we can come down and expand the viewport display. From Display As, change this to Wire. That way we can see the subtraction happen. Let's tab into Edit mode. Press Z and switch to Wireframe Shading. Drag select the top vertices. Press G, Z and drag these up above the wall. We can switch back to solid shading. Also, come back to object mode. Let's come into a top orthographic view now. Press G and drag this to about center of the walls. Press S, Shift Z to exclude the Z axis from scaling and increase this to cover the entire object. Let's press GZ and drag this up above the walls first. Select the walls and in the modifiers tab we can add a Boolean modifier. Use the picker and select our cube object. Now if we select the cube, press GZ and drag this down. The house does start to disappear, but it's very glitchy. We can right click. The default Boolean settings work best on manifold or watertight meshes, closed volumes and not overlapping. Our walls are not manifold. To get around that, we can expand the solver options. With exact solver enabled, we can check on self-intersection. This solves the problem where geometry is overlapping. It's a slower solve, but we don't get glitchy results. So now, if we select the cube and drag this down over the walls, we should get a smooth subtraction without issue. So that's the test complete, and we'll continue to combine the remaining objects in the next video. In this video, we continue preparing the objects for animation. Let's get started. To begin, we can switch off the animation collection. Next, switch on the environment collection. If we select the grass object, in the modifiers tab, we can switch off the grass modifier. Having this left on would slow the viewport down. In the geometry nodes tab, the density value can also be reduced to maybe 10 from 100 here. That will help free up the viewport response time if you do want that grass enabled. These can slow everything down and make the computer feel sluggish. Let's switch back to the layout tab next. The external wall will be a separate object. Press F2 and rename this external wall. Now press M and move this into the animation collection. This base object will combine with the floor objects, so let's press H to hide this for the moment. Press A and select the remaining environment objects. These cannot be combined as they have particles attached, but we can press M and move these into the animation collection. Next, we can switch on both the FF and GF floor collections. All the ground floors have a solidify modifier, so select all of these. Then press Ctrl+J and combine them. Apply the modifier now. Let's press Alt+H and unhide the base. Select this as we also need to apply the solidify modifier. Let's Shift select the step, then the ground floor floors. Press Ctrl+J and join these into one. Press F2 and rename these GF_floors. For the FF floors, let's drag select all of these. Make sure one is active. Press Ctrl+J and join these into one. Press F2 and rename these FF floors. These will reveal at different times, so will remain separate objects. Press A and select them all. Press M and move these into the animation collection. Then in the outliner we can select both these empty collections and delete them. Next we can switch on the Archimesh collection. We can start with the roof. The first thing I want to do is change the color of the roof tiles, so switch into the shading tab. Here I'm going to make this a darker color to represent roof slates. Then we can hover on the color swatch and press Ctrl+C to copy the values. We can switch back to the Layout tab now. In the Material tab, open Viewport Display. Here, press Ctrl+V and paste in those color values and update the viewport. Let's open the Modifiers tab. We can press Ctrl+A and apply the Solidify modifier. Then we can X off the Subdivision Surface modifier. This can be added back later if necessary. Then apply both array modifiers. The second section of roof we can apply the modifier. Then Shift select both these objects. Press Ctrl+J and join into one. These will be a separate object. Press F2 and rename roof. Press M and move to the animation collection. Next we have the stairs. Apply the mirror modifier now. Press M and move to the animation collection. We can select this object we used to subtract the hole for the stairs. Press X and delete this. The railing objects will move into position, so the first thing we can do is select all three. Press Ctrl+A and apply all transforms. That way, if they are moved from position, inputting 0 in the location field will move them back to this location. We'll use empty objects to control these during animation, so each will need to be parented to an empty. I can cover the first, then you can get the remaining two done before the next video. Let's start with this one here. Press Shift+S and put the cursor to World Origin. Press Shift+A and down here in empty, let's add a plane axis. Press F2 and rename this empty _front_balcony_rail. Now we can parent it, so select the rail. Shift select the empty. Press Ctrl+P and parent object keep transform. So now moving the empty object will move the rail, and we'll be adding keyframes to control this object's movements. Now we need to repeat that for the remaining two. Add two more empties. Rename them and parent the respective railings. Then move all these objects into the animation collection. We can continue in the next video. In this video, we continue preparing the objects for animation. Let's get started. Hopefully you have set up the three empties and they're controlling the three railings. So if each one is moved out of position, it will be just a matter of inputting 0 into the location transform. We can drag select all these objects now. 6 objects should be the total here. Press M and move these into the animation collection. We can then select and delete the Archimesh collection. Finally, we have the door and window collections to prepare. Let's start with the first floor doors and window collections, so switch these on. I'll cover the process with these two collections and then you can finish the ground floor collections before the next video. Let's zoom into the door handles. These have subdivision surface modifiers and will need to be applied. The easiest way is to combine all the handles first, then apply just one modifier. So let's come to the select menu and select linked. Here we can select material. That should select all the objects using the same material. So press Ctrl+J and combine these. Now in the modifiers tab, press Ctrl+A and apply this subdivision surface modifier. The next object with a modifier is the window sill, and this has a bevel modifier. So let's come back and select linked by material again and select all the window objects. Press Ctrl+J and combine these. Now apply the modifier. Next we can drag select all the objects. Press Alt+P and clear any parent constraints and keep transformations. We won't need the empty objects, so from the select menu let's select by type and choose empty. Press X and delete these. We also want to delete these subtraction objects, so again, from the menu we can select linked by material. Press X and delete these. Now we are ready to combine all the objects that remain. So drag select what is left. Make sure one object is active. Press Ctrl+J and join these into one. Press F2 and rename these doors_windows. Let's tab into edit mode and select it all. Press M and merge by distance and remove any overlapping vertices. We can tab back now. Let's press M and move this into the animation collection. Then we can select and delete the empty window and door collections. Next, we can switch on the ground floor door and window collections. This will be the same process as the previous example. First, combine the door handles and apply the subdivision surface modifier. Then clear any parent relationships and finally combine. So try work through the process and complete this before the next lecture. In this video, we continue to combine the remaining objects. We also check the face orientation and merge overlapping vertices. Let's get started. To begin, we can switch back on the animation collection in the outliner and also expand it. All the objects we need for the animation will be in this collection, apart from the tree and stones and grass objects. Let's select the two window and door objects in the scene. Press Tab into edit mode and select them all. Press M and we can merge by distance. It's important not to have any overlapping vertices because this may affect the Boolean modifier. Let's tab back to object mode. Press H and hide these. The roof will be its own object, so tab in here and select it all. Press M and merge by distance. We can tab back now and press H to hide this also. Next, we can select the walls. Let's tab in here and merge any overlapping vertices. We can tab back now. We can hide this also. Shift select the top and bottom floors and tab into edit mode. Select them all. Press M and merge by distance. We can tab back and hide these also. Next, we can check the stairs, so tab in and merge any overlapping vertices. We can tab back now. Press H and hide this also. The railing objects we can just select and hide. Also, the three empty objects at world origin, let's select and hide these. Select the outer wall and tab in here. We can check this for overlapping vertices now. That's it, so tab back. Press Alt+H and bring the hidden objects back. Press Q and check the face orientation. Some window panes may show red, so select them and tab in here. Select any red faces and recalculate to reverse them. We can tab back and switch off this overlay. Let's select this cube object we added earlier and press H to hide. We can press A and select everything else. Press Ctrl+A and we can apply all transforms. That way, if you accidentally move an object out of position, you can easily zero out the location and put it back. In this video, we enable the Images as Planes add-on and import the plan texture. Let's get started. For this video, I'll be using wood plank textures for the tabletop. This will be an outdoor table, so download a texture set for that type of material. I already have one downloaded and ready to go. We'll also be using a plan texture for the plan that rolls open. I have provided a plan texture in the resource folder, so download that and have it ready. Let's press Z and switch to Material Preview. In the outliner, we can select the animation collection. That way, when we add the planes to the scene, we can be sure they get added to this collection. So press Shift+S and put the cursor to World Origin. We can press Shift+A and from the Add menu in Mesh, add a plane. This will be the tabletop, so needs to sit underneath everything. Let's press numpad 1 and take a look at its position. Right now it's sitting above the ground. So first, press GZ and snap down to the bottom of the wall. This will make it sit at the same level as our grass and tile plane. This will cause Z fighting and flickering, so we need to move it down a little further. In the Z location, it's currently -200. We can update this to -202. In the pivot menu, let's change the pivot to medium point. Let's tab into edit mode and select it all. Press S, X, input 60 and enter. S, Y, input 45 and enter. While we are in here, let's press U and unwrap this to update the UVs. Now we can switch into the shading tab. We can create a new material. Rename this table top. I can speed up adding in the plank textures. I've left the default scale of 1 on the mapping node. I did rotate the textures 90 degrees using the Z rotation field here. Let's switch back to the layout tab. Next, we need a plane for the plan texture. For that, we can use an add-on that will automatically add and set up the texture. So first, press F4 and open Preferences. In the Add-ons tab, search Image as Planes. This Import Images Plane add-on here. Enable this and we can close Preferences. Then from the Add menu in Image, we now have this option, Add Image as Planes. Navigate to where you saved the asset folder and stored the image called Plan Texture. Select it and we can import this image as a plane. That creates a plane, then creates a material with the texture added. We need this scaled up so that the drawing matches the size of the house. That way it will look like the house extrudes from the plan. So let's press S and scale this up first and get it close to the size we need. Then press numpad 7 for a top view. This first needs to be rotated, so press R, Z, input 90 and enter. In the animation collection, let's hide all objects except walls and the plan texture object. That will make placement much easier. Then center this drawing up on the walls. Now start scaling it to match the outline. If you zoom into the 4 corners, you'll be able to get this exact. Just make sure it's close and the 4 edges match all around. That looks good now. Next, we can position this on the Z-axis just above the tabletop. So in the Z location, we can input -201 here. In the Modifiers tab, we can add a Subdivision Surface modifier. This will add extra geometry to help roll the plan. We can increase the levels to 2 and increase the geometry further. Then set the algorithm to Simple and keep the integrity of the corners. Press Ctrl+A and apply the scale before we add extra geometry. Finally, tab into Edit mode and select it all. Right-click and we can subdivide it. In the Options box, increase this to 20. Now we can tab back. In the scene, press Alt+H and bring back all the objects inside the animation collection. In this video, we use a curve modifier to roll and unroll the plan. Let's get started. Make sure the cursor is at world origin. Press Shift+A and in Mesh, add a plane. Press F2 and rename this Roll Control. We can then tab into Edit mode. Select the 2 vertices on the left. Press X and delete vertices. We are going to form this into a spiral shape using the screw tool the plan can follow. Select the 2 remaining vertices. Next, we can use search, so press F3 and search screw. This one here, edge screw. In the axis X, we can input 1, tab into the Y and Z and input 0 for both. That flattens this along the Y. Let's switch to wireframe so we can see this a little easier. We need this wide enough so it's not bunched up at center. In the Y center, we can input 2420. We can increase the resolution of this by increasing the steps to 32. Next, we can have this repeat several times, so in the turns, input 8. Next, we can switch to edge selection and Alt select this second edge. Make sure you select the correct edge here. This will be the shape we use to roll open the plan. Press Ctrl+I to invert this selection. You should have this selection now. Press X and delete edges. Next, we need to orientate this correctly. So press R, Z, input 90 and enter. Then press RX, input 180 and enter. Then finally scale down, so press S, input 0.15 and enter. Let's come into a front view now. Press G and drag this up above the ground for the moment. We'll be positioning it more accurately later. Select the end vertex. Press Ctrl and select the 8th one in. Press X and delete vertices. We want this extruding straight out so the plan starts out flat. Select this end vertex. Press EX and drag this away here. Next, we need to set the origin of this object, so select the inside vertex. Press Shift plus S and put the cursor to selected. We can tab back now and right-click and set the origin to 3D cursor. Then right-click and convert this to a curve. Let's switch back to Material Preview. In the outliner, we can select the Plan texture. In the Modifiers tab, we can add a curve modifier. Then use the picker to select our Roll Control object. That will roll up the plan. The plan may overrun the curve, so let's Shift select both objects. Press the / key and isolate. So if we select the Roll Control object and press GX, drag this across here, the plan should roll open. We'll have to align the plan to the walls again. So let's press the / key and return to Global. These are way over here. So in the outliner, hide all the objects except the walls, plan, and Roll Control. Select both the plan and control, then press numpad 7 for a top view, and move these so the plan aligns again. This time one corner will do, as we know it's the right size to fit the plan. So now if we select the control and move this back and forth along the x-axis, the plan will roll out under the position of the house and into position. The plan is down too far on the z-axis, so in the outliner, let's switch back on the table plane so we can see this. Select both the control and plan. Press GZ and drag this up so the plan sits above the table. Just make sure it's just above and not at the same level, and avoid any Z fighting. We can select the plan and right-click and shade smooth. In this video, we start setting up the Boolean modifier to reveal the building. Let's get started. The first thing we can do is press Alt plus H and unhide everything. We added this cube object previously to test the Boolean modifier. We can finish setting this up now. Let's press F2 and rename this wall_cutter. We'll use this to subtract the walls, doors, and windows. Let's move this into a separate collection, so press M and we can create a new collection. Rename this Cutter Objects. In the outliner, we can press the period key and bring this into view. It's really important we uncheck this icon, Exclude from Render. That way, this cube object will not be included in the final render. Otherwise, you'd see a cube covering the entire building. Let's come into a front view now. Press GZ and drag this to the bottom of the wall. To make sure there is no Z fighting and the Boolean modifier is below the ground, press GZ input -1 and enter. We can apply the location, so if it accidentally gets moved out of position, we can simply zero out the location. So press Ctrl plus A and let's apply all transforms. Let's press GZ and drag this up above the walls. Next, press Shift plus D and right-click. Press F2 and rename this door_win_cutter. We can tab into edit mode and select it all. Press S, Shift Z and scale this in a little so we can tell the difference between the two. Just make sure it's still covering the doors and windows. Scale it down a little more along the y-axis also. We can tab back now. Let's select the doors and windows top and bottom. In the Modifiers tab, let's add a Boolean modifier. Use the picker and select the door_win_cutter object. Change the solver to fast here. I find with more complex objects like these windows and doors, exact subtracts very slowly. Press Ctrl plus L and we can copy the modifiers from the selected to active object. if we select the door and window cutter object, press G, Z and drag down, the objects will disappear. Some edges become visible as we drag down, but edges don't render, so they will be fine. Here in my file, some artifacts remain, so I'll select these and tab into Edit mode. Press Z and switch to wireframe shading also, so we can see these. I need to zoom right in here. These are extra vertices created by the Archimesh add-on when creating the door. I need to select all these extra single unconnected vertices. Press X and delete. You may come across this yourself, so make sure and delete them. So now tab back and switch back to Material Preview. Let's put the cutter object back to 0 so we can see how many more we need. We'll need 1 for the roof, 2 for the floors, 1 for the external wall and 1 for the stairs. So that's 5 more. Let's select one and press Shift+D and right click. Press F2 and rename this roof_cutter. We can tab into edit mode and come into a top view. Let's select it all and move center of the roof first. Then scale down on the Y-axis and bring it closer to the size. But make sure it's still larger. Scale on the X also. Let's come into a front view now. We can drag this up and center on the roof. Now scale this down along the Z-axis and just cover the roof. Adjust its position if necessary. We can tab back now. Let's press Shift+D and right click. Press F2 and rename this one FF_floor_cutter. We can tab into edit mode. Select it all and drag down and cover the first floors. Make sure they are covering these. Shift+D again and drag down and cover the bottom floor. Make sure it's covering the base also. Press P and we can separate this by selection. Tab back and select it. Press F2 and rename this GF_floor_cutter. Next up are the outer walls. Let's select the wall cutter. Press Shift+D and right click. Press F2 and rename outer_wall_cutter. Let's come into a front view now and tab into edit mode. Select it all. We can drag this to about center of the wall. Now S, Shift Z to scale along the X and Y axes and cover the walls. Reposition and scale so it just covers the outer wall. We can stay in edit mode for the stairs, so press Shift+D and right click. Press Z and switch to wireframe shading. Press S, Shift+Z and scale this right down. We may have to rotate around to see the stairs. Press G, Shift Z to eliminate the Z axis when moving and keep the bottom in position just below the floor. Now scale and position this cutter around the stairs. With that done, let's press P and separate selection. We can tab back now. Select this and press F2 and rename this stairs_cutter. Then for each of these objects, we can add a Boolean modifier and use the picker to add the cutter as the object. Set the solver to fast. I can quickly work around and add a Boolean modifier to the remaining objects. This ground floor cutter object needs to be extended over the front step, so I can drag these vertices forward in edit mode. Once these are all done, the only remaining objects visible should be the balcony railings. In this video, we set up the camera with a follow path and track to constraint. Let's get started. When animating, it's always useful to do it from the camera view. After all, this is what the viewer will see while watching the animation. So it's helpful to see it from that perspective. In the outliner, let's shift select all the color objects. Press G, Z and drag these up to reveal all the components of the building. Then from the Add menu, we can add a camera to the scene. To help control the camera, let's switch into the Animation tab and use that screen layout. In the left viewport, press numpad 0 and enter Camera View. In the right side, let's press the / key for a moment and take a look at the camera. The triangle here indicates the top of the camera and also the front. The tip here is the viewing point, and anything to the front side of this point will be seen by the camera. This is also the origin of the camera and the rotation point. You'll notice this triangle is filled in, meaning this is the active camera. The active camera is the one used when rendering. If there are multiple cameras in the scene, you can switch between them and render at different frames. If I add a second camera for a moment, notice how the triangle is not filled, whereas the original camera has still the fill. If we switch to the Scene Properties tab, we can switch between the scene cameras here. This doesn't make the camera active, but just switches into that camera view, and you'll notice that in the left viewport here. To make this camera active, press Ctrl plus numpad 0. Notice how the camera's triangle fills in, and it's now the active camera. We can press X and delete this camera. We can select the original camera again. In the left viewport, press Ctrl plus numpad 0 to make it active again. Let's come into a top view in the right side. Press G and drag the camera back from center. If we try to rotate in camera view, we exit the camera view. Press numpad 0 to return here. If we press N and open the View tab, here we can check on Lock Camera to View. Now, if we use the navigation controls like Zoom, Pan and Rotate, we can do so controlling the camera. So let's position the camera back a little and get a good distance and frame up our model. In this viewport, the overlays are switched off, meaning less clutter in the viewport, including the cutter objects. Use the Overlays button to toggle on and off the visibility if needed. I find leaving them off makes it easier to spot any issues with the animation. If you are happy with the camera position, then press N and uncheck the lock so you don't accidentally move the camera from position. That way you can zoom in and make the camera view larger. Let's return to Global View now. Let's come into a top view. Press Shift and right click and place the 3D cursor about center. Then from the Add menu in Curve, we can add a circle. Then tab into Edit mode. Press S and scale this out to approximately the camera's origin. Zoom in here and make sure that lines up accurately. Press numpad 5 for an orthographic so we can see this correctly. Now get that aligned correctly. We can zoom back out now and also tab back to Object Mode. Press F2 and rename this cam_path. Let's actually drag this object and the camera. Press M and create a new collection. Rename this camera. In the outliner, we can press the period key to jump to these objects. Select the camera collection so the next object gets added inside. We need a camera target object, so from the Add menu, in Empty, we can choose a cube. Press F2 and rename this cam_target. Next, we can select the camera and open the Constraints tab. Then from here, we can add a Follow Path constraint. Now, before setting the constraint, press N and open the Item tab. We can clear out the transforms, so press Alt plus G and clear Location, then Alt plus R and clear the rotation. That places the camera back at center. Now in the target, we can choose the Cam Path object to follow. That snaps the camera onto the path. Now we need to track the empty we added. So we can add a Track To constraint. Then in the target, search Cam Target and add this here. This setup lets you control the camera in a few different ways. You can scale the circle and move the camera in or out. You can also change the pitch of the camera by moving the circle up or down. If you select the cam target and press G, the camera will follow this. This allows you point the camera in any direction. Scale this up to help identify it and select it more easily. Select this in the outliner. In the Object Properties tab, we can check on Show Name, so there is no confusion selecting this object. Finally, we can select the camera. In the Object Constraint, you can control the position of the camera on the circle by using the Offset setting on the Follow Path constraint. This should give us enough control to animate the camera and capture the animation. In this video, we set up an empty object to control the position of the ground planes. Let's get started. To begin, we can select the tabletop and the plan objects. Press H and hide these for a moment. We can press Shift+S and put the cursor back to World Origin. Press Shift+A and from the Add menu in Empty, let's add a plane axis. We can press S, Input 5 and make this large enough to see. Now we can select the grass. Shift select the tiles and Shift select the stones. Then come around and Shift select the empty. Press Ctrl+P and set parent to and keep transform. That way we can select the empty and press G. All three objects move along. We'll use this to control their position later in the animation. Let's press F2 and rename this empty_ground_control. Press Alt+H and unhide those two objects. In this video, we add keyframes under roll control. Let's get started. We are now ready to start animating. We'll begin with the plan rolling open, and that happens over the course of 1 to 1.5 seconds. If we come to the Output Properties tab, make sure the frame rate is set to 24 frames per second. In the dope sheet below, the numbers here are the frame numbers, so every 24 frames is equal to 1 second. In the View menu, I like to check on Show Seconds. The frame numbers get replaced with the time in seconds. You'll notice the label on the scrubber displays seconds and frames. So if I drag this across to 0, 1 plus 18, here this reads 1 second plus 18 frames. In the outliner, let's make some space and expand the cutter object collection. Let's Shift select all these objects. In the scene, press Alt+G to clear out the location transform and place these back on the ground. That way we have a better view of the plan rolling open. Let's select the roll control object. We'll need to make sure the scrubber is back at frame 1. Click this Jump to Endpoint button to place that back. Press GX and drag this across to its start position and when it's rolled up. About here where it's fully rolled up looks good. To set a keyframe, we can press I. This opens the keyframe menu and we can choose a location keyframe. That keyframe will store the object's location at frame 1. This plan will roll open over 1.5 seconds. So we can move the scrubber to 1.5 seconds or 1 plus 14 on the timeline. Then press GX and drag the control object until the plan is flat. Make sure it fully lays flat on the tabletop. Then we can press I and add a second keyframe for its position at 1.5 seconds. So now if we click the scrubber to the start and press the spacebar to play, the plan will roll open. Use the button below here to restart the animation over and over again to get a sense of the timing. The shortcut is the Shift plus the left arrow key. The frame rate indicator here displays how close to the full 24 frames the animation is playing back. You rarely get this full 24 as the computer has to work hard to play back animation. We'll look at exporting a play blast later so you can get a better idea of the timing. You'll notice here the roll starts slow at the beginning, speeds up and slows at the end, and that's due to the interpolation type. By default, when you set keyframes in Blender, they use Bezier, and we can visually see that if we open the graph editor. In the view menu, we can toggle graph editor. I can press Ctrl plus space to make this full screen. Here we can see the Bezier shape easing in and out. We can change this to linear to get straight line interpolation as the plan opens. So press A to select all the keyframes. Press P to open the menu, and in here we can choose linear. That updates, so let's press Ctrl plus space again and return. We can also press Ctrl plus tab to toggle back to the dope sheet. The green line gives us a visual of the interpolation type. We can play this again and take a look at the changes we made. That looks very good with no speed up or slow down. If you'd like to change the speed the plan rolls open, you can by adjusting the position of the keyframes. So clicking the top channel selects all channels beneath. Then click and drag back to reduce the amount of time, or drag forward to increase the time it takes to open. I can right click to cancel. It's easy to change the timing by adjusting the keyframe positions. In this video, we set up the camera. Let's get started. We can begin with the scrubber at 1+14. We can set up the camera start position, so use the cam path and cam target objects to move the camera into the first position. This might take a while as I want to frame the entire plan and fill the camera view with the table. I want a certain angle on the camera also, so that will involve moving the cam path object and adjusting its scale. Adjusting the scale moves the camera in and out. I can quickly adjust all these objects and get the camera into position. Once you're happy, we can make this left side viewport full screen by pressing Ctrl plus space. Then press space and play the animation. This will be the position of the camera until the walls start appearing, and at that stage the camera will move in closer and start to rotate. That looks like a good starting position, so let's click back to previous and add some keyframes to store the camera location. We have three objects, the camera offset value, the cam path, and the cam target that we need to record. So select the cam path object first. Drag the scrubber to 1+14 and where we finished the roll control animation. Because this will be the start position for the path object, let's first press Ctrl plus A and apply all transforms here. That way, if this moves from position, we can zero it out. If you find a better start position later, just apply the location again. So press I, and this time we can add a location and scale keyframe here, as we need both location and scale values stored. Next, we can select the cam target object. Press I and add a location keyframe here also. Finally, we can select the camera. In the Object Constraints tab, we can click this Animate Property button to store this offset value at this frame. In this video, we start revealing the walls and ground floor. Let's get started. Now we can move the camera in close to start capturing the walls forming upwards. So select the cam path object. We can drag the scrubber onto 4 seconds and where we want this movement complete. Now press S and scale down the cam path object so the camera starts to frame the wall on the drawing. We'll adjust the rotation next. Press I and add a location and scale keyframe here. Select the camera next. In the Follow Path offset, rotate the camera around and square it up. We can click and store this value. We can also move the camera up, so select the cam target object. Press G, Z and drag this up and finish framing the camera view. Press I and store this location. I need to select the camera again and adjust the offset value to match the lines of the drawing. Now update that keyframe. So now if we start at the beginning and play this back, the plan rolls open. Then once open, the camera moves in close and ready for the walls to appear. Let's zoom in here and select the wall cutter object. The scrubber can be moved back to 4 seconds and where the movement will start from. Press I and add a location keyframe here. Then we can drag the scrubber forward to 7 seconds. Now press GZ and drag this up until the top of the ground floor walls are up. Don't go too high here, as we don't want the very top floor revealed at this stage. Instead, we'll use the floor cutter to reveal this section beneath the individual floors. So press I and store the location value here. Next, we can select the ground floor cutter. Drag the scrubber back to 4 seconds in the dope sheet. Press I and add a location keyframe here. Now we can move the scrubber onto 8 seconds. Then press GX and drag this in the -X direction and reveal the floor. Zoom in and make sure it's fully revealed here. We'll move the camera into position next to capture this movement across. Press I and add a location keyframe here. Next, we need to move the camera around. Our last keyframe is at 4 seconds, and from here the camera will rotate around to 14 seconds, doing a full 360 resolution. We can click and drag in the end field here and move the end frame out past 14 seconds. So let's move the scrubber out to 14 seconds. Then in the Constraints tab, use the offset to rotate the camera right around the house and back to about where it started. Then add a keyframe to store this value. If we drag the scrubber back along here, we should get a full resolution. The camera is probably a little close to the model in parts, so we can adjust its position as it rotates. First, let's select the cam path object. Click the Jump to Keyframe button to land on the last keyframe for this object. We will want the location and scale value for this object at frame 14, so click the top channel to select them all. Press Ctrl+C and copy. Then move the scrubber to frame 14. Press Ctrl+V and paste these here. We can update this value later for a better ending position, but this is a good starting point. Let's move the scrubber along here and find where the camera is closest to the model. About here around 10 seconds. Press S, Shift Z and exclude the Z axis from scale. Scale and move the camera straight out from this position. Then press I and add a location scale keyframe. So now if we drag forward, the camera will rotate around, keeping the building in frame until it comes back to rest at frame 14. In this video, we reveal the first floors and complete the walls. Let's get started. For the next part, we'll have the first floor reveal, but at the moment, the base of the first floor is part of the walls, and we need these part of the floors. So we can separate first, then join to the floors. So let's press numpad 1 for a front view. Press Z and switch to wireframe shading. Now tab into edit mode. We can press Ctrl+space and make this full screen. Now drag across the internal vertices between the ground and first floors. Press P and we can separate selection. Let's tab back now. If we select the wall cutter, press GZ and drag this up for the moment. That way we can select the object we just separated. Now let's click back to previous. In the modifiers tab, let's click and remove the modifier. We can join this next. Let's switch back to material preview. We need to select this first floor cutter. Press G and drag this away along the X-axis for a moment. That way we can select the object we separated. Shift select the floor. Press Ctrl+J and join into one. We also need to update the keyframes of the wall cutter, otherwise there will be a gap. So with it selected, let's move the scrubber back to 7 seconds and the last keyframe. In the scene we can press G, Z and snap to the bottom of the floor object. Now press I and update the location keyframe. Now we are ready to add keyframes to the first floor cutter object. So select this. In the X location, input 0 and put that back at the start position. Make sure the scrubber is back at 6 seconds and where this floor will begin to reveal. Press I and add a location keyframe. Then we can move the scrubber onto 10 seconds. This will match the speed of the ground floors. We can zoom over to the end of the ground floor cutter. That way we can press G, X and snap this over and match that position. Now press I and add a location keyframe. Now we can finish the walls up to their full height. So select the wall cutter object. Move the scrubber to 8 seconds. Press I and add a location keyframe here. Next, move the scrubber to 11 seconds. Then press G, Z and drag this up until the walls are fully revealed. Now press I and add a location keyframe. Then drag the scrubber back and forth and make sure everything looks as expected. We'll render a play blast or a low resolution test once everything is set up and make timing and position adjustments at that stage. But keep note of the things you'd like to change as we set this up. In this video, we reveal the roof, railings and windows. Let's get started. Now we can move on and reveal the roof and animate the balcony railings. So let's select the roof cutter object. Then move the scrubber to 10 seconds. Over the course of 4 seconds, the roof will reveal, so press I and add a location keyframe here. Now move the scrubber to 14 seconds. Then in the scene, press G, X and drag this across and reveal the roof. Make sure the roof is fully revealed at 14 seconds. Zoom in and make sure it's not too far past the roof either. Press I and add a location keyframe here. At the same time the roof is being revealed, we'll want the railings to start arriving and landing into position. So at 13 seconds, the railings will be in position. Let's switch to wireframe shading so we can see the empty object we set up to control the railings. These are at world origin. Drag select the 3 objects. If we press G, all 3 will come along. Right-click to cancel. With the scrubber at 13, we can press I and insert a location rotation keyframe for these. Let's move the scrubber back to 10 seconds. Then, if we zoom out in the scene, we can see this a little clearer. Press G, Z and drag these straight up and out of the camera view. If we press the period key in the outliner, you'll bring these objects into view. That way we can select them individually. In the pivot menu, make sure this is set to medium point. Then press R, Z and rotate each around so all 3 have a different orientation. We can also move the 2 outside railings away along the Y-axis. For the center one, let's move this along the X. So this also needs to travel back along the X-axis to get into position. Shift select all 3 now. Press I and add a location rotation keyframe here. We can press Z and switch to material preview in the scene. Then press the spacebar and give this a playback. It's playing back very slowly, but all 3 are moving back into position as the roof completes. We can also check if the railings are visible in another part of the shot by scrubbing back and forth and making sure they are not visible at any stage. That looks good. Let's reveal the doors and windows now. This will be over 2 stages and match the ground floor walls and first floor walls. So let's move the scrubber to 4 seconds. Select the door win cutter object. Press I and add a location keyframe here. We can move the scrubber on to 7 seconds. Then press G, Z and snap up to the top of the wall cutter. That way they move at the same rate. Press I and add a location keyframe. We can move the scrubber on to 8 seconds now. Press I and store this location keyframe. Now move the scrubber onto 11 seconds. Press G, Z and snap to the top of the wall cutter. Press I and add a location keyframe here. So now if we drag back and forth, the windows rise up at the same rate as the walls. Feel free to change how these are animated. We'll need to improve the camera view towards the end, but we'll do that in the next video. In this video, we continue to update the camera position. Let's get started. We have this end keyframe where the camera stops, and we can update this now so it better captures the roof and railings. So let's select the cam path object first. We can move the scrubber onto 14 seconds and the last keyframe for this object. Let's press S, Shift Z and scale this out on the X and Y axes. Then G, Z and drag down to get a better view of the objects. Press I and add a location scale keyframe. That's the first of two camera positions. As the grass rises and the external walls reveal, we'll move the camera down further so the tabletop is no longer visible. Now select the camera. In the Constraints tab, we can adjust the offset value and square up the camera view a little bit. I find aligning the lines of the texture with the outline of the camera one way to get it fairly straight. Update that keyframe once you're happy. So now we can drag back and forth and take a look as the camera moves around and rests in the new position. That looks better and it captures the railings moving into position. Now we need the camera's final position, so let's move the scrubber onto 15 seconds. Select the cam path object. Press G, Z and drag this down and get it roughly in position. Press I and add a location scale keyframe. This position will be updated if necessary when all the other objects have keyframes. Let's move the scrubber to 13 seconds. We can select the roll control object. Then Shift select the plan. This will move away over 2 seconds. So first, press I and store the location keyframe. Then we can move the scrubber onto 15 seconds. Press GX and drag the plan away to the left side and out of view. Then press I and store the new location. Over this time, the external walls will also reveal. So let's move back to 14 seconds. Select the external wall cutter. Press I and add a location keyframe. Then move the scrubber to 15 seconds. Now we can move the cutter back along the Y axis, so press G, Y and drag this back to reveal the wall. If you happen to get a glitchy result here, I can just leave this about halfway for the moment. Select the wall. In the Modifiers tab, change the solver to exact and fix any issues. Now drag this back and show the entire wall. Press I and add a location keyframe. So now, as the camera moves to the final position, everything gets into position very quickly. In this video, we animate the trees. Let's get started. Now we can start adding the trees to the scene. We'll do that two ways. The first will be similar to the balcony railings and move down onto the ground. The second will be more like growing trees where we'll scale them from 0 to a full size. Let's start with moving them into position. In the outliner, we can press the numpad- key and close these collections. Find the tree collection and switch it back on. Select the tree collection. Then in the scene, press Ctrl+H, and from here we can isolate this collection. Let's press Shift+S and put the cursor to World Origin. Press Shift+A and we can add an empty, plain axis. Let's press F2 and rename this empty_tree. Drag select everything now. The empty is still the active object and the lighter color. Press Ctrl+P and we can set parent to and keep transforms. So now if we select the empty and move it, the tree follows along. We can right click to cancel. In the outliner, we can switch back on the visibility of the animation, cutter and camera collections. In the scene, make sure the scrubber is close to the end of the animation so the external wall is visible. Then we can come into a top view. Press G and drag the tree to the back wall and position here. We can have these landing around 13 seconds so the camera will capture them fully. Maybe press S and scale this down a little. Let's move the scrubber to 13 seconds. Then press I and we can add a location, rotation and scale keyframe. Move the scrubber back to 11 seconds. Then press G, Z and drag up away from camera view. Press I and add a location, rotation, scale keyframe. So now, dragging this along, the trees come into view and come to rest at 13 seconds. Now I'll show you how to make a copy and update the keyframes. It's really similar to what we have been doing. So move the scrubber to 13 seconds. Press the period key in the outliner and jump to the empty. Select this and right-click and select Hierarchy. This selects all the child objects. Then in the scene, press Shift+D, X and drag this across here. Now press I and update the new location, rotation and scale values. Really the location. Now if we move the scrubber back to 11 seconds, both trees will be in the same location. So press GX and drag this away. We can also press RZ and rotate this around. Press I and update the keyframes now. So between videos, try add a few more trees. Even rotate and scale them on 13 seconds so they look a little bit different. Now we can have a tree grow from a scale of 0 up to whatever size we want. So let's move the scrubber onto 16 seconds. In the outliner we can select the empty and right-click and select Hierarchy. Press Shift+D, Shift-Z and drag this across to the right side of the house and position here. Probably best remove the keyframes, so in the dope sheet press X and delete keyframes. Then select just the empty. Press I and add a location, rotation, scale keyframe. Then move the scrubber back to 14 seconds. Press S, input 0 and enter. Press I and add a location, rotation, scale keyframe here. Now if we move the scrubber back and forth, the tree scales from 0 to full size. It's probably a little large and the branches are coming through the walls. So move the scrubber onto 16 seconds. Press S and scale down so it's not too large. Then press I and update the keyframes. I think the two back trees are coming in too early, so select each of the empties. Then with the keyframes highlighted, press G and drag these further along and have them arrive later, maybe 14 seconds. Repeat that for the second one, but don't move this as far forward and keep the timing slightly offset. In this video we animate the stairs and the grass moving into position. Let's get started. We can drag back towards the beginning of the animation and to where best to add the stairs. We have a Boolean object set up on this, or you can do something similar as the balcony railings. I think I'll subtract this with the cutter object. So move the scrubber to 4 seconds. Select the cutter and press I and add a location keyframe here. Then move the scrubber onto 6 seconds. Then press GZ and drag this up and reveal the stairs. Press I and add a location keyframe for 6 seconds. So now if we drag back and forth, the stairs is captured well in this camera view. Next, we can move the grass, tiles and rocks into position, so select the grass. In the modifiers tab, we can switch on the geometry nodes here. These were reduced in number earlier, so it's not too hard on the viewport. We can move the scrubber to 15 seconds and where these objects will come to rest. Press I and add a location keyframe here. Now let's move the scrubber back to 13 seconds. Let's press Z and switch to wireframe shading so we can see these objects. We can also come into a top view. Press GX and drag away off the tabletop, as this will be visible early in the animation. Press I and store the location. Let's drag the scrubber to about the 15-second mark. We can see from camera view here there is a gap between the plan and the ground. So let's close that up. Zoom into the edge of the plan. Press GX and drag the ground up close on the plan at this frame. Press I and add a location keyframe here. Check the scrubber as you may have to move the ground again as there will be more gaps. I can quickly check this and correct any gaps. Add a few more keyframes along here to remove that gap. This can be checked in the test render for any timing or gap issues. In this video, we begin adding assets from our asset library. Let's get started. Now we want to add furniture objects at different locations of the animation. For this example, we can use the cube diorama asset pack from the blender.org website. I covered setting this up in the asset browser lecture, so watch that if you haven't those assets linked in your preferences. I'm going to make some space here on the bottom right. Drag up and split the properties editor in two. Then we can switch this to an asset browser editor. Then from the drop down, select the cube diorama library. I'll demonstrate adding a desk to the scene, so I can find this in the list here. Now drag this into the scene. This will land in at 5 seconds, so move the scrubber to 5 seconds. We can also zero out the Z location field and sit this on the ground. Let's come into a top view. Drag this over and position inside the building. Press I and add a location keyframe here. Now we can come into a front view. Move the scrubber back to 3 seconds. Then in the scene, press GZ and drag this up and out of view. Press I and add a keyframe here. So now, if we drag along, the table lands into the building as the floor passes underneath. This will look much better with many different models landing into the house, and there are many available online for download. I'm sure by now you have an asset library. If not, I'd recommend starting one. If you don't have any more models, why not add more from the cube diorama file? I'm going to add a few more from my library, and I can do that before the next video. In this video, we render a viewport animation. Let's get started. At this stage, we have keyframes added to all the objects, but it's very hard to tell if the timings are okay. That's where viewport render animation will help. This will render exactly how the scene looks now, and each frame renders almost instantly, so it's very fast. We do need to set up how we want the animation to render, so open the Render Properties tab. Here we can change the file format from the default PNG to a video format FFmpeg. Then in the encoding area, change the container to MPEG-4. The default codecs will be fine here. Finally, in the output section, we need to choose a location. The default is the temp folder, but choose a location in your project folder. I can create and use this folder. Quickly give it a name. Usually you'll create tons of preview renders, so sequencing them to look back at the changes can be helpful. We can accept this location. In the right side, let's come into camera view. That way it will render this view. Make sure the frame range is close to the last keyframe, otherwise it will render unnecessary frames. I have this closed up about 16 seconds. Back in the view menu, we can come down and choose viewport render animation. This will take a few minutes, so I'll speed it up. With the rendering complete, I'll double click and play the video. That will play back at the full 24 frames per second and give you a good idea of the timing. So it's good to spend some time and study your own. Also, look out for any noticeable issues such as objects that shouldn't be visible or any artifacts. One issue you may encounter is a material showing as the boolean cuts through. I can close this window. If we select the wall and open the material tab, the first material listed will appear as the boolean cuts through. Select the color or material you'd like to be visible and use the arrow button to move first in the list. We can continue creating the animation in the next video. In this video, we set up Eevee. Let's get started. Hopefully, you've reviewed your viewport render and made the necessary changes, fixed any timing issues, and removed any artifacts from the render. I'd recommend rendering another viewport render after any changes to make sure everything is as expected. We're moving on to a full render, so it's important to have everything fixed at this stage. These renders take a long time, and you'll save yourself considerable time and heartbreak having all the issues ironed out before proceeding. Let's begin in the Render Properties tab. Blender has two render engines for final render, Eevee and Cycles. Eevee is Blender's real-time render engine, and Cycles is a physically based render engine. Eevee will give good results quickly. Cycles will give a more realistic result, but take more time to render each frame. If you plan on using Cycles for final render, then using Eevee is useful for testing. Let's look at Eevee first. The default sampling values work well, so no need to change these here. Settings such as ambient occlusion and screen space reflections will cost more in terms of time, but it won't be very noticeable as Eevee is very fast. Let's move down the bottom to color management. Here, the default uses AGX, but choose a preset to help improve the colors. Median high contrast, for example. Let's move on to the Output tab. The image resolution is 1920 by 1080 and more than what we need. These will produce HD images but take a great deal of time. Consider reducing the resolution to HD 1280 by 720. This will greatly reduce render time. Just update the values here if your computer takes too long per image. Next we have the end frame. My last keyframe is about 16 seconds, so the end frame can be set to 408 or 17 seconds. So update that end field value here. The end frame can be extended further in the video editor after rendering. Next we have the format. Rather than render a video straight from Blender, we can change this to PNG images. Images are easier work, especially if you have artifacts when rendering. You can simply render one particular frame again and fix any issues. Next, we can check the output folder. We can create a new folder in the project folder. Give the folder a name. This can be called House Animation. Now we can accept this. We can move the scrubber to about 13 seconds. Then press F12 and give this a quick test render. That will open a separate render window on screen and render the image, and I can speed this up. The time to complete the render will be displayed up top here. This is quite fast as it stands, but what will help is disabling the geometry nodes within the frame range. They will not be visible. This will result in rendering out the animation in two parts. The ground only starts to move across at the 13-second mark, so we only need to have that visible from then on. So let's set up the frame range to render the first part of this animation. Move the scrubber to 13 seconds and the first keyframe for the ground control. Then press the left arrow button to move back one frame to 311. This will be our end frame for the first part of the animation. So in the end frame, let's input 311. The grass will only be needed rendered from frame 312 to 17 seconds. So we will render that section when it's switched on later. So select the grass object. In the outliner, press the period key to bring this into view. We can switch off the disable in render icon here. In the modifiers tab, we can disable the geometry nodes modifier. Now press F12 again and give this another render. While this is only a small increase, it will be more noticeable when rendering with cycles. So it makes sense to render this animation in two stages. The first stage will be from frame 1 to 311, then the second stage from 312 to 408. The HDRI is rendering as the background, and that will be fine, so you can swap out the HDRI with another image if necessary. That's Eevee set up, and you are ready to come to the render menu and render animation. In the next video, we look at setting up cycles, and that's what I'll be using. We'll also set up the second stage of the frame range in the next video, so be sure to watch that. In this video, we set up and render with cycles. Let's get started. Next, we have the Cycles render engine, so in the Render Properties tab, switch to Render Engine here. Recent improvements to Cycles has considerably reduced render times and narrowed the gap between the two render engines. Cycles is a physically based renderer and will give you more realistic results. In the sampling section, we can reduce the max samples to 80. Blender have a denoising feature we can use to reduce the noise, so no real need to use a very high value. Increasing this will increase render times, and you can always increase it if you have the time to render. Let's press F12 and give this a quick render. This will take a lot longer than Eevee, but the render will be more accurate. I can speed this up. Using low samples can cause the image to be grainy in places. You can increase the samples to improve the render quality, but this increases render times. We can use the denoising feature, so switch to the Layers tab. In here, make sure denoising data is checked on. This will allow us to denoise the image in the compositor once rendered. So let's switch into the compositor. Check on Use Nodes up top here. Let's move the Render Layers node back a little. Press Shift+A and from Filters we can find and add the Denoise node. Drop that over the line and connect this up to the noisy image output. Now press F12 again and give this another render. I can speed this up. Denoising will clean up the image and we can see it has removed a great deal of noise. This node setup can be left in place when rendering the animation. Let's switch back to the Animation tab. Once you are happy with your test renders and there are no obvious issues, pick your render engine. I'm going to use Cycles, but use Eevee if that's what you want. I'm going to render the first frame section first. Then in the next video we can set up the second frame range and render the remaining, including the particles and geometry nodes modifier. One last thing is to select the plan. In the modifiers tab, apply the subdivision surface modifier so the edges of the plan are smooth in the final animation. So with that, let's come to the render menu and render animation. In this video we render the second section of frames, including the grass. Let's get started. Hopefully you have the first section rendered successfully. You should have a list of images in your output folder and we'll look at combining these in the next video. Right now we need to render the second section of animation. In the end frame, let's input 408. This will be the full length at 17 seconds. In the start frame we can input 312 here. Now the important part. In the outliner, let's find and click to include the grass object in render. Do that for the stone particle objects if you disabled that. Make sure the grass modifier is switched on in the modifiers tab. Then open the geometry nodes tab. We can increase the density value to 500 or more depending on how you want this to look. This will slow the viewport. You can try lowering value if you find your computer too sluggish. I'm going to reduce the Z scale to 0.1 as the particles are too high. Now we can switch back to the animation tab. In the outliner, we can disable the grass from view. This will help speed up your viewport and the grass will render. That way, if you need to test render the changes we made, the viewport will be responsive. We are now ready to render the remaining frames, so from the render menu, let's render animation. In the next video, we can take all the images and combine them in the video editor. In this video, we combine the images into the final video file. Let's get started. Now we are finished with this file, so make sure and save. Then we can come to File, New, and start a new video editing file. This is the video editor in Blender. On the bottom, we have the sequencer where you can add the media. Then the sequencer preview above this. We can add our rendered images. They get rendered in sequence based on the frame number, so from the Add menu, we can choose Image Sequence. Navigate to where you saved the images. Press A to select them all, and now add Image Strip. This strip extends beyond the end frame, so we can press the page up to jump to the end of the strip. Now press Ctrl+End and close this up. We can press GY and just drag this strip to about channel 3. Press the spacebar and play through and take a look. Check for any issues with the animation, any artifacts, bad timing or errors in general. If you come across any, you can remove any frame and re-render. Plus, by playing this right through saves to cache, so the next time you'll get the full 24 frame playback. So for example, if you see an issue with one of the frames here, frame 96 for example, the scrubber or playhead displays the image to the right side. So if you wanted to remove the image on screen, select the strip, press K to make a cut. Press the right arrow key to step forward one frame. Press K to make another cut. This image is now free, so select it and press X and delete. So if we press the left arrow key, we are missing frame 96. Then you can open back up the animation file and fix the issue, then re-render that frame. Save that image and add it back in here. We can press Ctrl+Z to undo before we cut that strip. Let's add an intro and outro, then render our video. Select it all. Press GX and drag the strip out to 2 seconds or 48 frames. Press Shift and the left arrow key and move the scrubber back to the beginning. Press Alt+A to deselect. Press Shift+A and from the Add menu we can add a color. Press GY and just drag this up. In the sidebar you can change the color, but black will be fine. We can also add a text object. Press Shift plus the left arrow just to make sure the scrubber is back at frame 1. Press Shift+A and from the Add menu add a text. We can move this up above so it's not hidden by the color. On the sidebar we can change the font type here. This will open to the fonts folder on your computer. If not, just navigate to that folder. It's C, Windows and Font on mine. You can change the view type to thumbnail to get a preview if it's not already set. This font here will do, so I can add this in. The panel here lets you change the size, color, position and many other properties. Let's update the text to House Animation. Increase the size to about 100. We can also increase the length of the text to 2 seconds. So grab the handle on the right, press GX and drag out to about 2 seconds and left click. Zoom in here and we can actually move it to the end of the image strip. Press Shift+S and snap to the scrubber. Now move the scrubber to 1 second. Over in the text properties, let's click and add a keyframe to the opacity value of 1. Press the page up a couple of times and come to the end of the strip. Now reduce the opacity to 0. Then add a keyframe. Click the scrubber back to the beginning. Reduce the opacity value to 0 and add a keyframe here. Next, we can add a cross between the color and the image strip. Select the color strip. Press Shift and select the image strip. Press Shift+A and from transition we can add a cross. Move this back to the start and give it a play. That looks fine, so let's move the scrubber past the end. Then press page down to snap to the end of the strip. Drag this forward 1 second. Press Shift+A and add a color strip. Select the image strip, then the color. Press Shift+A and add a cross. Press page up and snap to the end. Press Ctrl+End and close up the timeline. Press the spacebar and give this a playback. You can add more text to the end, but this will do for the finished video. Now we are ready to render the final video. So in the Properties editor, in Output, we can change the format to be FFmpeg video. In the encoding drop-down, we can set the container type. I usually change this to MPEG-4, as it's compatible with most platforms you might share on. The video codec can be left as default. If you are adding epic sound to the video, then select an audio codec from the list. AAC or MP3 works well. Finally, we need to select the output folder. This will be in my project folder, here in Final Video Output. Now accept. So now we are ready to render the finished video. So let's press Ctrl plus F12 and render animation. This will render very quickly and I can speed it up. I can open this off screen. This plays in my default video player VLC. It's free and very reliable. That's it complete, and hopefully you've enjoyed the course, and I look forward to seeing your final results and reading your feedback. In this video we covered downloading the free and open source software FreeCAD and also the installation process on a Windows system. Let's get started. To begin, we can find the free parametric 3D modeler FreeCAD online. In a web browser you can search FreeCAD. This software is available at FreeCADweb.org. You can read from the description, FreeCAD is a free and open source general purpose parametric 3D modeler. Let's open the website. From here, then open the Downloads page. FreeCAD is available for Windows, Mac and Linux. Installation is standard for each of the 3 operating systems. If you need further installation instructions, click into the wiki link. I'm going to install FreeCAD on Windows, so I can choose the 64-bit installer. That will automatically start the download and opens onto a donation page. The file will be saved to my download folder, so I can speed this up. Once downloaded, I can drag in the downloaded file. This is the FreeCAD installer.exe file. Double click and open this up to start the installation process. First up is the license agreement, so make sure and read this. I can click Next. Here you can choose what users are allowed to use the application. The default is fine for everyone using this computer, so Next. Here choose the installation location. The default location will be fine, so Next again. Here choose the components, file associations and desktop app. These are fine, so Next. Now choose the Start menu folder. Enter a name here or use the default and that will be fine, so I can click Next. That will work through and install FreeCAD, so I can speed this up. Now we can complete the install. Put a check mark and launch FreeCAD. Now click Finish. That opens FreeCAD to the Start workbench, so the installation has been successful. In this video, we open FreeCAD and take a look at the Start screen and the interface layout. Let's get started. We can continue where we left off in the last video, here in the Start workbench. In the Documents tab, you'll find the most recent files opened. There are none right now as this is a fresh install. Below are example files. These are great resources and will give you an idea of what can be created in FreeCAD. Let's open the file ArchDetail. Click once to open this up. When you open a FreeCAD file, they open as tabs along the bottom. This file has 2 tabs. We have the page view displaying the drawing, and the FreeCAD scene where the model is constructed. The dimensions are also included here. There are different ways of working in FreeCAD and we'll see another example during the course. We can close the file by clicking the X on both these tabs. That brings us back to the home page. The Help tab has extensive documentation on the different workbenches available in FreeCAD. There are links to forums where you can ask questions. You'll also find links to the manual and further information about using FreeCAD. Let's click back to the Documents tab. From here we can click New and create a new FreeCAD document. That will launch FreeCAD. The Start page is replaced with the 3D view. You can switch back and forth below using the tabs. The 3D view is where we add, draw and interact with objects within the scene. On the left side is the Combo view. This has 2 tabs, Model and Tasks. Unnamed here refers to the file name, and anything in the file gets listed beneath in what is called a tree view, and lists the saved contents of the file. Let's actually save the file before continuing, so come to the Save button up top here. Navigate somewhere and save the file. Probably best set up a project folder for the course and save all files in the same location. I've created a project folder for this course, and in here I'll create a new folder called FreeCAD Files. That way, in here all my FreeCAD files will be available. Give the file a name. The format will be .fcstd. Now save. The Tasks view displays the current tool or command properties. Back in the Model tab, an object's properties get displayed here. The Model tab is divided into two categories, View and Data. Object data and display properties are available here when an object is selected. Below this, the Report view will display information and any errors or warnings. The Report view has two tabs, the Report view itself and the Python console. Every command is executed using Python, and you can watch the results of that here. These panels can be resized if necessary. You can also undock them and place at other locations. Just hover on an area and a space will become available. You can also click the X and remove them. If you right-click here, the list of panels allows you add this combo view back. I can place this back on the top right of the viewport. You'll find the panel view in the View menu. Here, these panels can be enabled or disabled from here. Up top are the toolbars, giving you easy access to the common tools within each workbench. They can be repositioned by clicking and dragging them, similar to the panels. Then dock when you see the outline emerge. These can also be docked vertically along each side of the viewport. I'll leave this back for the moment. In the View menu, in Toolbars, switch them on and off from here. If we right-click below the panels, the toolbars are listed. In this video, we take a look at workbenches, toolbars, and macros. Let's get started. To begin, let's look at the Workbench drop-down. Workbenches provide you with different tool sets to help complete specific tasks within the application. The Arc Workbench provides BIM tools, parametric support, IFC, and 2D floor plan support. It does that using integration from the TechDraw Workbench. The Robot Workbench to simulate robot movement, or the Mesh Workbench to work with mesh objects. Let's open the Arc Workbench and take a look at the tools available here. The Arc Workbench is ideal for working with architectural elements. This workbench provides tools for BIM, parametric modeling, or drafting 2D floor plans. Once you switch workbenches, different tools become available specific to that workbench. The Arc Workbench has many toolbars, so you may need to reconfigure so all fit and are visible within the viewport. Any changes to the configuration will be saved in future. Let's look at the toolbars and the commands available in the Arc Workbench. The first toolbar is a standard file toolbar you'll find in most applications. It's where you can create a new document, open a file, save, copy, paste, and undo and redo commands, and a refresh button. Next is the Workbench toolbar, and beside this is the Macro toolbar. Macros are a series of instructions that perform a specific task, and you can record them using the red button here. You can also create them using Python code. The next toolbar here is the View toolbar. Fit all to the viewport or just fit selection to the viewport. Next, you can change the draw style of objects in the viewport. The toggle on and off an object's bounding box. Use the arrow buttons to move back and forth between previous selections. Then go to Linked Objects. Then sync your view to the selected object. The next button lets you switch to isometric. Then the next 6 buttons here let you switch between the different views. The first is Front. The icon graphically indicates the view. If you hover the cursor, you'll get a tooltip displaying the command, and below, the shortcut key listed. You also have top, right, rear, bottom, and left. The final tool here is Measure Distance. Moving across to the Structure toolbar, use this to make a new part, create groups, make links or make sublinks. Next is the Arc toolbar. These tools are used to create solid arc parametric elements within FreeCAD. Here you can draw walls and define the width and height, or use an existing line, wire or sketch to form the wall shape. The same is true for most of the other objects like the structure, roof or stairs. The other tools along here include defining a building or site, setting the levels and creating a schedule. You'll find a comprehensive set of 3D modeling tools within the Arc toolbar to help bring your sketches or designs to fully realized 3D models. Next up, we have the Draft Annotation toolbar. Use the Text tool to add a multi-line annotation to the drawing. You can also add a dimension to the drawing using the Dimension tool here. Next, the Label command displays a leader line and arrow with a multi-line text for labeling elements of the drawing. The final command here creates and loads custom styles. Change the font, type, size, line spacing, and a list of other properties for the drawing annotations. In this video, we look at navigating in FreeCAD. Let's get started. Before we move on to the Snap toolbar, let's look at navigation in FreeCAD. We'll be looking at some snapping examples, and it will be helpful being comfortable navigating around. In FreeCAD, the navigation type is controlled on the bottom right here. CAD is the default, or expand the list and choose one from here. If you have experience in one of the listed software, then you can use that configuration. Let's choose the Blender navigation type. To rotate in the scene, press the middle mouse button. It will be easier to see this if we enable the grid here. That way we can use the grid as reference when rotating. Pressing Ctrl and the middle mouse button zooms in and out. Pressing Shift and the middle mouse button pans the view. Maybe you'll prefer a different navigation setup, so you can try out the others from the list. To get the shortcuts for each, let's come to the Edit menu and down and open Preferences. Open the Display tab on the side here. Then up top, open the Navigation tab. Here, under Navigation, click the mouse button for the mouse button configuration. Each are listed for selection, panning, rotation, and zooming. Switch to CAD and find the button configuration here. For this course, I'll stick with Blender, but choose one that suits your style. Then you can set the orbit style, rotation mode, camera orientation, or zoom. Up top, the navigation cube refers to this in the top right corner here. This can be positioned using the corner settings or its size adjusted. We can click OK and close Preferences. This widget lets you click and switch into that view. Use the arrows and rotate in 45-degree intervals. From the drop-down, switch between orthographic, perspective, or isometric. Also, zoom to fit. It's a useful widget to reorientate yourself in the scene or get an axis reference. In this video, we look at the Snap menu in FreeCAD. Let's get started. Next, we can move back to the Snap menu. Snapping allows you accurately align and position objects in the scene. There are many different snap types available, each with a specific purpose. Clicking to highlight the snap element switches it on. It's best only enable the snap elements you may need, as having too many enabled can cause confusion. The first button on this toolbar is Lock All. Switching this off disables snapping. We can switch this back on and take a look at snapping in FreeCAD. Let's switch all these snap types off and just look at the first one here, Snap Endpoint. Let's switch into a top view for this example. Make sure the grid is switched on here. We can select the Line tool from the Draft Creation toolbar. Left click to place the first point. Then press and hold Shift so the line straightens and move the cursor across here. Then left click for a second point. The Snap Endpoint setting will allow us snap a new line to either endpoint of this line. So select the Line tool again. If we come close to the endpoint, a small circle appears over the endpoint with a small icon of the endpoint snap. So left click to snap to the endpoint of the line. Then drag away and click for the second point. There are some snap settings in preferences, so let's open this up. We can open the draft tab on the side here. Then across the top, open the grid and snapping tab. The first setting, always snap, activates snap automatically when hovering the cursor. Disabling this means you can use the control key to enable snap mode. Then the shift constraint, snap mode and alt mode keys can be changed from the drop downs. You can also display or hide the draft toolbar and after use. Let's click OK and close preferences. The remaining snap types work in a similar way, so the next one will snap to the midpoint of edges. The next is snap center and works on circle objects with circular edges. Next is snap angle. This snaps to points on a circular edge separated by 30 or 45 degrees. Snap intersection snaps to the intersection of two edges. This is reliant on the edges having been drawn on the same plane, and that's why the working plane setting is important. We'll be looking at how this works in the next video. Next is snap perpendicular, and snaps to the perpendicular points on faces and edges. Snaps into a perpendicular point on another edge. Snap extension allows you extend from another edge and snap aligned. Let's look at an example, so enable this snap setting. If we select the line tool, I can draw a couple of lines in here first. Now if we drag away from the end of this line, a dotted line appears and we can drag out along, extending from this edge. If we hover on this edge across here and drag up, this edge also extends out and we can snap to the intersection. Really useful snap setting. Next is parallel and lets you draw a parallel line to an existing line. Snap Special works with arc objects and provides additional snap points not ordinarily available to the other snap settings. Snap Near will snap to the nearest point along an edge or a face. Snap Ortho gives angle options of 45 degrees from the previous point. So with this active, we can select the line command. Click and place the first point. Now drag out about 45 and the snap icon will display, indicating the angle. So click for the second point. This is relative to the world coordinate system. Snap Grid snaps to the grid intersections. The grid spacings can be controlled from preferences. Open the draft tab, then grid and snapping. Here, grid spacing is currently 1 mm and controls the spacing. Also, the grid size can be controlled here also. We can close preferences. If you do update the grid properties, then update those changes by switching the grid on and off here. We can skip Snap Working Plane as I want to show an example in the next video. Snap Dimension shows a temporary dimension. So if we draw another line here, the dimension will show as we are creating it. Very useful when drafting. Then the final button is switching the grid on and off. We can look at the Snap Working Plane in the next video. In this video, we look at the working plane and how this can be used as a reference for creating and modifying objects. Let's get started. When we created the lines in the previous snapping example, these were listed in the tree view. If we select the first, then press Shift and select the last one, we can press Delete and remove them. Now we can look at Snap Working Plane and how it relates to the working plane in FreeCAD. The working plane is a reference plane used when creating and modifying objects. You can define the orientation an object will be created in relation to the 3D scene. We can click the current working plane button here and open up the properties. The working plane can be aligned to faces, vertices, or you can choose a preset plane from one of the following. Top will align the working plane to the XY plane of the coordinate system. Then front, side, align to view or automatic. Automatic will use your current view and align the working plane there. Then use the offset field to set a distance for the working plane. You can select an individual vertex in 3D space and then move the working plane to that position. The grid properties can be adjusted below by changing the spacing, amount, extension and snapping radius. Let's look at an example, so close this for a moment. We can come into a top view first. Then let's use the arc wall command here. Place the first point. Press Shift to straighten the line and drag across and place the second point. This gets drawn very large, so let's come to the Data tab. Let's update the height to be 10, the length to be 10, and the width to be 10. In FreeCAD, you need to click away for the changes to update. So now we have something we can see a bit clearer. If we wanted to add an object or draw on this face, we can first define this face and align the working plane. So select the face and click the working plane button. This updates to custom and the grid snaps to this face. Then anything we add will be aligned to this face. Let's click away and deselect the face. Open the working plane again. This time we'll use the side option here. We can now look at the snap working plane example. This will snap whatever we draw to the same plane as the working plane. Let's disable this first. Enable the endpoint snap. Also, let's come into a right view and align the working plane. Now select the line tool and hover on a corner, then snap here. Sometimes you may not see the line, but it will have the first point. Drag across the diagonal and snap to this side. If we rotate around, the line has snapped as expected and aligned with the face of the wall. Let's come back to a side view. This time, let's enable Snap Working Plane. Now select the Line tool and draw a line across diagonally from two opposite corners. This time, if we take a look, the line has snapped to the working plane. Working plane snap will snap whatever you are drawing to the working plane. For the snapping settings, I usually leave end and midpoint enabled, and enable additional when the need arises. In this video, we look at the draft modification toolbar. Let's get started. To begin, let's set the working plane to automatic. That way, the working plane will align automatically. In the model view, we can shift select these objects. Press delete and remove them. We can also come back into a top view. Sometimes if the grid doesn't update, you may need to switch the grid off and back on again, or reselect auto in the working plane menu. The first tool is move, so let's add an object to move. We can select the line tool again and draw a line across here. You can either select the object you want to move or the move tool first. So let's select the object first. Now select the Move tool. The Move tool works by first selecting a base point for reference. The Task tab appears with Move settings. The Local Value fields let you input the next points. You can set the length and the angle. Relative moves relative from the first point. Global are relative to global coordinates, or in the .2 release of FreeCAD, are relative to the working plane coordinates. Continue keeps the tool active until you check it off from the toolbar. Copy will make a duplicate of the selected object and move that. Modify sub-elements moves any selected sub-elements of the object instead of the whole object. So let's get the first reference point. So hover on the endpoint and snap here. When we do, the local fields are active and we can either move the edge and click to place or input the X, Y, Z values here. So let's input 10 and press enter. Input 10 for the Y and press enter. Then input 10 for the Z and press enter to complete. That will move the edge relative to the reference point we selected. Let's select the Move tool again. This time uncheck relative and check on global. Also check on copy. Select the base point. We can move this to world origin, so input 0 in the X, Y, Z fields. Now click Enter Point and move the edge to world origin. The shortcut to activate the Move tool is MV. The rotation tool works in a similar way. Select the reference point and where the edge will rotate around, its pivot. The properties need a base angle and we can input 0 and hit return. Now the rotation angle, so we can input 45 and press enter to complete. The shortcut for the rotation command is RO. The scale tool can scale an object up or down. Similar to the previous two, first choose a reference point. In the scale properties, input the XYZ factor. Here I can input 0.5 for all three. Then you have options for uniform scaling, working plane orientation, whether you want a copy of the object, modify sub-elements, or create a clone. You also have the option to pick 2 points in the scene to calculate the scale factor. Click OK to scale this down. Next up is the draft mirror. This command creates a mirrored copy of the selected object. If we wanted to mirror across the axis here, first get a reference point, this endpoint. Drag up and press the Shift key to straighten. Now click again and mirror the line. The mirrored line is now listed here. If we select the original line, any changes to the properties will change the mirrored line also. So if we come to the data tab below here and find the length field, change this value to 5. Then click away to update and both lines change. The mirrored line can be converted into its own object by using the draft downgrade and upgrade buttons on this toolbar here. That way the dependencies are removed. Now changing the original line length will not affect the mirrored line. Sometimes you will see the icon to recompute, so you will need to right click and recompute to update the changes. Next, the offset tool will offset a copy of the selected object or the object itself a given distance. The trimX tool trims or extends a selected object. Let's see an example, so I can first delete these objects from the scene. Now draw a couple more lines. Let's extend this line out beyond the vertical line first. Select the tool and straight away just drag either side of the line to extend. We can place this over here. Select the line again and activate the tool so we can trim this line. This time if we hover on the line it highlights and we can left click to trim at this edge. The stretch command can be used to stretch the selected points of an object. Next we have the clone tool. This creates a linked clone of the selected object. Updating the original will update the clone. Next are the array tools. Choose from the list here. Each has a specific purpose for arraying objects in certain formations and can be linked. Let's look at the first array type, draft ortho array. Using this type allows you array along the 3 axes. First, set the number of arrayed objects. We can set the Z to 2 here also. Then the XYZ intervals between each object. The defaults will be fine here. Checking on the fuse option will fuse any overlapping parts of the array. Link array creates the most efficient array. Click OK to create this. Zoom out and rotate around to view these. In this video, we continue looking at the draft modification toolbar. Let's get started. We can begin by deleting all the objects in the scene again. Come back to a top view now. Let's select the line tool and draw a line across here. Select this now and let's select the draft edit command. This places the selected object into draft edit mode where the nodes are highlighted and can be moved. Left click to select and drag to move. The properties dialog appears where you can update the location, length and angle properties, or just left click again to place. The next tool is sub-element highlight and selects the base object. Next is the join tool. Let's look at an example, so first delete the objects from the scene. Draw 2 lines with one endpoint of both at the same location. Select both over here. Now use the join command. This joins the draft lines into one object. This command also works on draft wires. If we wanted to split this line in 2, then use the draft split tool. Then you can either pick a point along the edge, or if we hover on the edge point where the 2 lines previously met, we can click and split it here. The next 2 commands are upgrade and downgrade. We saw an example earlier when converting a mirror object. You can also deconstruct solid objects or separate components. Next, you can convert draft wires to B-splines. If we select the draft wire tool and draw 3 lines randomly here. Now use this tool to convert this object to a B-spline. The original object can be deleted. Then enter Edit mode and modify the points of the spline. The next command, Draft2Sketch, will convert your draft object to a sketch object. This works the other way, converting the sketch to draft object. The next command, SetSlope. Let's delete all the objects in the scene first. Now come into a top view. The draft slope can slope lines and wires along the Z-axis. So let's select the draft wire tool and draw a line across here. Now select the tool. In the properties, we can input 0.1. Now click OK. We need to rotate around to see the slope. Actually, come into a front view. This rises all the points after the first on the Z-axis. 1 is equal to 45 degrees. You can also flatten lines, so select the tool again and input 0 to place flat on the Z-axis. The next command is Flip Dimension. We first need to add a dimension, so let's select the Dimension tool here. If the object is selected before using the tool, just drag away to get the distance. If the object wasn't selected, snap to the first and last endpoint. Then drag away for the third point, which will be the distance away from the line, and left click. The text will be small, so let's open the View tab for this dimension. Here, all the dimensions visual properties can be updated, but we just want to increase the font size to maybe 2. Now we can use the Flip Dimension command. Works on mirrored objects when the dimension gets flipped. The final command on this toolbar is the Shape 2D View command. This creates a 2D projection for the 2D shape. That was a quick look at the draft modification toolbar, and we can move on to the draft creation tools next. In this video, we'll look at the draft creation toolbar. Let's get started. We've touched on the draft modification toolbar during these videos, mostly using the line tool. We saw how you can create a straight line using this tool. This tool can also define the path of an arc wall, for example. The second tool along here is the polyline tool. A polyline are connected line segments that form one object. Let's come into a top view first. If we select this tool, we can left click and place the first point. The tool remains active, so click and place the second point. Let's add another point. Now a polyline can be left open or closed. To close it, hover the cursor on the first point here and the snap circle appears. Left click to close this up. This has created a shape with a face. Usually when working with 2D objects in FreeCAD, you'll disable the Create Face option. It's easier work with just the outline of objects. Individual objects can be controlled in the Data tab below here by simply changing the Make Face flag to false. To update that change in the Data tab, just click away. To globally change this Make Face setting for all objects, we can open Preferences. From here, open the Draft tab. We can uncheck this option here, Fill Objects with Faces whenever possible. Now click Apply. Click OK to update that change. That way, any objects we create will not have a face displayed when created, but you do still have the option in the Data tab to display a face. The Fillet tool works on draft lines. So let's draw 2 lines here. Make sure to snap to the end of the first. Now select both lines. Select the Fillet tool. The default value of 100 can sometimes be larger than the lines you try and fillet, and this can result in the operation failing. So let's input 3 for the fillet radius. Leaving Delete Original Objects unchecked will leave the original object in place. Create Chamfer will instead create a straight line in place of the rounded fillet. Press Enter to update the changes and create a rounded corner between our edges. The new fillet object gets listed in the Model tab. Next up is the Arc tool. There are 2 options here. The first is Arc, where you set the center, then the radius, finally the start and aperture angles. The second takes 3 points to define its size, a start, middle and end point, allowing you increase its circumference as you create it. Next up is the Circle tool. You can input a center or click to place. Then input a radius or drag out and place one manually. If yours has created a face, you may need to restart FreeCAD for the changes to take effect. Next, the ellipse tool draws a rectangle as the bounds for the ellipse. Then you can adjust the major and minor radii in the Data tab and change the properties of the ellipse. Next is the rectangle tool. Click for the first point or input the coordinates in the properties and press enter. Then place the second point or input the coordinates here. Next is the polygon tool. Start with the center point, then set the number of sides. Then either fillet or chamfer the polygon using the checkmark. Then drag to set the radius. In this video, we continue looking at the draft creation toolbar. Let's get started. To begin, let's select all the objects in the tree view here and delete them. Let's start back at the B-spline tool. With this tool, you select the exact points of the curve. The option lets you undo the last point placements, finish the curve and leave it open. Close the curve, wipe, and that's to undo back to the first point and set WP. This lets you adjust the working plane to the last point. After the curve is complete, you can use the edit button and adjust the position of the points. The next curve type is Bezier, with a cubic and Bezier type available from the drop-down. With the cubic type, click and drag to place your control points. Unlike the B-spline, you define the curvature with the placement of the control points. You do get the same options in the Task tab. The control points can be edited and repositioned after creation. With the Bezier type, click and place the control points and define the curvature of the spline. The points of the curve can also be edited after creation. Next is the point. This creates a point in 3D space and useful for reference when placing or snapping other objects. The draft face binder extrudes from selected faces. The draft shape string lets you create 3D text. First, choose a location. Enter the string or text. Set the height and choose the font type. Some formats that can be used include .ttf and .otf. Here, I can open a TTF file. Now click to create this. The text can then be extruded in the part workbench. Use the part extrude command here. The default values will be fine, so extrude this. We can switch back to the arc workbench. The final command is draft hatch. This allows you add a hatch pattern to a planar face. Let's use the rectangle tool and draw in a face here. We need to make sure the make face flag is set to true in the data tab below here. Now we can select the hatch command. This uses a .pat file. These are available online, but FreeCAD also provide one. On Windows, this can be found in Program Files, FreeCAD, Data, Mod, TechDraw and the PAT folder. On Mac, that's Applications, FreeCAD, then the rest. And on Linux, USR, Share, FreeCAD and the rest. I can add this in here. Select the pattern from the drop-down. Set the scale. This can be set to 1 to begin. The rotation is fine, so click OK and add the hatch to the face. In this video, we look at the draft tray tools. Let's get started. To begin, let's select all the objects in here and press delete to remove them. Next, we have the draft tray options. These include selecting the working plane, and we saw this in an earlier video. Setting style settings, construction mode and groups. We can skip the working plane and open the style settings. This lets you set up the style for new objects. You can load previous saved styles by loading preset. Click the Save Style button here and a dialog lets you name the style. You can apply the style settings to the selected objects or groups using Selected. Or clicking Text Dims will apply to all the draft text and draft dimensions in the scene. We can click Cancel to exit the style settings. The next button is Construction Mode. Construction mode is intended when setting out and creating construction lines or references. Usually these will not form part of the drawing, but are necessary in the drawing construction as guides and references. When construction mode gets enabled, a new folder gets created and stores the geometry inside. So if we switch on construction mode, now select the line tool and draw a line here. The construction folder gets created and the new line is stored inside. This is useful because once finished with the construction geometry, the folder can be hidden using space or deleted altogether along with all the objects inside. The last button here is called Auto Group, but with recent changes to FreeCAD, the group functionality is being replaced with layers. Layers are a way to organize and manage your objects. If we click here, we can create a new layer. This creates a draft layer container and inside a new layer. Any subsequent layers will get added inside the layer container. Objects such as the line can be dragged and placed inside this layer. When adding new objects to the scene, you may want them added to a specific layer. That involves making a layer active. If you right-click on a layer, you can use Activate this layer. Or click the Auto Group button. Just to note, if a layer is selected, it becomes active. Otherwise, if the file name is selected and you click here, you can choose the layer from the list. If you don't want a layer active, choose None. We can select the first layer. Also, toggle off construction mode. Now if we draw a line, this will get added into the active layer. Objects can be dragged into other layers, or back outside layers by dragging over the file name. Double-click lets you rename a layer. Right-click for additional options and you can select the layer's contents. In this video, we look at unit scale and setting up grid and snapping. Let's get started. To begin, we can come to File and New. Down below, we can close the previous file. Then come to File and Save. Navigate to a location to save the file. This can be renamed Building Plans. Now click Save. We are almost ready to start drafting, but there are a few more settings I need to cover first. We can come up to Edit and down here to Preferences. We begin in the General tab. Here in General, set your preferred language. Next, set the number of recent files available to choose from. The Style Sheet options let you change the default color scheme of FreeCAD. Select one from the list here. To update the changes, we can click OK. Then the changes will be applied to the viewport. Let's come back to Edit and open Backup Preferences. Find one you like here, but for this course, I can leave it at the default and switch this back to No Style Sheet. I'll click OK just to update that and come back into Preferences. Next, you can change the size of the toolbar icons. I can increase this to 32px. This should make it easier to catch what I've clicked on screen. Next, you can specify what workbench to open after startup. FreeCAD opens to the Start workbench by default, but if there was a workbench you regularly work in, then changing this will have FreeCAD open into that workbench. I can set this to Last. The other tabs across the top are packed with settings to help you customize FreeCAD even further. Next, let's come over to the Units tab. Here we can set the unit system to use. There are options for building Euro or building US. We can leave this set to default standard. We can increase the number of decimals to 4. We can skip the next few tabs. Import-Export we'll be looking at later when setting up the ODA converter. This is very important to the functionality of FreeCAD. Let's come down and open the Draft tab. Up top, switch into Grid and Snapping. Because we will be drafting a large object, we need to increase the grid spacing to something that better matches that scale. Here we can increase this to 1000 mm or 1 meter. With those changes, we can click Apply and OK. Sometimes you need to click on and off the grid to have that update and reflect the changes we made in Preferences. In this video, we take a look at drawing lines using coordinates and look at changing an object's properties. Let's get started. Now we can move on and start creating the ground floor layout. I can drag in this PDF file. This image is available in a resource as a PDF called GF Dimensions. Use this for dimension and layout reference. I'll be calling out dimensions as we draft the plan, so having this should aid you in that process. It's not essential you have it open, but it may help. To begin, we can make sure the working plane is set to auto. After changing the icon size, I needed to rearrange the toolbars here so everything was visible. Let's come into a top view. We're going to start with construction lines. These will be used for distance and positions. The construction folder can be hidden at the end of the process. So let's click and enable construction mode first. Now, any new object created will get added into the construction folder. That folder gets created as soon as we create something. We can select the line tool first. This opens the properties box. The line will be 3.2 meters long. We can start this at world origin, so in the X field, let's input 0. Notice if you move the cursor into the viewport, the global X field changes and updates to your cursor position. So be careful when entering coordinates, as it's easy to accidentally change these values. If you keep the cursor over the line properties, the values don't change. This time, let's keep the cursor over the properties and input 0 for the X and press enter. That opens the Y field, so input 0 for the Y coordinates. Press return and input 0 for the Z coordinate. Press return one more time to confirm these 3 coordinates. The properties box updates and expects the second coordinates of the line. If we drag away for a moment without clicking, the first point is at 0, 0, 0. So let's input the second coordinate points. Hover back over the properties. In the X, let's input 3200 and make sure there is an mm to specify millimeters and not meters. Then press return. Then we can input 0 in the Y and Z. At this stage, we could press return and complete the operation. Alternatively, in this scene, we can press X and that will specify the other 2 axes will be 0. Input 3200 mm for the length, making sure to remove any M suffix and then press enter. The construction group has been created and the line added inside. Select the line and below in the data tab we can make sure the length is indeed 3200 millimeters. This length value can be modified as it's a parametric object. Let's increase the line length to 5000. Then click away to update the viewport and the line length increases along the X-axis. If we expand the placement settings, we can update the angle to 90 and rotate this to align with the Y-axis. Next, inside placement, let's expand the position tab. In the position X axis field, input 1000 and move this forward along the X-axis. As we are seeing, you can use the object's data to modify an object's property after creation. In the View tab, there are properties associated with an object's visibility, color, width, or whether it's selectable or not. Let's use this line to get the second point of a rectangle. So open back up the Data Properties tab. Come back to the Placement tab and we can input 16,000 mm into the X location. You can specify the unit of metric in FreeCAD if necessary. So input an mm for millimeters or m for meters. So this would be 16 meters or 16,000 millimeters. Finally, in the length field, we can input 1000 mm. Now we have an endpoint here to snap onto. So from the toolbar, select the rectangle tool. This tool is similar to the line tool as you first input the start point, then the second point. For the first, we can input 0 for the X. Press return and input 0 for the Y. Press return and input 0 for the Z. Now for the second point. We can come over and hover the cursor near the endpoint. Make sure endpoint snapping is enabled on the toolbar here. When the small circle appears, you can click and snap to the endpoint. In this video, we take a look at changing line placement properties, the Draft Trimx tool and the Move and Copy tool. Let's get started. Let's begin with the rectangle object. The size of this object represents the overall length and width of the building. We can use the offset tool and form the wall thickness. So from the modification toolbar, select the offset tool. As we draw towards the rectangle, we get a preview of the offset. In the properties, we can check on copy. That way, the original rectangle remains in position and the new section is offset. In the distance field, we can input -300. We use minus to get this offset inside the rectangle. Now press return to complete the operation and create this offset. Next, we can start marking in the internal walls of the building. We can use this first line we created and reposition that. From the drawing, we can see the distance will be 4650 from the origin. So select the line and open the Data tab. Expand the Placement tab and the Position tab. In the X field, we can input 4650 mm to specify the unit. In the Y field, we can input 300 and move this up into position. Then let's come to the Length field. Here we could reduce the length by 600 and make this the exact inside length. However, let's use the Draft TrimX tool and reduce the length that way. So from the modification toolbar, we can select the Trim tool. Now come over and hover on the edge we want to trim back to. This edge highlights, and we can click anywhere along to specify the length. The line now gets trimmed back. If we select the line again, in the Data tab, the Length field has been updated to the new line length. Next, we can offset this line to the width of the internal wall of 150. So with the line selected, select the Offset tool. Make sure the copy flag is true. Now drag out, then input 150 and press return to confirm. Now we need the next two internal walls. These are at a distance from this point of 4900. Press Ctrl and select both these lines in the tree view. We can come up and choose the Move tool. In the Move properties, we can check on the Copy option, as we also want to duplicate both these lines. The next thing we need is a base point, so hover on the endpoint of the first line until the snap point highlights and select this. Then drag away, and if you follow along the x-axis at the same level as the point, notice how the x-axis locks. Now you can also press X to lock the x-axis. Input 4900 and press return to confirm. Next, we need another copy of these two lines over a distance of 2500. So we can select the Move tool again. Check on Copy so these get duplicated. Hover on the endpoint of the first line and select the base point as reference. Press X to lock in that axis. Input 2550 and enter. In this video, we take a look at using the Wire tool and construction mode. Let's get started. We can start with this line and use it to form the internal horizontal walls. So first, select the Move tool. In the properties, check on Copy. Notice here that the shortcut key is listed for each of the additional settings. Next, we can select the base point, drag away and press X to lock in this axis. Input 1000 and press Enter to place this here for a moment. If we come to the Data tab, we can expand the placement settings. Here we can input 0 for the rotation. Then for the Y location, we can input 6500. We can make this long enough to include two walls. So first, in the X position, we can input 6300. The length can then be increased, so input 10,900 here. Now we can select the Offset tool. Make sure Copy is checked on. Drag away and input 150 and enter. Next, we need two more lines a distance of 1200 down along the y-axis. Select both these lines by pressing Ctrl and adding to the selection. Select the Move tool and in the properties check on Copy. Select the base point first. Now if we drag away, press Y to lock in the axis. This will be a negative value, so input -1350 and enter. That's all the construction lines for the walls, so now we can start drawing in the actual building lines. Select these lines and drag them inside the construction folder. These were added outside as construction mode was switched off. Let's create a new layer. In the tree view, expand the Layers tab. Double-click and rename this Walls. If we click Auto Group, the selected layer will become active. Now any object created in the scene will get added to the wall collection. We can use this draft wire tool and start tracing over the construction lines. Let's zoom into the first vertical line here. We can start at the top point, so click here, then drag down. Now this wall extrudes down 100 millimeters past this point of the wall here. Press Y to lock in the axis. Then hover on the endpoint to get the first distance and left click. Now we need to draw down 100 along the negative Y, so input -100 and enter. Next, we need to change the axis, so press X and drag across. While in the tool, we can press S to activate the snap menu. Here, switch on perpendicular. Now snap across. Next, we need to change the axis back, so press Y and drag up and snap to the top here. We can press Escape to exit the tool. Next, we can copy this wire object along here. Select the Move tool. Then check on Copy over here. Now get a base point to reference. Drag across and press X to lock the axis. Now select the first edge here to snap onto. If we select the construction folder, we can press the spacebar to hide the objects inside and check we have what we expected. That looks good, so press the spacebar again to unhide. We can now create the bottom sections to match the top. So select the wire tool again. Select the second point on the bottom to get the base point. Now drag up and press Y to lock in the axis. We can hover on this endpoint and get the distance. Drag up and input 100 and enter. Press X to change direction and snap this across. Now press Y and snap this back down here. Press Escape to exit. Next, we can make a copy, so select the Move tool. Check on Copy and get the base point. Drag across and press X to lock in the axis. Now snap into position. Next, we can select the Line tool. Draw the two lines from the top to the bottom and finish off the walls here. When you are done, hide the construction folder and check everything is correct. That looks good. To finish this, we can mark in the external walls. Select the Line tool again. Click on the endpoint and start tracing around this outer one. Press LI to activate the Line tool and continue working around. Snap to each endpoint around the perimeter. Click back to the start to finish. We can select the Line tool again and this time trace around the inner line. We can avoid crossing the internal walls so that the walls will look connected as they should in a drawing. So click up to and start the next line after these. Repeat this all the way around and mark in these lines. On the right side, we can actually cross this upper line as the internal wall won't connect here. Finish this by drawing back at the start. In the tree view, we can hide the construction folder and check everything looks correct. That looks good. We can add in the vertical lines in the next video. In this video, we continue drafting the internal walls. Let's get started. Let's begin and start adding the horizontal lines. We can start with the Line tool. Then on the right side, get the endpoint here and draw a line across. Press X to lock the axis, then hover down here to get the distance and snap. Repeat that for the second line underneath and draw this across here. We can then select the vertical line and press Delete to remove it. Next, select the Line tool and draw two new lines, one on top and connect there, then a second to connect below. Now we can use the Line tool and there is an endpoint here. We can start the line. Press X and lock this, then hover and snap to get the length. We can repeat that for the line below on the opposite side of the hallway. Next, both these need to be offset by 150. Select the top line. Now the offset tool. We can drag up from the line. Input 150 and press enter. Repeat that for the lower line. Select the offset tool. Then drag away and input 150 to offset. We created these sections using the wire tool, and the easiest way will be to draw lines over these objects, then delete them. So select the line tool and start tracing over this shape. All the way around. Just skip crossing the joining wall. Finish this. We can then find the wire objects in the walls folder. Press delete and remove it. We should be left with the lines formed like this. The same can be repeated for the remaining walls. Try get that done before the next video and we can move on to marking in the windows. In this video, we take a look at midpoint snapping and rotating objects. Let's get started. Let's click on Auto Group here and create a new layer. In the tree view, double-click and rename this layer to Windows. With this layer selected, we can click Auto Group again and the selected layer will become active. We can start on the bottom right side and mark the position of the first window. Let's actually switch on construction mode first. Now select the line tool. This first line will be 1575 up from this corner. Hover here and in the x-axis on the line properties 16 is displayed. We can press return to accept this. Be careful not to move the cursor or the values will change. After you press return, the Y field is active, so we can input 1575 mm. Make sure to use mm and not m after this value. It can sometimes switch to meters, so you need to be careful. Press return again and then in the Z we can input 0 and press return again. If we move the cursor now, the first point of the line is in position. Drag across and snap to the inside line on the bottom here and finish this line. Next we can select this line. Then up top, select the offset tool. Drag up and get the line preview. We can input 2000 here. We are finished with construction mode right now, so we can switch this off. Notice how the construction folder is hidden, but the two construction lines are visible. We just need to select the folder and press the spacebar to unhide and hide again, but we could wait until we draw in the rectangle first. Select this tool. Now hover the cursor and get the first point and add this here. Drag up and snap to the second point and draw the rectangle shape. We can select the construction folder now and press the spacebar 2 times to hide these two construction lines. On the snap menu, we can enable midpoint snap. Now select the line tool. We can draw a line from the midpoint to the midpoint and finish marking in this window. Next, we want to copy both these objects, so select these in the tree view. Now select the Move tool. In the properties, check on Copy. We can hover and get the snap midpoint here. Drag up and snap this to the same midpoint up top. Now we can select the outside and the two inside lines this side and delete them. We can draw in lines that only connect to the windows and don't overlap. Select the line tool and draw lines from endpoint to endpoint. This will make modeling in Blender easier. The shortcut LI works well here and saves time with back and forth to the toolbar. There is another window the same dimension on the top right here. So we can make a duplicate of one window, rotate and snap into position. So expand the window folder. Select one rectangle and one line and make sure both are already a unit. Then we can select the Move tool. Check on Copy. Select the base point and drag this away. Press Shift+B and drag a selection to select these again. This time we can select the Rotate tool. For the first point we can select the bottom corner. This next point is the base angle, so we can drag straight up and snap to the opposite corner. Now for the rotation, press Shift and snap this to 90 and left click, or input 90 and press Return. Now select the Move tool again. You can use the midpoint snap. Now snap this to the center of the wall. In this video, we take a look at changing the length properties of an object, and we use the draft wire to mark the large window. Let's get started. The next window will be center of this wall here and 3000 in length. Let's Shift select the last two objects we copied. Now select the Move tool. Check on Copy here. Select the base point, then move this away here first. Now if we select the rectangle in the tree view, down below in the height field, as this was rotated, we can input 3000. We can repeat that for the line and increase the length here to 3000. Now select both objects again. Select the Move tool. Select the midpoint as the base and snap this into position. There is also a window 3000 in length below here. So select both these objects again and make another copy. Select the midpoint and press Y to lock in this axis. That way we can snap down to the correct level. On the left side of the building, there is a large window running around into 3700 from the end. We can draw this in now. Let's switch back on construction mode. Select the line tool and we can hover below here. In the X field, we can input 3700 and press enter. That's the first point, so drag up and press Y to lock the axis. Now snap up to the height. We can select this line now. Then select the Move tool. Make sure and check on Copy. Select the base point and drag up. Press Y, then snap this into position. Select the Line tool again and we can draw two diagonal lines across the corners. Draw these bottom and top. Let's switch off construction mode. Select the Wire tool and start tracing the window shape around here. Always best zoom in close on short lines to make sure it is actually snapping to the correct point. Trace this all around and snap back to the first point to complete the closed wire. Finally, we can select the Line tool again. Now snap to the endpoint of the lines and just define this as a window. With that complete, we can select the construction folder and press the spacebar twice and switch the lines off. The final step is to select any lines that are overlapping. So that's these two up top and the two down below here. Control select these. Now press Delete and remove them. If any construction lines are outside like here, make sure they are inside the construction folder. Then unhide and hide again. Now select the Line tool and work around and draw these wall lines back to connect up. I can quickly work around and connect these up. These were added to the window layer, so I can select these first. Now add them into the wall layer and tidy this up. In this video, we take a look at using the Arc tool and rotating objects. Let's get started. Before we move on and start creating the doors, there is a wire object in the Windows layer. Delete any and draw in lines to replace them. I can quickly draw these back in here. We can start with the front door of the building. Rather than draw this in place, let's draw it independently first, then move it into position. First, we can create a new layer. Then let's rename this Doors. With it selected, click Auto Group and make this the active layer. Now we can select the rectangle tool. Click anywhere for the first point. For the dimensions, we can input 1200 for the X and press return. Input 300 for the Y and press return, and input 0 for the Z and press return. Select the line tool now. Snap to the endpoint first. This will represent the door open. Drag up and press Y. Input 1200 and press enter. Next, we can come up and select the arc tool. We first need to define the center of this arc, so click and select the endpoint. The next input is the radius. We can input 600 or come to this endpoint and select this. Next, the start angle, so we can click the same point as this will be the start. Now come down around and select the aperture angle or this second endpoint. In the tree view, select the three objects that make up this door. Select the Move tool and get the base point. Now snap this up into position. We can then select any overlapping lines and delete these. Then use the Line tool and draw lines to connect back up. The back doorway is the same size, so select the door objects. Then select the Move tool. Check on Copy over here first. Select the base point and then snap this up. These will need to be rotated 180. Let's select the Line tool and draw a line midpoint to midpoint on the doorway. This will help us rotate 180 degrees. So select them again. Now select the Rotation tool. Select the center point. Drag to the end and pick this second point. Input 180 and enter. We can now select the center line. Press delete and delete the temporary line. To finish this, select the overlapping lines. Now draw back inlines connecting this up. In this video, we make modifications to the door object and create the internal doors. We use the mirror tool during this process. Let's get started. Let's select the three objects that make up the lower door. Select the Move tool. Now check on Copy. Choose a base point and move this away into some space. The internal doors will be narrower, so we can make the necessary adjustments and reduce this object to fit. In the tree view, select the rectangle object first. In the Data tab, the height can be reduced to 150. Then the length can be reduced to 1000. Update those changes by clicking into the scene. Next, we can select the line. Change the length to 1000 also. Click away and update this change. Finally, we can select the arc object. Here in the radius field, we can input 1000 and update this. The rectangle needs to be repositioned, so select it. Now the Move tool. Select the corner point and snap this back into position. Select all three objects in the 3 view. Press MV for the Move tool. Select the corner base point. Now snap this to the inner point of the wall up here. This will be 150 from the wall along the X-axis. This will be a negative value, so select these again and press M and V. Select the base point. Press X to lock in that axis and input -150 and enter. Next, we need a door on the opposite wall. This time, we can use the Mirror tool. We will need a center point to use when mirroring, so select the Line tool. Now draw a line between the 2 points of this wall here. Select the 3 objects of the door in the tree view. We can come up and select the Mirror tool. First, select the center point of the new line. Drag away and press X to lock in this axis, then click again. That has created 3 mirrored objects in the tree view. One feature to note is that if we select this original line here, then in the Data tab we can modify the length. So we can input 2000. The mirrored line will also update as this is linked to the original. We can select this line again and input 1000 back here. We need 3 more smaller internal doors marked in here. So select the 3 mirrored objects. Select the Move tool and check on Copy. Select the base point and just leave this to the side. Repeat that again and make another copy. And now make another copy and place this over here. We can start with the bottom door. Press Shift+B and drag a selection. Press R and O for the Rotate tool. Select the first point and now the second on the same plane. Input the rotation value, or you can press Shift and this snaps to increments. This looks to be about 270, so left click to confirm. We can quickly rotate the remaining 2 into the correct orientation using the same method. These will both be 90 degrees, so get these rotated. Finally, the top and bottom door need to be moved 150 away from the wall. We can start with the bottom one. Select the 3 objects. Press MV for the Move tool. Select the base point first. Drag up and press Y. Input 150 and enter. We can repeat that process for the top door. Select the 3 parts of this door. Press MV. Then this will be moved in the negative Y direction, so for the distance input -150 and enter. For the final door, select it. This time move it up along the Y-axis by 1850. Now there are 2 things left to complete. The first is one final door on this wall here. This is an external door from the garage. It's the same size as the external doors, except the rectangle needs to be 150 to match the width of the wall. It's also 650 from this wall here. Your challenge is to make a duplicate of the external door, modify and fit this into the wall. The second task is to remove any overlapping lines over the doors and draw in connecting lines. We can also remove this temporary line here. I can complete this before the next video, so try get that completed. In this video, we take a look at changing the line draw style and changing the line thickness of multiple objects. Let's get started. Hopefully you have gotten the doorway duplicated, modified and into position. The final door we need to mark in is the garage door. Then we can modify the style of both the doors and windows. Let's start with the line tool. For the first point, click the upper line as this sits center of the garage walls. Press Y and snap down the distance. Select the line now and we can use the offset tool. Drag to one side and input 1500 and press enter. Select the center line again. Activate the tool again by pressing O and S. Drag and input 1500 and enter. Careful not to adjust the line position as the value is overwritten. We can delete the center line. Now we can also delete the overlapping lines and draw back in the new lines to connect up. I can quickly draw these in here. Now we can look at changing the line style of the windows and doors to differentiate them and have them stand out a little more. Let's start with the window lines. We can select both the inside and outside lines. Press Ctrl and add to the selection. You want to make sure there are no overlapping lines as this style will only be applied to the windows and not the walls. With all these window lines selected, let's open the View tab. Here, we're looking for the line width property. Change this to 1 and reduce the thickness of the line. Click away to update the selection. We can do the same thing with the inside and outside door lines. Select each of these. Careful when selecting, as a double click can sometimes deselect everything. With these selected, we can input 1 in the line width field. Click away and update those changes. Finally, let's select all the door arcs. Quickly add these to the selection. In this case, let's change the draw style. So from the drop down, we can choose dashed, but feel free to pick the style you want. Very useful being able to change all objects selected and not just individually selected objects. In this video, we take a look at arraying an object. Let's get started. We can begin and select the rectangle tool. We can click anywhere for the first point. For the length along the x-axis, we can input 1000. Press enter and input 350 for the y-axis. The z will be 0, so press enter and finish this. With it selected, we can select the move tool. Select the base point. Now move this to the inside corner of the wall here. The stairs will start 1420 away from this wall. So select the move tool again. Select the base point and drag away. Press Y to lock in this axis. This is moving in the negative Y direction, so input -1420 and enter. Rather than duplicating this object multiple times, we can use the array tool. With the rectangle selected, we can select the array tool here. That opens the array properties. We will be arraying this along the y-axis. So in the Y field, for the number of elements, we can input 13. In the X intervals, input 0 for the X, Y, Z fields here. Then in the Y intervals, this will be the same width as the steps themselves. So input -350 in the Y field. Because we want to array along the negative Y direction, make sure and add that minus symbol. That's it, so we can click OK to complete. In the tree view, an array folder has been created and inside is the original rectangle object set to hidden. In this video, we take a look at where to get the ODA file converter and how to link the application inside FreeCAD. Let's get started. Before we move on to importing furniture objects, it can be convenient to use CAD blocks from other sources. These are common drawing elements such as tables, chairs, or drawing symbols. Rather than drafting these yourself, they can be found online and added to your project. CAD blocks are commonly available in DWG or DXF format. To import these files into FreeCAD, an external application needs to be linked to convert the file. This application is called the ODA file converter. In a web browser, I have typed in DWG FreeCAD. Here we can click into the freecad.org wiki page. This explains about DWG file use within FreeCAD, including what you need to be able to import DWG files. The converter information is here and called the ODA converter. We can right-click here and open a new tab. Now open this page. This is a standalone application that's available for Windows, Mac and Linux. It's straightforward to download and install. I have this installed on my system. So have a read about the application, then download and install it. When you have that downloaded and installed, we can open back up our FreeCAD project where we can link the ODA converter. We can come up to Edit and open the Preferences tab. In the Import/Export section here, we can open the DWG tab. This is where we can link a path to that ODA file converter we have installed on our system. So make sure you have installed the application on your computer so it can be linked here. So once you have it installed, we can click this File Path button. Then navigate to where it was installed on your system. In my case, this is Windows, so it's in my program files. It's here in a folder called ODA File Converter. Here we can link the .exe file. So select it. This is the ODA executable, and when it's selected, we can click Open. This now makes the application available to FreeCAD. This will work in the background when working with DWG files in FreeCAD. We can also open the DXF tab. Here we can put a check mark in Allow FreeCAD to automatically download and update the DXF libraries. When we are done, we can click OK. So now if you were to use CAD blocks, just come to File and Import. Then navigate to the CAD blocks and import. The ODA converter will work in the background. The ODA converter is a standalone application, so you can use this outside of FreeCAD to convert files. In the next video, we can import some furniture assets for our drawing, but feel free to add in CAD blocks yourself. In this video, we take a look at adding in DXF files and storing these inside groups. Let's get started. In the resource folder of the course, there is an asset folder. If you haven't downloaded that folder yet, now is the time, as we are ready to import the furniture elements. It's a compressed file, so make sure and unzip the folder. First, we can create a new layer. Now double-click and rename this furniture. We can make this active, but when importing objects, they get added outside layers. Imports also get imported in a great number of shapes, so we can try organize these by using groups. The benefit of groups is they can be stored inside layers, whereas layers cannot. So if we right-click on the drawing name, and from here, create a group. Double-click and rename this Bat. Then drag and drop this inside the furniture layer. This will help keep the tree view clean and easy to manage the furniture elements. Now we can come to File and down to Import. Navigate to where you have downloaded and unzip the asset folder. Find the furniture folder, and inside we can select the Bat file. Then click Open and add it into the drawing. When this gets added, it does as a collection of shapes. We can select the first, come down to the last one and press Shift and select this. Then on the modification menu, we can choose Upgrade. This will upgrade these shapes to more complex objects and reduces the number. This converts the shapes to wire. So now we can select all of these, then drag and drop these into the Bat folder. We can zoom in and see the Bat has been added into position. That will be the process and something you can manage between videos. But let's do one more before moving on. So let's create a new group. Double click and rename this Car and press Enter. Then drag and drop this into the furniture layer, because a car is really just a piece of furniture. Now come to File and Import. We can select the car now and add this in here. Select all the shape objects. Now upgrade the parts. These can be moved into the car folder. That will be the process of adding in the remaining assets. I can continue this between videos, so try get this task completed before the next video. In this video, we take a look at adding dimensions to the drawing and how to configure the dimension settings. Let's get started. Let's continue and add dimensions to our drawing. There are different methods when adding dimensions within FreeCAD, and I find this method pretty straightforward for 2D layouts. To begin, in the tree view, we can create a new layer. These can be renamed dimensions. So now we can come over and select the dimension tool and make it active. Make sure the endpoint snap is active. It can sometimes be helpful switch off some of the other snap options and just leave on endpoint. The first dimension we want is the distance of the return window here. So on the very corner, snap to an endpoint. Then up to the wall here. When placing these dimensions, they should be placed a set distance from the line. This first one will be 500 from the line, so we can press Y to lock in that axis. Then input 500 and enter. That places the dimension here, but before we can see it, we will need to make some modifications to its properties. Select this and we can open the View tab. The first setting is the arrow type. Choose one from the list, but I can change this to arrow. Then above in the arrow size, increase this to something like 50. This can be adjusted at any time. Let's move down a little and look for the font size. Here we can increase this to 300. The next setting we can adjust is the extension line. Input 300 here and have the extension line indicate the start and end of this dimension. We can also input 300 in the extension overshoot and have the line display both sides of the dimension line. Next, we can come down to the unit area. Here you can choose to show the unit suffix. Here this is displayed as millimeter. We can set this to false and switch this off. In the decimals drop-down, we can reduce the precision to 0 and remove anything past the decimal point. We can also move the text up off the dimension line, so this is easier read. That is controlled here in the text spacing field. Here we can input 100 and add the suffix mm to specify millimeters. They are some of the more common dimension settings to change. If you added multiple dimensions, it's possible to select them all and change the settings at once. Another option is to set the dimension settings in preferences first. That way you may only need to change individual settings. Let's take a look, so come to Edit and open Preferences. Here we can open the Draft tab. Now open Texts and Dimensions. We can start with the font size. Increase this to 300. This will use millimeter by default. We can leave the display mode to text above. The 3D option works well for 3D models. We can reduce the decimals to 0 and match the existing dimensions. For the extension line size, increase this to 300. Then for the extension line overshoot, we can increase this to 300. For the arrow style, this can be changed to arrow. Then increase the size to 50. For the text spacing, increase this to 100. Finally, uncheck Show Unit Suffix. We can click OK to save these changes. Now we can select the dimension tool again and get the length of this wall section here. Press Y to lock in that axis. Input 500 and enter. Let's use the dimension tool again, and this time we want the full length of the wall. Get the first point and then the second. Press Y, and this time we want this dimension above the first and also evenly spaced, so we can input 1000 here and press enter. This time the decimal value can be increased because this is displaying meters. So increase this to 3 in the View tab. Let's select the dimension tool again. This time we can get the full length of the building. Snap to the first point, then the second. Press Y. This time input 1500 and move this out beyond the last dimension. This will also need the decimal value increased to 3. I'm going to continue around and add in more dimensions around the drawing. Try work around and mark these in and also on the side. Adding dimensions along the vertical will be the same, just make sure and specify the x-axis whether positive or negative. When you do get those added, make sure and add the dimensions into the dimensions layer in the node tree. In this video, we take a look at how to add text in FreeCAD. Let's get started. To add text in FreeCAD, we can come back to the Draft Annotation toolbar. This first command here creates a text object. Let's actually create a new layer first. Rename this Text. Now make it the active layer and we can click to add a text object. We can click to place the text object in what will be the living room. This opens the properties, so let's add the text. Name this living room. In the View tab, you have some text properties if you need to adjust these. To use the label object, we can first select the first point, then the second as a leader line and the third. The label text can be changed in the Data tab. Here in the label area, update the text between the square brackets. You don't need to remove the square brackets, just replace the text. This can read external render. I'm going to add a few more text objects to indicate the different rooms. Try work around and add some text before the next video. In this video, we take a look at how to add a page template, how to insert the drawing into a drawing sheet, and how to export to PDF. Let's get started. There are different methods to display your drawing in FreeCAD. For this example, we will use a section plane. A section plane can be used to cut through a model and create elevations and sections. In our case, any object selected when creating the section plane will be visible within the layout. In the current version of FreeCAD, that involves expanding all the layers. In older versions, you only needed to select the group, but currently we will need to work down along and expand every group and layer. Then, starting at the top, we can select layers. We don't need to include the construction folder. Press Shift and come right down to the bottom. Select the last object here. That's everything we want included in the layouts selected. So with everything selected, we can come up to the Arc menu and come down and select Section Plane. Here we can see a plane has been added and it's also listed in the tree view. Next, we need to switch workbenches. So from the Workbench menu, we can switch into the TechDraw workbench. This workbench has some options for creating sheets. We can first use this option here and use a template to insert a page. So click this folder icon. This will open up into the FreeCAD templates folder that comes with the application. In here, we can choose a landscape ENM52 and open this up. That creates a new page, and you can toggle back and forth between the new page and the drawing below here. The information on the sheet can be updated by clicking on the green boxes and updating the field from the dialog box. I can cancel this. Now let's get our drawing displayed on this page. We can expand the page group first, as the new view will be added to the page group. Make sure the section is selected for this option here that inserts a view of a section plane from Arc Workbench. Click this and add the new view. Now this gets added very large and we will need to adjust its scale to fit the sheet. So first, select the Arc view and come down to the Data tab. We need to reduce the scale, so in here we can input 0.015. Then click away to update. This is not getting displayed correctly, so in the line width we can increase this to 0.5 or a value that displays correctly for your sheet. Click away to update. When you have the Arc view selected, it's possible to move and center up on the sheet. The name Arc view on the sheet can be changed by renaming the view in tree view here. We can rename this top view, for example, and that will update on the page. When you have the drawing sheet complete, you might want to print or export as a PDF. To export as a PDF, come to File and down and choose Export PDF. In my project folder, I can create a new folder. Rename this PDF. Double click inside. Give the PDF a name. I can call this House Drawing. Now save the file. I can open this up off screen and drag this in. That's the drawing complete and very easy export from FreeCAD. In this video, we take a look at exporting the DXF file. Let's get started. When exporting from FreeCAD, we need to select all the objects we want to export. This has been a recent change and may change again in the future. Previously, only selecting the group was sufficient when exporting from FreeCAD. In the tree view, we can take a look at what we will be exporting first. The construction folder will not be exported. The dimensions won't be exported either. Let's select the dimensions group and press the spacebar to hide them. Close the layer. The text we can export and bring these into Blender. The section object we can select and press the spacebar to hide this. All the groups and layers are expanded from the dimensions lecture, so we can start below here. Shift select the last array object, then drag the slider and come to the very top. Now Shift select the first object. In the scene, everything that will be exported will get highlighted. Now we can come up to File and down and choose Export. In my project folder, I'm going to create a new folder. Rename this DXF. Double click inside. We can call this house_drawing. From the drop down, there are many file types to export to, and we can look for and choose the DXF 2D format. Now click Save. That's it for FreeCAD. Well done for completing the drawings. Don't worry if you haven't, I'll make my file available when we get to the lecture of importing to Blender. If you have skipped the Blender section to complete this CAD section, then head back to the Blender Introduction series and continue from there. In those videos, we'll get set up in Blender. Then there will be a series of introduction videos so you can get a feel for the software. Included after these are some challenges to solve that should keep you on your toes.